Welcome to the Amazon AWS Masterclass for Complete Beginners. This course is for complete beginners and even those that have some experience already. And regardless of if you have no experience, a little bit of experience, maybe a little bit more advanced, you're still going to learn a lot of the foundational fundamentals that are going to help you become more experienced with AWS and be able to teach you some different tips, techniques, and strategies that you're going to be able to use in your AWS career. By the end of this course, you should have a fundamental understanding of the AWS platform and AWS Certified Solutions Architect program. So this course is really going to give you that understanding at a foundational level as far as how to navigate through the AWS platform easily and effectively so that you can get the outcomes that you're looking for with AWS. So let's go ahead and jump into the content that we're going to cover in this AWS Masterclass. So we're going to cover 5 different sections in this AWS Masterclass, with the section number 1 being the AWS Intro plus the Identity and Access Management. This is where you're going to get an overview of how the AWS Amazon platform works, how to set up some users, how to set up some access management, and how to create various roles within the AWS ecosystem. And then in section 2, we're going to go over the AWS Elastic Compute Cloud. So we're going to go into an introduction into EC2. Then we're going to go into the hands-on version of the EC2 lesson. And then we're going to go into installing Git, Docker, Apache, setting up different security groups, setting up various IP addresses, and many more. And then in section 3, we're going to go over the EC2 storage. So this is where we're going to go into the Amazon EBS volumes, volumes hands-on. We're going to go into creating snapshots. We're going to go into encryption, Lifecycle manager. So that's where we're really going to go into deep EC2 storage coverage. And then in section 4, this is where we're going to cover Amazon AWS Simple Storage Service. So this is the Amazon S3. We're going to go into an introduction to Amazon S3. We're going to go into the hands-on with S3 buckets and objects. We're going to go into versioning, encryption, creating security and bucket policies, and then the S3 websites, and several more lessons. And then finally in section 5, this is where we're going to go into the introduction to the AWS command line. So this is the CLI. And what we're going over here is installing the AWS CLI. We're going to go over configuring it. We're going to go over the configuration roles and policies. And then we're going to go over the AWS CLI with Amazon EC2 and Amazon S3, and then the IAM. So we're going to go over a ton of different lessons in this particular masterclass. And so I'm excited for you to get started, and we'll see you on the inside. So as you can see here, we're on the website aws.amazon. And this is really giving you here an overview of what AWS is all about. And simply put, AWS stands for Amazon Web Services and is a secure cloud services platform offering compute power, database storage, content delivery, and other functionalities to help businesses scale and grow. And so what this platform and what AWS is all about is about the cloud, right? Being able to host, create, set up, right, different type of cloud infrastructure, right? Think about different IT departments that have, physical IT servers that have, different types of data, right? They are typically putting all of their data in a particular IT storage room where they have all these different servers, right? They have maybe virtual servers in there, but they're essentially having everything in a physical manner, right? Where now a lot of companies are transferring all of their data directly to the cloud because it's easier to manage. There's less moving pieces, right? You don't have to have as many people actually working within IT department. So it really helps minimize the number of people involved in the process to manage an IT infrastructure, IT department, right? You can build up different applications, different servers, different websites, all through the AWS platform, right? So very, very powerful. And so let's go down here and take a look at the various industries. You can see here advertising and marketing, financial services, game tech. And honestly, there really isn't a industry that AWS will, not be able to work in because of how easy, how efficient their platform is, and how simple it is for you to work with. Once you get a fundamental understanding of how different tools work, right? It's going to be very easy for you to come in here and set up a server, set up different applications, right? And we're going to walk you through exactly how to do all that. So here we look at the technology categories, right? Where you can work within machine learning, analytics, creating data lakes, right? Internet of Things, serverless computing, containers, enterprise applications, and storage. I know a lot of different companies out there that use AWS simply for their storage and to host, various applications, right? You think about social networking platforms out there, the majority of them are hosted on the AWS platform, right? So very, very powerful here as far as what the AWS capabilities are, right? And so I recommend you come in here and take a look at, a little bit deeper as far as the AWS homepage and take a look at the different services here, right? We're going to cover some of these in this particular masterclass here. We're going to go over the EC2. We're going to go over the S3, right? And so we're going to go over a lot of these different sections in this particular masterclass. And so now let's go ahead and take a look at the AWS Certified Solutions Architect Associate Program. So this particular masterclass here is really centered around getting you a fundamental understanding of how to become somebody who has the skills of a solutions architect, right? Obviously, this course is not going to cover from A to Z as far as you being able to, pass the actual test, because that would require, a very, very lengthy course, and it would require tons and tons of content. This course here, this masterclass, is really giving you a foundational understanding so that you can get to know how the Certified Solutions Architect program works, the different lessons that are going to be involved, so that if you really want to take this serious and actually get certified as a solutions architect, right, then you're going to want to expand your learning. But this course here is really going to be that foundational, absolute beginner's understanding so that you can take this information and then continue your education as far as being able to fully understand what the Certified Solutions Architect is all about, because the particular exam is actually quite lengthy and there's a lot of questions and there's a lot of content. So this course is really giving you, like I said, that foundational understanding, because a lot of what you're going to learn in this course is going to set up that foundational structure for you to have, so that everything else that the actual course or the exam is going to cover, you're going to be able to easily digest that, and it'll make a lot more sense because you'll have that foundation already set. So I'm excited for you to get started, and we'll see you on the next one.
Some of the core concepts and important points to remember and terminology when it comes to AIM. Now, keep in mind, just as with any other service in AWS, AIM is very vast and it has a lot that it offers and a lot that it allows you to do. So, my job here is not to give you, a complete encyclopedia, coverage of AIM. I'm going to give you the core concepts and the important pieces of AIM that you will need in order to, start using the service and, pretty much be able to do 80% of what you would need to do, maybe even 90% of what you would need to do with AIM, if you're working in an organization or, you're building your own application or whatever the case may be. And anything further as it comes up, for niche or edge cases that you might encounter, it's up to you to go and use AWS's documentation to find answers to what you're looking for. Now, I will say, I've probably said this before, and I'll keep saying it. AWS has, a stellar documentation system. So, they very thoroughly document everything, and it's very easy to find, very easy to read. It's not very complex, right? It's very, very simple, writing, very simple English. And so, you should be able to find whatever you're looking for. They do also offer, all their documentation pages, in PDF form. If that's something you'd like to do, download it and print it out, maybe, and read from there. So having said that, let's get into AIM. Now, what is AIM? It is basically an abbreviation for Identity and Access Management. As you'll find, AWS loves abbreviations. They abbreviate everything like they're in the military. Even AWS itself is an abbreviation for Amazon Web Services, right? So, you get used to these abbreviations. You'll pick them up. Don't worry, but you should always know what the abbreviations stand for. Like EC2 stands for Elastic Cloud Computing, right? Because, that's important to know because, the Elastic term is used quite often in AWS, and it's important to know which services are Elastic. And same with, with cloud computing, you understand that it's a cloud computing service and so on and so forth. So you should know abbreviations for each of these services. Or the meaning of the abbreviations for each of these services. So identity and access management. So, that pretty much gives you an understanding of what IAM is used for. You're basically managing identity and access. And identity obviously refers to users and that kind of stuff. And access, what type of permissions they have, so on and so forth. So it's a web service that helps you securely control access to AWS resources. Given the vast amount of resources available in AWS, and given the scale to which you can build applications and systems with AWS, you'll most probably be working at a company or an organization or, on a team where different individuals within that team will need access to different parts of the AWS account. And it's probably not wise to give everybody complete access. So you need a way of managing all of that, right? You don't want your, project manager who doesn't have any technical idea of how to use AWS. You don't want him to be able to go in and be able to, disrupt any of the services you have running or any of the servers and that kind of stuff. But you do want him to be able to manage billing and that kind of stuff, right? Same with a developer. Maybe you don't want the developer to know the intricacies of how your servers have been set up and all of that, but you do want him to have access to a particular server so he can deploy his code or his application. So there are endless cases or scenarios that we can go over, but in each of these, the central theme is that you have multiple users and they each play a different role in your production environment, and you want to be able to manage who has access to what and restrict it as required. So and likewise, right, just as you have different users, you might also have a vast number of different services, different servers, different instances and that kind of stuff running on your account. And you might want to also manage which one of those services can communicate with the other services, right? Like let's say you have a database and the database is closed to external access, but you might have 3 servers running different versions of an application, and you might want to control which of those servers have access to your application. So you need a way of managing access management of different web services to other web services as well. So you do that under the role definition. So whereas a user refers to an individual, a role will refer to a web service. So we're going to go into all of that. Don't worry. So essentially, AIM is an alternative to using the root user, which should never be used. Note the exclamation mark. And this is very important. So it is highly, highly, highly advised by AWS and by all the DevOps engineers that have experience using these type of services, that you should never use the root user for your daily work. And this is also, I guess, a theme that's been transferred over from Linux administration. Those of you who are familiar with Linux administration, right? You don't want to do your regular administrating or your regular maintenance and that kind of stuff using your root user, right? Because it's very risky. You might do something and mess stuff up and not be able to undo any of that. So it's always good practice to create a separate user, even if you are the admin, even if you are the creator of the account, and even if you are the one that should have the the ultimate highest level access. You can give yourself access to all the different web services, but you should do it as a separate user. So the first thing you should do is obviously create a user for yourself that is like the highest level admin, master user, and then from there you can do whatever you want. And so it allows you to create and manage IAM identities. So these are what we refer to users, groups, or roles as. So anything you create within IAM, specific, to a user or a group or a role, is referred to as an IAM identity. Again, the reason I'm emphasizing these definitions and these terms is because, especially if you're going to take the exam or you're working in an environment that has been using AWS for a long time, you're expected to know these definitions and know these terms. So I'm going to be covering as many terms as I can, but keep in mind that, again, I can't, this course is not meant, no course will ever go into, complete detail, because that would just take way too long. So do use the AWS documentation to further, expand your AWS vocabulary, and I will put some references at the end of this, each section for you to, read further on everything we've covered. So users, like we said, refer to individuals. Groups allow you to group users so that you can apply the same permissions or policies, as they're called in AWS, to multiple users and change them without having to go into each individual user. So for example, if you want to have a set of permissions that you want to assign all the developers on your team, you don't want to, let's say you want to change something in these set of permissions, you don't want to go into each user one by one and change it. So you can assign them all to a single group, let's say a developer group, and then you can assign a policy or a set of permissions to that group, and whenever you change that, it's reflected within the underlying users. And roles, like we said, they refer not to individuals but to instances, or like a database or a server, that kind of. Now, this is above the we're not, for the sake of this course, roles are not that important, but let me just give you a more proper definition of what a role is, just so you do know what it is. So a role is very similar to a user in that it is an identity with permission policies that determine what the identity can and cannot do in AWS. However, right, a role does not have any credentials associated with it. So instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. And so an AIM user can assume a role to temporarily take on different permissions for a specific task. And then, but for all intents and purposes, right, why would you prefer a role over a user or user over a role? I'll go into that in the following slides, but I just felt you should know that. But in general, it is used it is used the way I told you it is used, but it's good to know what it's formally defined as. So IAM allows you to manage permissions and policies, as we've stated. It also lets you set up multi-factor authentication, also known as MFA, and this just allows you to ensure the security of the users that are accessing your account. And security is a whole nother beast when it comes to all AWS services, and we're going to be covering as much as possible, but do make sure that you are up to date with the latest. One important thing to keep in mind with AWS is they're always updating, they're always changing their services, and even the look of their console and that kind of. Hello and welcome to Identity and Access Management in AWS. Now, keep in mind, just as with any other service in AWS, AIM is very vast, and it has a lot that it offers and a lot that it allows you to do. So, my job here is not to give you, a complete encyclopedia, coverage of AIM. I'm going to give you the core concepts and the important pieces of AIM that you will need in order to, start using the service and, pretty much be able to do 80% of what you would need to do, maybe even 90% of what you would need to do with AIM, if you're working in an organization or, you're building your own application or whatever the case may be. And anything further as it comes up, very niche or edge cases that you might encounter, it's up to you to go and use AWS's documentation to find answers to what you're looking for. Now, I will say, I've probably said this before, and I'll keep saying it. AWS has, a stellar documentation system. So, they very thoroughly document everything, and it's very easy to find, very easy to read. It's not very complex, right? It's very, very simple, writing, very simple English. And so, you should be able to find whatever you're looking for. They do also offer, all their documentation pages, in PDF form. If that's something you'd like to do, download it and print it out, maybe, and read from there. So having said that, let's get into AIM. Now, what is AIM? It is basically an abbreviation for Identity and Access Management. As you'll find, AWS loves abbreviations. They abbreviate everything like they're in the military. Even AWS itself is an abbreviation for Amazon Web Services, right? So, you get used to these abbreviations. You'll pick them up. Don't worry, but you should always know what the abbreviations stand for. Like EC2 stands for Elastic Cloud Computing, right? Because, that's important to know because, the Elastic term is used quite often in AWS, and it's important to know which services are Elastic. And same with, with cloud computing, you understand that it's a cloud computing service and so on and so forth. So you should know abbreviations for each of these services. Or the meaning of the abbreviations for each of these services. So identity and access management. So, that pretty much gives you an understanding of what IAM is used for. You're basically managing identity and access. And identity obviously refers to users and that kind of stuff. And access, what type of permissions they have, so on and so forth. So it's a web service that helps you securely control access to AWS resources. Given the vast amount of resources available in AWS, and given the scale to which you can build applications and systems with AWS, you'll most probably be working at a company or an organization or, on a team where different individuals within that team will need access to different parts of the AWS account. And it's probably not wise to give everybody complete access. So you need a way of managing all of that, right? You don't want your, project manager who doesn't have any technical idea of how to use AWS. You don't want him to be able to go in and be able to, disrupt any of the services you have running or any of the servers and that kind of stuff. But you do want him to be able to manage billing and that kind of stuff, right? Same with a developer. Maybe you don't want the developer to know the intricacies of how your servers have been set up and all of that, but you do want him to have access to a particular server so he can, deploy his code or his application. So there are endless cases or scenarios that we can go over. But in each of these, the central theme is that you have multiple users and they each play a different role in your production environment, and you want to be able to manage who has access to what and restrict it as required. So, and likewise, right, just as you have different users, you might also have, a vast number of different services, different servers, different instances and that kind of stuff running on your account. And you might want to also manage which one of those services can communicate with the other services, right? Like let's say you have a database, and the database is closed to external access, but you might have 3 servers running different versions of an application, and you might want to control which of those servers have access to your application. So you need a way of managing access management of different web services to other web services as well. So you do that under the role definition. So whereas a user refers to an individual, a role will refer to a web service. So we're going to go into all of that. Don't worry. So essentially, AIM is an alternative to using the root user, which should never be used. Note the exclamation mark. And this is very important. So it is highly, highly, highly advised by AWS and by all the DevOps engineers that have experience using these type of services, that you should never use the root user for your daily work. And this is also, I guess, a theme that's been transferred over from Linux administration. Those of you who are familiar with Linux administration, right? You don't want to do your regular administrating or your regular maintenance and that kind of stuff using your root user, right? Because it's very risky. You might do something and mess stuff up and not be able to, undo any of that. So it's always good practice to create a separate user, even if you are the admin, even if you are the creator of the account, and even if you are the one that should have the, the ultimate highest level access. You can give yourself access to all the different web services, but you should do it as a separate user. So the first thing you should do is obviously create a user for yourself that is like the highest level admin, master user, and then from there you can do whatever you want. And so it allows you to create and manage IAM identities. So these are what we refer to users, groups, or roles as. So anything you create within IAM, specific, to a user or a group or a role, is referred to as an IAM identity. Again, the reason I'm emphasizing these definitions and these terms is because, especially if you're going to take the exam or you're working in an environment that has been using AWS for a long time, you're expected to know these definitions and know these terms. So I'm going to be covering as many terms as I can, but keep in mind that, again, I can't, this course is not meant, no course will ever go into, complete detail, because that would just take way too long. So do use the AWS documentation to further, expand your AWS vocabulary, and I will put some references at the end of this, each section for you to, read further on everything we've covered. So users, like we said, refer to individuals. Groups allow you to group users so that you can apply the same permissions or policies, as they're called in AWS, to multiple users and change them without having to go into each individual user. So for example, if you want to have a set of permissions that you want to assign all the developers on your team, you don't want to, let's say you want to change something in these set of permissions, you don't want to go into each user one by one and change it. So you can assign them all to a single group, let's say a developer group, and then you can assign a policy or a set of permissions to that group, and whenever you change that, it's reflected within the underlying users. And roles, like we said, they refer not to individuals but to instances, or like a database or a server, that kind of. Now, this is above the we're not, for the sake of this course, roles are not that important, but let me just give you a more proper definition of what a role is, just so you do know what it is. So a role is very similar to a user in that it is an identity with permission policies that determine what the identity can and cannot do in AWS. However, right, a role does not have any credentials associated with it. So instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. And so an AIM user can assume a role to temporarily take on different permissions for a specific task. And then, but for all intents and purposes, right, why would you prefer a role over a user or user over a role? I'll go into that in the following slides, but I just felt you should know that. But in general, it is used it is used the way I told you it is used, but it's good to know what it's formally defined as. So IAM allows you to manage permissions and policies, as we stated. It also lets you set up multi-factor authentication, also known as MFA, and this just allows you to ensure the security of the users that are accessing your account. And security is a whole nother beast when it comes to all AWS services, and we're going to be covering as much as possible, but do make sure that you are up to date with the latest. One important thing to keep in mind with AWS is they're always updating, they're always changing their services, and even the look of their console and that kind of stuff. So anybody who makes a course eventually becomes outdated, and so this course is like probably the newest course you'll have access to, but still you should keep up to date with, the new features and the new security documentation, that kind of stuff. So here are a list of some of the key IAM features. So the number one feature obviously being shared access to your AWS account, right? Otherwise it would be, a huge pain doing anything, because you wouldn't be able to have anybody else working with you on your account unless you shared with them, your actual credentials, which would be, very risky and a big no-no when it comes to security. So you can grant other people permission to administer and use resources in your AWS account without having to share your password access key. So this is the number one feature. Granular permissions. You can grant different permissions to different people for different resources. For example, you might allow some users complete access to, an EC2 instance or an S3 instance. Again, EC2 stands for Amazon Elastic Compute Cloud, and S3 stands for Simple Storage Service, or DynamoDB, Redshift, other services as well. For other users, you can allow read-only access to just some S3 buckets, or permission to administer just some EC2 instances, right? If you have an admin or a Linux admin or somebody that you want to manage your instance, or to access your billing information, but nothing else. Like we said in the previous slide, maybe you want your project manager to access your account, but you don't want him to mess stuff up on accident because he has no technical knowledge of how to use AWS, but he needs to view the billing and manage the billing and that kind of stuff. So another feature would be secure access to AWS resources for applications that run on Amazon EC2. You can use AIM features for securely provide credentials for applications that run on EC2 instances. Okay, so applications, maybe you have you have a database that's running on your EC2 instance, maybe you have a web API, whatever it may be, can securely provide credentials for those applications. These credentials provide permissions for your application to access other AWS resources, such as S3 buckets or DynamoDB tables, and so on and so forth. If you're not familiar with S3 and these other names I'm throwing around, don't worry, this course is intended to teach you all of that. So we will be covering almost all of those major services in this course, but there are over 100 I think services on AWS, so we can't cover all of them, but like all the main ones like EC2, S3, so on and so forth, we'll cover. And then obviously multi-factor authentication, also known as MFA. You can add two-factor authentication to your account, so that's what MFA is, and to individual users for extra security. With MFA, you and your users must provide not only a password or access key to work with your account, but also a code from a specially configured device. So this device can be a phone, it can be a designated MFA device, whatever it is. There are some options. We'll see them when we're doing the hands-on for this section, but I prefer using my phone. There's an application you have to download and that kind of stuff, but you might have exposure to MFA from other applications. I think Google now is also requiring MFA or recommending MFA when you're logging even into your Google account or your Gmail account. Identity federation, again, these keywords are good to know for the exam and when you're working with other DevOps engineers and stuff. Identity federation basically means that you can allow users who already have passwords elsewhere. For example, if you're working in a company and you have a corporate network, or some other not a CRM, but some sort of software that's managing the employees at your company, or you just have another application that already has user and password information, and you don't want to go and create a new set of user and password information just for the sake of AWS. You can integrate that with AWS so that essentially they can use their existing passwords to log into AWS. Now that's a huge topic, and that's something that no other course will also cover. That's a more advanced topic, but it's good to mention here so that that it's possible. identity information for assurance. So if you use AWS CloudTrail, which is another service from AWS, you can receive log records that include information about those who made requests for resources in your account. And that information will be based on AIM identities. So that's useful if you do use AWS CloudTrail. And then it's integrated with many AWS services. You can see a full list of all the services that IAM is integrated with. If you just search like AWS services that work with IAM into Google, you find the AWS documentation page, and then it's free to use. So that's a big plus, right? AWS notoriously charges you for everything, but AIM is just a default free service. But obviously you will be charged for the services that your users will be using when they use their AIM identity to access your AWS account. So obviously make sure of that, keep track of what services they're using, because you will be charged for that, but you won't be charged for using AIM specifically. So let's get into AIM identities. So we've kind of mentioned all of this previously, but these are where I'll formally define all of these terms. An IAM identity provides access to an AWS account. That's very clear. A group is a collection of AIM users managed as a unit, so it can contain many users, and a user can belong to multiple groups. And groups basically let you specify permissions for multiple users, as I mentioned. And AIM identity represents a user, and this is, I pulled this from the AWS documentation. This is a very good example of how you can have groups set up. So you have your original account. Again, the root access to this account you should never use. Just lock it up somewhere safe, and that's it, right? Don't use it. You have to use it obviously to create your first user, which will basically be you. And then from there, you don't need to use it again. But for example, if you want, Bob and Susan to have admin access, you can create a group called admins, and then you can specify admin permissions that'll basically be, transferred over to any user that belongs to that group. Same with developers, and same with, let's say you want to have a test group, and so on and so forth. So, that's how you manage groups. And I'll show you that in the hands-on video. First we'll create permissions and so on and so forth using just individual users, and then I'll show you how it's more efficient to use groups. So an IAM identity represents a user and can be authenticated and then authorized to perform actions in AWS. So each IAM identity can be associated with one or more policies, and policies basically determine what actions a user, role, or a member of a group can perform on which AWS resources, and under what conditions. So policies, I'm going to be getting into that as well, but there are predefined policies, and there are policies that you can create, and I'm going to be showing you how to do that as well, but I'm going to also be giving you some more information on it in the following slides. So identity access management, it's very, so you can get a quick idea. Policies define what actions the above can take. So users, groups, and roles, they can each have different policies, so on and so forth. Then you can move users in and out of different groups, and same with roles. So there are AWS managed policies and customer managed policies. So AWS managed policies are basically policies that are created and managed by AWS, and they're very useful, especially if you're new to using policies. It's highly recommended that you just stick to using AWS managed policies. For example, and I'll show you how to do that, but you can search for let's say network administrator. So we'll be able to open this up, and we'll be able to see exactly what that policy has access to, and whether or not it has read or write access, or has complete access, or AWS uses the word full access, and then you can just assign those to groups and so on and so forth. But in the case that you do want more customized policies or permissions, you can create customer managed policies, and so these will provide you more precise control. And there's a visual editor within AWS where you can visually create or edit your AIM policies, or if you're more programming inclined or code inclined, and you want to use some kind of reproducible method, each policy is actually essentially a JSON document or a JSON data file. So you can define your policies as JSON files, and this way you can save it or you can share it and so on and so forth. AWS managed policies are a good starting point to help you figure out the names of the privileges that you might want to use, but it's better to use the AWS policy generator, which I will show you how to use. But yeah, so you're not going to really find yourself using customer managed policies too often. I do in some cases just for just to add something or take away something from an already existing managed policy. But again, we'll get into all of that. Now, when would you want to create an IAM user instead of a role? Because remember, I defined what a role is, and at this point, it might be a little too advanced. And so you might have gotten a little confused as to when to, what the difference between a user and a role is. I did mention that, the very common application of using a role specifically when dealing with web services instead of individuals, but obviously the definition is a little bit more broad. And so I'm going to try to give you some idea of how you could prefer or when you would prefer one over the other. So this should help you understand better the difference between the two. So because an IAM user is just an identity with specific permissions in your account, you might not need to create an IAM user for every occasion on which you need credentials. Okay. In many cases, you can take advantage of IAM roles and their temporary security credentials instead of using the long-term credentials associated with an IAM user. So if you created an AWS account and you're the only person who works in your account, then technically it is possible to work with AWS using the root user credentials for your AWS account, but that's not recommended at all, as we've discussed. So instead, it's highly recommended that you create an IAM user for yourself and use the credentials for that user when you work with AWS. So in that case, obviously you create a user and not a role. And there is some nice documentation by AWS on security best practices when dealing with AIM. And again, just search into AWS documentation on docs.aws.amazon.com. Just search for security best practices in AIM and you'll find those. Another case would be when other people in your group need to work in your AWS account and your group is using no other identity mechanism. And so in that case, create AIM users for the individuals who need access to your AWS resources and assign appropriate permissions to each user and give each his or her own credentials. So we strongly recommend, and it's AWS strongly recommends, and any other AWS professional would strongly recommend that you never share credentials among multiple users. So essentially you would just create another user for each, a separate AIM identity for each user, each individual. So that's generally two good rules of thumb. Those are two situations where you would create an IAM user instead of a role. Now let's look at the opposite. Let's look at the other side and answer the question, when would you create an IAM role instead of a user? By the way, these are questions that might come up on the exam as well, if you are taking this course for the exam. Our goal with this course is more of a hands-on, real world, course for, application, getting your hands dirty. We're not as concerned about the exam, but we are covering everything you do need for the exam. So I will try to, as much as I remember, to note important things you might need for the exam. So you should create or think about creating an IAM role for these three situations. So assume you're creating an application that runs on an Amazon Elastic Compute Cloud or Amazon EC2 instance, and that application makes requests to AWS. So don't create an IAM user and pass the user's credentials to the application or embed the credentials in the application. Okay, instead of that, create an IAM role that you attach to the EC2 instance to give temporary security credentials to applications running on the instance. Okay, and we made brief mention of this earlier. When an application uses these credentials in AWS, it can perform all of the operations that are allowed by the policies attached to the role. So essentially it is like a user, but note the specific use case here. So you can again use AWS documentation, search for using an AIM role to grant permissions to applications running on Amazon EC2 instances, something like that. And you can find relevant documentation on how you would do that. Or you're creating an app that runs on a mobile phone and makes requests to AWS. In that case, again, don't create an AIM user and distribute the user's access key with the app. Don't do that. Instead, use an identity provider, like login with Amazon or Amazon Cognito, Facebook or Google or any other service like that to authenticate users and map the users to an IAM role. And the app can use the role to get temporary security credentials that have the permissions specified by the same policies that by the way, that you can attach to users, but in this case that are attached to the role. So again, you can find out more information on how to do all of that. And also another use case for creating a role instead of a user would be when users in your company are authenticated in your corporate network and want to be able to use AWS without having to sign in again. That is, you want to allow users to federate into AWS. Remember, we talked about user federation, and if you already have a system at your at your corporation or at your company or business or whatever that where you're already managing and dealing with users and passwords and that kind of stuff. So in that case, don't create IAM users. Configure a federation relationship between your enterprise identity system and AWS. And there are a couple ways you can do this. I'm not going to go into details. Again, all of this you can find, through AWS documentation. Like I mentioned, the federation issue is something that's above the scope of this level. But just knowing that it exists will help you, especially if you do get a question like that on the exam. So these are some very useful resources you can use to find out more. Essentially, if you just go into the AIM user guide, on the side you'll have some links basically that you can walk through everything that AWS documentation has to offer in terms of AIM. When it comes to IAM, how to create users, groups, how to assign policies, and that kind of stuff. So this will be a very practical walkthrough, and in general, throughout this course, expect to learn the most from these hands-on videos. If you're studying, solely for the exam, obviously the presentations will be important for you, the slides and any documentation that you can find on AWS, because you'll have to memorize terms and definitions and that kind of stuff. But in general, AWS is best learned by application, just getting your hands dirty, trying stuff out, and just, experimenting. And that's what we're going to do. And to the best of my ability, I'm going to try to keep this as laid back as possible. I don't want to give the impression that you should have everything memorized and know exactly where everything is and just know where, just click through everything and you're done. Because most of the time that's not going to be the case. When you do require the use of a particular service, you might not know everything about it, and you might have to click around a little bit and just play around and discover some stuff on your own. And that's generally the best way to approach all the services in AWS, because as you can see, from here, or we can just click on this in the upper left corner, AWS gives us access to a lot of services. So there are a ton of services here. Everything from computation services to storage services, database services, machine learning services. So, it's a pretty long list, and there's no way we can cover all of this, and no other course would ever even attempt to cover all of it. but I'm going to try to give you as much as possible. A few of these services will pretty much cover 80% of your AWS needs, and then the remaining services you can learn on an as needed basis. So for example, EC2, Lightsail, S3, RDS, these type of services will pretty much be used in any application. And so, they're crucial and they'll definitely be covered in the exam. But then others are less common, or they're more specific to particular use cases, or they pertain to another specific AWS certificate or like another exam. So it's another domain completely, and we don't need to worry about it. But for this video, we're concerned with IAM. So we want to create users and groups and manage them and assign policies and so on and so forth. So we want to use the IAM service. By the way, I do apologize. I might, in the last video as well, I get confused sometimes. I might have referred to IAM as AIM. I don't let those two things get mixed up. There is another thing called AIM in AWS that we will be learning about. So everything in this section is concerned with IAM. So if I've ever said AIM, just assume it to be IAM, okay? Identity and Access Management. So there are a couple ways to access IAM. IAM is a service after all. So just like any of the other services, it's a service. So it has its own dashboard and its own, area. And so we can access it just as we would any other service. So probably the easiest way to do it would be by using the unified search, which is a new feature that AWS recently started implementing. So basically you can type in whatever you have in your mind. If you don't remember the abbreviation IAM, you can just type in Identity and Access Management. If you do remember the abbreviation, you can type that in. Whatever, AWS will do its best to find it for you. So let's type in IAM. And there we go. AWS instantly finds that service for us. So under services, it finds the closest matching ones. So IAM, manage access to AWS services. There we go. Okay. And it also lists some of the top features within that service. So you can go directly into groups under IAM, or roles or policies or users. And there's, documentation, other stuff that, we're not concerned with. So you can access it directly from here, or you can from this page where we can see all the services, which is basically the same thing as this drop down here. We can go into security, identity, and compliance, and it's the top service there. So everything to do with security, identity, and compliance is listed here. But obviously the number one central, most important one is IAM. This is like the center of the central hub, if you will, for all your security and identity needs. So before we go into that, let me draw your attention to something. So if you notice, I'm in the Ohio region, US East Ohio, or US-East-2. In your case, whatever region is closest to you, wherever you are in the world or in the US, whatever region is closest to you, this happens to be the closest to where I'm based out of. But it could just as well be anywhere else, and obviously this list keeps getting longer and longer. But not all services on AWS require the selection of a particular region. So when you're dealing with actual hardware, when you're dealing with stuff like EC2 or RDS or S3 or whatever, you're gonna have to pick a region in which that service will be used, and that particular instance of you using that service will be used, and that particular instance of you using that service will be specific to that region. And in fact, some services might not be available in all regions. However, there are some services that are global and that are applied to all the regions and are not region specific. So IAM happens to be one of those services. So if you keep your eye on Ohio here, as I click on IAM, you're going to see that it changes to global. And if we pull down the regions drop down, you'll see that IAM does not require region selection. And in fact, you're not even allowed to select any region. So anything you do in IAM is directly applicable to all the regions. And so you don't have to worry about that at all. So once we click on IAM, we're immediately presented with the IAM dashboard. And this is basically where you have access to everything you need. And it's pretty similar to other dashboards you'll find on AWS. And it contains some extra links on the right, just to help you out. Best practices, security alerts, what's new. This is all just extra stuff. And then we have two main sections on the left. We have access management, access reports. Access reports we don't really need right for now. It's, something that's a more advanced topic. But we do want access management. So under access management, we have groups, users, roles, and policies, which are the main things we're going to be concerned with for this video. And in the dashboard, you have your IAM resources. So here you can see the number of users, groups, roles, identity providers, and customer managed policies you have. So we are given 2 default roles by AWS. So I did not create these, and you should also see 2 here. These should have been created by default by AWS. However, when it comes to users or groups, currently we have 0 because this is my root. I did use my root credentials, my root user to access this account, just as you have, which means that I haven't created any users yet, and I'm just using the email I used to sign up for the account, which again, like we said, is not good practice. So the first thing we want to do is create a user. So let's go ahead and we can click on this, or we can just go into access management on the left and click on users. Here you will see a list of all your users eventually when you do have users, but currently we have none. And then some additional information about your users. So which groups they belong to, how old their password is, how long ago they last, used their credentials to basically log in, and whether or not they have MFA or multi-factor authentication. Now, we have no users, so there's no point in spending time on this page currently. Let's go ahead and add a user. And the first user you create, as we said, it's generally good practice that you create yourself a user immediately as soon as you create an AWS account. And that user will be the user you'll use essentially to access your account instead of the root user. And then from there, you can continue creating other users and you were going to do. So since my name is Ismail, I'm going to be creating a user called Ismail. You can just, create a user with any name, your name. Just create one with your name. And I can add as many users as I can create essentially as many users as I want at once. But we're not going to really be using this feature at the moment because we don't have, a team or, this is just an example, right? But, if you did have a team and you wanted, for example, all the developers on your team to immediately be created, using the same settings, you can just create them all at once. But we don't need to do that. So I want to give this user complete programmatic access. So this is essentially because, we're creating this user for ourselves. So it's going to be the second most powerful account or second most powerful user after the root user. So we want to give it as much access as possible. We definitely want to give it access to the management console. And here, it's up to you. You can do whatever you want in these settings, but I generally prefer an auto-generated password. I don't like typing in actual passwords, but you could do that if you wanted. To, but if you click auto-generated password, you will be able to download the password and the user will be able to use that password. And then I always require password reset. So this forces the user the first time they use those credentials to log in, it forces him or her to create a new password. So that, that's good for security reasons. So now we haven't talked about policies yet, but if you do allow for password reset, or you do require password reset, the user is automatically assigned or attached to the IAM user change password policy. So we're going to see this later on, but essentially this is where that'll come from. If you're confused as to why when you create a user it's automatically attached a policy called IAM user change password, this is where that comes from. So at this point, if we had any groups that we had already created, we can assign this user to that group. If in this case we don't, so we can actually create a group directly from here. But for now we're not going to, because I want to show you guys how to create just a user first, and then we'll create a group later on. So we want to attach policies that will basically give this user access to different or services or different resources, and give it different permissions. So we click on attach existing policies directly. So, and then these will be the Amazon managed policies. And as you can see, there's quite a long list of, and it keeps getting longer and longer as you scroll. These are all policies that Amazon has predefined for us, and this saves us a lot of time and effort, because pretty much any type of, or any set or combination of permissions you might want to give a user is, most probably defined in some way or another within this list. So, but if not, and you have experience already with AWS and you've already used AWS managed policies and you want to define or create your own policy, you can do so from here. We're not going to do that now because we don't want to confuse ourselves, right? We're just learning how to use policies and all of that. So we're going to ignore that for now. But you can search for, let's search if there is any policy that has to do with like admin access, because our user that we're creating now will essentially be the admin, right? We said he's going to be the second most powerful user after the root user. So let's type in admin. And there we go. We have quite a few, but the top one pretty much will do the job for us, right? Administrator access. And we can open this up to see exactly what this policy gives access to within the policy summary. So here we can see that, we have this policy will give us access to 264 out of 264 services. So it'll give us access to all the services on AWS. So there are 264 services, and we'll have access to all of them. Let's find some that we might be familiar with. Let's see, like billing, right? We have full access to billing and all of its resources. What else? What's something that? Okay, so EC2. We have full access to EC2 and all its resources. So this is a very useful policy for us at this moment, but obviously when you're creating policies or when you're creating users other than your own user, you most probably will not want to give them, most probably will not want to attach the administrator access policy to their user, because you probably don't want other people to have as much control as you do over your own account. But in our case, we do. But we could, depending on whatever you want, right? You just want, for example, EC2, something to do with EC2. So everything to do with EC2 policies will be listed here. So for example, EC2 Instance Connect. So this means, it gives you access to 2 services only. It gives you access to EC2 Instance Connect, full access, all resources, and EC2 only gives you access to a limited number of resources from EC2, or no, all resources, but the access level is limited. So, this is just an example, obviously. So based on your needs, you'll have to find the policies that you would like to use and attach to the users you're creating. And in the worst case, you can just create your own policy. And so I mentioned in the last video that policies are actually defined as JSON objects. So if you're familiar, if you've worked with web technologies before, you should know what a JSON object is. Essentially, if we click on JSON here, we can see the policy in its JSON form. So maybe, if you continue using AWS and you get better and better, and maybe you become an AWS developer and stuff, then you can actually start writing your policies as JSON objects, or sharing them or finding them online, that kind of stuff. So, but for our purposes, the policy summary is enough for us to understand what we're dealing with. And then we can create tags for the user. So IAM tags are key value pairs you can add to your user. Tags can include user information, such as email addresses, or they can even just be a description that, such as a job title or their position or their role in the team or whatever, right? And you can use the tags to organize, track, or control access for each user. So, since we're not going to be creating too many users, it doesn't really matter for us. But if you're dealing with hundreds and hundreds of users, right, or even just tens of users, it does end up getting pretty messy, and you do want a way to easily organize and to easily find important information. Like, for example, you might want to find that email. We could add like an email, Ismail@gmail, let's say. This is my actual email, but as an example, or maybe they have like a company ID, company ID, his company ID is, whatever, right? 1, 2, 3, 4, 5, 6. And then so this is intended for you to easily organize and just track your users. So you can just add whatever you want here. And then we can review everything. We created a user called Ismail. We gave him programmatic access and AWS Management Console access. We auto-generated his password, and we do require a password reset. And these are the policies that we've attached. We've attached the administrator access policy, but the IAM user change password policy has also been attached because we have required a password reset. And then these are just the tags that we assigned, and all of this can be changed later, so don't worry about it, right? Let's create our user. And success. We have successfully created the user shown below. In our case, it's only one user. You can view and download users' security credentials. You can also email users instructions directly from here for signing into the AWS Management Console. This is the last time these credentials will be available to download. However, you can create new credentials at any time, etc. So users with AWS Management Console access can sign in at this URL. Now you might be wondering how I got this number-1-AWS-course. I'm going to show you how to do that. But in your case, you'll see your account ID here. So this link, your users can now use to log into your account using their credentials. So here, if you click download.csv, that's what I generally do. You'll get an Excel file, like a CSV file that you can open up in Excel that will have your, the user login credentials, the username and the password that your user can now use using this link to log in. Let's close this. And we can see now that we have one user in the users feature here. We have one. So the username is Ismail with a capital I. Password was created today. He belongs to no groups. He hasn't logged on ever, and he doesn't have MFA enabled. Now let's go back in the dashboard for a second, and here you should see your the sign-in URL for IAM users. So in your case, let's delete the alias. In your case, it's going to be something like this, right? And this is your account ID. So in my case, it's 432 all the way to 94, and you can find that out from here. So if you go into in identity access management, at the bottom you'll see AWS account ID, and this will be your account ID. And by default, the sign-in URL for IAM users is your account ID.signin.aws.amazon.com/console. but you can customize this to make it easier for your users to log in. And in my case, I called it number 1 AWS course, and it does have to be unique, right? For example, AWS course might be taken already. If we try to create it, yeah, this account alias already exists. So, you know, number 1, there might be many AWS courses, but there's only one number 1, right? So we create an alias, and there we go. Now this link can be used for IAM users to access your account. Now we can now see that we have one user down here, and if we click on it, it's the one we just created, and we click on it once again, we have access to all the details that we specified. So immediately you have access to the permissions that this user has, and these are defined as policies, and there are 2 policies that have been applied. Now we can delete them and add other ones as well. So here I just want you guys to get comfortable just playing around and not be hesitant, right? You know, many times people are afraid that they might make a mistake that's irreversible or something like that. So I want to show you how easy it is to, you know, undo stuff and delete stuff, add stuff back, and that kind of stuff. So we can, for example, go ahead and delete administrator access. We're detaching this policy from this user, and now he only has the IAM user change password policy attached, but we can add permissions. We can go into attach existing policies directly, find the administrator access policy, select it, go into review, accept these permissions, and there we go. The user now has administrator access policy again. So it's very easy, right, to just play around with this. You know, don't hesitate. You know, if one of your users contact you and says, you know, what happened, I don't have access, it's okay. Just come into users, click on their username or their group, if they have a group that's assigned to them, and click on and just open up the permissions and see what they have access to. Now let's look into the IAM user change password policy, and let's see what this policy gives you permission for. So it gives you permission for one of 364 services, and that is the IAM service, and it doesn't give you access to everything in IAM. It gives you access to multiple resources, but not all resources, and it only gives you limited read and write access. So if we open up the administrator access policy, so let's open that up. Take some time to load because there are 264 services, and we type in IAM here, we'll see that we actually have full access to all IAM resources. So this is actually redundant. There's no need for this service because we already have access to all of it, all of IAM. So we can actually remove this service. We can detach it. I mean, not this service, but this policy. We can detach this policy because this covers everything pretty much. So now we just have one policy. So we can also view the groups that this user belongs to, the tags that we created. We can edit tags, and the security credentials, and so on and so forth. So you can delete the user, you know, everything to do with that user you can do here. Now, since you've downloaded the credentials, you can now you can sign out. Okay. And let me actually do that for you. Let's go ahead and sign out. And you can click on sign in to the console. And originally we were logging in using the root user, and that was by using the email you used to create your account, your original root credentials. And you would type that in here, click next, and enter your password and log in. But we said that that's not good practice, and you should definitely avoid that. So we created a default, or we created an admin user, and we called it, you know, Ismail in my case, in your case, whatever you called it. And now we want to use that to log in, right? So we're going to click on IAM user, and here you would enter your account ID. So the 12 digits that I showed you, that was, you know, on the left side at the very bottom. However, because it's hard to remember your account ID, especially if you're dealing with a lot of different AWS accounts, like for me, you know, I have a separate AWS account for all my clients. So those are a lot of account IDs to keep track of. So that's why we defined an account alias. We define an account alias, and we can use that to directly access the login for that account. With the alias for our account was number -1 AWS course. And now we can log in as an IAM user for the account number -1 AWS. And our username is Ismail. Make sure you do watch out for capital letters. And for the password, you'll have to open up this file down here and find the auto-generated password for that user. So I've opened up that file and I've copied the auto-generated password. Now I'm going to type that into here and I'm going to sign in. Now it's asking me to create a new password, because remember, that's what we specified specifically. We wanted the user to create a new password. So I'm going to copy in my old password here. So the old password is the password that you downloaded as a CSV. And then you can specify a new password. And confirm password change. That's loading. And now you have successfully logged in as an IAM user. And you will see now up in the right corner, you'll see Ismail at number 1-1 AWS course. And that, now I'm logged in as an IAM user instead of a root user. And because I have access to everything, I shouldn't have any problems. I can go right back into IAM. And everything is exactly as we left it. Now that's something very important to keep in mind. When you create IAM users, you're not creating new accounts. You're not creating a new AWS account. You're creating an access or a user that can access your account. So they're going to be logging into the same account. They just have access to different services and different resources within those services within that account. So within your account. So now we have one user, right? Now, if we wanted to create another user, we can go ahead and do that. But what we want to do is create a group, because what's going to happen is now if we create another user, right, and it's also an admin user, we're going to have to assign it the same policy. But later on, if we want to change something, across all admin accounts or across all admin users, my bad, then we're going to have to go in and do that individually. So instead we can create a group. So let's click on groups. No records have been found. We can create a new group. Let's call this group admin. Okay. You can call it developer. You can create a developer group for developers, whatever the use case may be. But in our case, we want to create an admin group. Next step. Now we can select a policy or policies to attach to that group. So since it is an admin, it's going to be an admin group. Let's just attach the same administrator access policy to it. Click next. This is just reviewing which policies you've added. And then we can create the group. And now we have an admin group that has 0 users assigned to it. Now, when we go back into users, by the way, if you've noticed that now the last activity is marked as today because we've actually logged in. Okay, so let's click on Ismail and let's go to groups. Now we can add the user to a group. And now we see this admin group that we just created. And we can add Ismail to this group. Now, if you had another group there, you could have added at the same time, right? With the same click, you could have added Ismail to both or three or any number of groups at the same time. So that's very easy to manage. And now Ismail belongs to the admin group and has this permission or this policy attached to him through that group. This means that we no longer need to specify specific permissions for that user. We can just remove this. You might have a user within a particular group that needs to have special privileges, even though he does belong to a group. And so you can come in here and you can assign him special permissions as well on top of whatever he gets from the group. But in our case, we don't need it because we have attached from group. We have the same policy. that's attached from group. So we can just remove the directly attached policy, and we're detaching it, and it takes some time sometimes. No worries. Let's just let that detach, and there we go. We have now the same policy, but now it's through a group, and this means that we no longer have to manage it through that user. We can just go into groups, and we can manage the permissions they have directly from here. We can attach any policy we want. We can remove any policy we want, so on and so forth. So, and then here we can manage the users, remove user from the group. You can add users to the group. So you can add users directly from groups instead of going into the user himself, going to the user's page. And here you can obviously see that, now we have one user. So generally the best practice is to define your groups first and define the permissions that those groups will have, and then create users and assign them directly to groups. And as much as possible, try to have your policies be attached to users through groups and not directly attached. Okay. And then basically now you have complete control over how many users you can create and how many, policies you can attach and that kind of stuff. And that'll pretty much be enough for you, for most of what you need. And if you go into policies, you can manage your policies. You can create a policy. And this is, remember I mentioned in the last video that there's a visual editor. And if you wanted to, you could specify the JSON directly. You can you can create a JSON object of the policy you want, but the visual editor is generally enough for you. You can select a service that you want to give permissions to. So let's say EC2, we click on it, and then the actions, the different access levels, the resources from within the EC2 that you want to give access to, so on and so forth. And then you can actually create the policy and then start assigning it to people. So you can also import a managed policy, and that would be done as a JSON object. But again, that's a more advanced topic. Now, if we go down into account settings, we can create what's called a password policy. So it's a set of rules that define the type of password an IAM user can set. And by default, this password AWS uses this password policy here. So it requires a minimum password length of eight characters. It includes a minimum of 3 of the following. It has to have 3 of these characters. Must not be identical to your AWS account name or email address. So you can change the policy. You can enforce any number of characters. You can require any number of options here. You can enable password expiration, for example. 90 days, and then you can require that to have administrator reset, prevent password reuse, so on and so forth. So you can define exactly your password policy for your users, and this really adds to the security. And you might even have some guidelines or requirements by your company as to how your policy should be defined, and you can do all of that here. Now, one last thing that I'll be covering is how to set up MFA. Now, again, keep in mind, as with every other service, and as I've said many times before, there's a lot going on for every service, and it's just too much to cover in a course. So I'm giving you, what's pretty much enough for, everything you need for the exam, obviously, but also pretty much everything you need in practical everyday use. You can go around and you can start exploring roles. Because now you know how to use, how to create users and groups and that kind of stuff. So it's pretty much the same thing with roles. The only difficulty with roles is for people just getting into AWS is, understanding the difference between a role and a user. And I defined that in the last video. So just go back and review that if you have troubles there, and you can get a lot of information here. AWS also recognizes that people have trouble with that. So, it gives you a description of what it is. Roles are a secure way to grant permissions to entities that you trust. Example of entities include the following: an IAM user in another account, application code running on an EC2 instance that needs to perform actions on AWS resources, so on and so forth. So everything you need is here, but essentially you create a role in the same way you create a user. And then there's something, this is a new thing called identity providers, and it's too high level for this course, so I'm not going to go into it, and it's not required for you to continue with this course. But one thing that we should know how to do, and this will again be very important for security in your organization when you're creating users, is setting up MFA. So if we click on a user and we go into security credentials, here we have access to everything to do with security access. We can inactivate the access key for that user, set up SSH key, access, GitHub credentials, so on and so forth. But specifically here, we have something called assigned MFA device. It's not assigned, so we can manage that, and we can choose a type of MFA device to assign. And I mentioned that there are several options. So you can use an authenticator app, and this is the one I prefer. Or there are actually physical, devices that act as MFA devices that you can also use. But anyway, you'll click on that and you continue, install a compatible app on your mobile device or computer, and you can see a list of compatible applications. I think I have one from Microsoft or Google or something. And then you scan this code, and then you'll get 2 different codes. You might have to wait a little bit in between them. And then this way you'll establish access and connect, you'll establish a connection between your AWS account and your authenticator application. And then this way you can assign your MFA, you can assign MFA, authentication to your multi-factor authentication to your account. And so every time you log in, you'll have to use your device or your app to authenticate. And this just adds an added layer of security to your account. And so, it's something that's highly advised, and quite frankly, you should be doing it for your other accounts as well, not just AWS accounts, right? You should do it for your email accounts and so on and so forth. So that pretty much covers everything you should ever need for IAM. And yeah, so take some time, play around with that, maybe create some users, create some groups, explore, experiment. Go through some more documentation, and I will see you in the next section. To this section on Amazon Elastic Compute Cloud, also known as Amazon EC2 or just EC2. This might be the single most important instance. This might be the single most important service in all of AWS. And that's because this was one of the original services, and a lot of the current existing services are built on EC2. For example, Lightsail uses, EC2 in its backend, and so on and so forth. And EC2 is really the core of AWS. This is where you create all your, this is where the servers are created, basically, right? And the whole point of AWS is to create servers. Most of the time, there might be other applications like people just using it for, machine learning or other stuff. But at its core, it is a cloud computing platform or a cloud computing service. That's what AWS was created for, and that's what it's intended for in terms of use. So EC2 is at the very center of that. And even if your application or your intent for AWS is not centered around, virtual computing or cloud computing, you can escape learning EC2. EC2 is the first real service that's ever taught in any AWS course, and it's something that will always come up in all the exams. Like I said, it's one of the most fundamental services. We learned about another service, right? We learned about IAM, but that's just, an additional or an extra service that is just there to facilitate the other core services. And the main of those core services would be EC2. So having said that, let's go ahead and get introduced to EC2. So essentially EC2 is, a cloud computing service offered by AWS, and provides scalable computing capacity. Okay. And there's a lot of advantage to using, scalable computing as opposed to using, other services like DigitalOcean or whatever other hosting provider you might use to host a website or something like that. Because then you have to actually manage your scaling. You have to project your traffic, and that kind of stuff. But with AWS, all of that is very easy to manage. And, huge companies like Netflix depend on AWS solely for all their server needs. And so, EC2 at its core might be, just a very simple web service. You're just, generating a new Linux instance, let's say, but, it has the potential to scale up all the way to the scale of something like Netflix, with all their, video streaming that's going on live at the same time all around the world as we speak right now. All of it has EC2 in the back end. So it eliminates your need to invest in hardware up front so you can deploy and develop applications faster. And this is very, very important, right? Before the introduction of, cloud services like AWS, companies or startups had to invest in hardware up front. That means that if you have an app that's coming out, you were expected to, guess how much traffic you'd be receiving, and based on that, you'd be expected to buy all the hardware, the servers, everything you would need to manage that traffic, even if you wouldn't be hitting that traffic goal for a long time, or even if it would have, maybe you'd only get that amount of traffic at certain times of the week or the month, but you would still have to account for all of it. You'd have to, account for the maximum expectation plus some, just in case. And then as traffic increases, you'd have to keep scaling up your hardware, and you need a place to manage all of the, store all of that hardware and have people manage it, so on and so forth. So, it was a very difficult operation, very difficult way of starting up a company, especially when, you're just starting up and you don't know if your idea is going to be successful and you still don't have profits rolling in. So basically AWS eliminates the need for all of that. And, if you're taking this course, you probably know all of this. There's no need for me to go into the advantage of using a, cloud service provider like AWS. You probably, by now it's pretty well established the benefits of using something like AWS. And so, if not, go and read about it. But it's been a huge game changer for companies and anybody who wants to get into, developing their own app or their own large scale service or whatever it may be. So you can launch as many or as few virtual servers as you need, configure security and networking and manage storage, and all from AWS. So you might still need to hire DevOps engineers, for example, if you're starting up a company and that kind of stuff. But now it's all more easily manageable. They just manage it all through AWS. AWS takes on the responsibility of ensuring that your servers are up and running and all of that. And it enables you to scale up or down to handle changes in requirements or spikes in popularity, reducing your need to forecast traffic. So that's also something very important. Even if you did have the means to buy all your hardware upfront and to be able to sustain your regular traffic, you can never account for or never prepare for the big spikes in popularity or traffic. Let's say you have, I don't know, some sort of sports news website, and right around the Super Bowl, you're going to get a huge amount of traffic that you'll probably never see again for the rest of the year. That you can't be expected to have hardware to deal with that spike in traffic when it's only going to be, for the span of a week maximum, let's say. So you're able to deal with all of that through AWS. You just, allocate servers as you need whenever there are spikes. And then when the traffic goes back down, you can just let go of those instances and go back to using your regular servers. And this way you can really minimize your costs and really manage your service or your product or whatever it may be much more efficiently. So that's the advantage of EC2. Some of the features that EC2 offers are instances. So instances are basically virtual computing environments, more traditionally known as servers or virtual machines or something like that. But the modern terminology would be instance or virtual computing environment. And then Amazon Machine Images, or AMIs as they're known, and we're going to go into more detail on this later on, but those are basically pre-configured templates for your instances, and they're known as AMIs, and they package the bits you need for your server, including the operating system and additional software. So we also have instant types. So instant types are various configurations of CPU. So when you're first generating your instance, you can select the type you want, and they have various configurations, not just of CPU, but memory, storage, networking capacity, and that kind of stuff. So you can select an instant type based on your need. You can select different types, so on and so forth, and then key pairs. So it is essentially secure login information for your instances. AWS stores the public key, and you essentially store the private key in a secure place. So this makes everything very secure. Even AWS is not able to access it. Instant store volumes. So these are storage volumes for temporary data that's deleted when you stop, hibernate, or terminate your instance, and those are like different stages in the instance lifecycle, which we'll be going into more detail later on. So these are just temporary, and then there's persistent storage volumes called EBS volumes, or Elastic Block Store, Amazon Elastic Block Store, and these allow you to persist your data in your applications, or in your whatever your use case is for an EC2 instance. And then you're aware of what regions and availability zones are. So EC2 does allow for multiple physical locations for your resources, and these include both for your instances and for Amazon EBS volumes. So this allows you to really ensure that you can build highly available and fault tolerant systems. So you can have your systems or your servers spread out across different regions, and even within regions across different availability zones. So you can specify all of that, all the way down to actually the racks within the availability zone. So you can specify, and we'll learn this when we're learning about placement groups, but you can even specify whether or not your instances should be located on the same racks within your within the data warehouse, or the data center where the availability zone is located. So you have complete control over everything to do with where your instances are located, and this can allow for highly available. Remember, high availability means accessing, being able to access from anywhere in the world, and fault tolerant, which means that it's highly, even if things go down, you have other saved versions or other versions elsewhere, and so it makes for very robust applications. And then we have another feature called security groups, and security groups are basically a firewall that enables you to specify the protocols, ports, and source IP ranges that can reach your instances. So traditionally, right, you would need like a Linux admin to be able to manage all of that, and it would get very, Linux does a pretty good job of allowing you to manage it, but still, nowadays with AWS, you can do this all just visually, drag and drop, select, so on and so forth, and you don't need to go into your actual Linux instance to specify all of these details. Elastic IP addresses, we're going to also be covering this in depth later on, also abbreviated as EIPs. So these allow you to basically, I'm going to be covering this in more detail later on, but essentially when an instance is created, it'll have a temporary public IP, and whenever it restarts, it'll be assigned a new public IP address. So elastic IP addresses are static IPv4 addresses for dynamic cloud computing. So you can assign a stationary, fixed, static IP address to your instance. And this is very important, especially if you want it to be able to be accessed from the internet or from somewhere outside your VPC, a virtual private cloud. And also very useful for managing downtime on servers. So if one of your servers goes down and you do have a backup server, you can assign the Elastic EP to the other server, and you know, while you're fixing up the other server, and you know, to the user there's no difference. They're still accessing the same app through the same IP address, but in the backend you're managing downtime. And tags are basically metadata that you can create and assign to your Amazon EC2 service resources, very similar to what we did with IAM users. And then virtual private clouds or VPCs, and you know these as virtual networks you can create that are logically isolated from the rest of the AWS cloud, so they belong to basically you, and you can optionally connect these to your own network. And so yeah, you know, this is all very important for EC2. Now before we go further, you know, EC2 is a huge topic and there's a lot to cover. Before we go further, let's get our hands dirty. Let's go and create an instance, okay? And then throughout the rest of this section, we'll go back in and, you know, we'll learn all the other stuff, like, you know, all the other details and settings and that kind of stuff when it comes to EC2. But for now, let's just go and let's do some hands-on and let's create ourselves an EC2 instance. This video will be just a hands-on video. No slides for this one. I'm just going to be showing you how to install just some common software onto your Linux instance, your EC2 instance. And you know, I just picked, you know, the top 3, probably the most common piece of software that people who would use AWS EC2 instances would be installing on their servers. And these are actually not Apache, but you know, Git and Docker are probably, for me, the single most installed piece of software on EC2 instances, because you know, obviously I pull in my application codes from Git, you know, from a private repository, from GitHub using Git, and then I always use Docker just to standardize my work environments and my dependencies, that kind of stuff. So you know, whenever I initiate an instance, the first thing I do is install Git and Docker. And in the next video, you'll see how you can actually use something called user data to have AWS actually run these commands for you directly when you initiate an instance, so you never have to run them again manually. And then still further on, I'll show you how to create AMIs, where you can actually create images of your instance with this piece of software installed, and all you have to do is create a new instance from an existing image, and you don't have to ever install anything again. But for the sake of this video, you know, we want to get our hands a little bit dirty using Linux and actually installing stuff and seeing how that works. So again, I just picked these randomly, you know, just so you know, we can have some experience installing stuff on the instance, and just so we know we have a list of commands that we can use to later, you know, automate this process using user data. So with that said, let's jump right back into our AWS console, and here we are. We have our instance that's running. So obviously the first thing we want to do is we want to make sure that our ports are open, yes, and you know, our status checks have been passed. And then we can just select our instance like so and connect. We have the proper user, EC2 user, and we connect. So probably the easiest example, the simplest thing to install be Git. But before we install anything, we just want to make sure we update our instance, because you know, there might have a new software updates or some, you know, security patches or some, you know, anything that might have come out since we first initiated this instance. So we can use sudo yum Those of you who are familiar with, Ubuntu or Debian-based distributions, you might be used to apt-get. But for Linux, for the AWS Linux 2 instance, we're going to be using yum to install stuff. And update, and we can do -y, which just lets, if it asks for any confirmation, we just give it a yes. And no packages marked for update, and that's probably because I'm recording this all in one day, and so I've already I've just created this instance maybe a few hours ago, so obviously there haven't been any updates since then, so that's not a problem. We can just go right into installing Git. So again, for that we're going to use sudo. Again, for those of you who are not familiar with Linux, I do advise that you do go and watch a couple of very quick introductory videos on Linux and how to use the command line interface, or like the terminal for a Linux operating system. Sudo basically gives us root privileges for that particular command. So if you were to just write su, for example, so like sudo su, or some variation of su depending on the distribution, it would actually change our user to the root user, but that's not advised. Just like we don't advise you to log into AWS using your root user credentials. That actually comes from Linux administration, where it's not advised that you use your root user for daily tasks. So instead we use sudo, which gives root privileges to that command, and that's it. And so that's it. It keeps stuff pretty safe. When you don't use it, you don't have root privileges, and when you do use it, you do have it just for that instance. So now we're installing Git first, just because it's a little bit easier to install than Docker or Apache. So let's use yum again. Install Git -y, and there we go. It's installing. Let that install, and we're done. Now we can just use git clone and just put in address of any repo in a Git repository, and you can just clone that repository right on into here. So that's pretty cool. Let's now install Docker. So since we're using an Amazon Linux 2 instance, Amazon actually makes it easy for us to install Docker. Amazon Linux extras, install Docker. So this is kind of the benefit of using a AWS backed instance, because they have put in some useful software and that kind of stuff for us to easily access and install. Otherwise it might be a little bit more difficult and require a little bit more knowledge of Linux. So if we run this, there we go, Docker is being installed, and it's asking us if we're okay with 270 megabytes being downloaded, and we are, or 65 megabytes being downloaded and 270 being installed. We are, because our instance has enough juice to manage that. Otherwise it would be pretty useless. So let's just let that install, and there we go. Docker is now installed, and we can start the Docker service or the Docker daemon like so, and we can create, or we can add an EC2 user to the Docker group, or we can add, our EC2 dash user to the Docker group, so you can execute Docker commands without using sudo. And we can do that like so. Again, for any of these commands, if you're confused, you can just easily look them up. Linux has been around for so long that every question has pretty much been asked and explained. For example, you can pull up the man pages for user mod, man user mod, and it's modify user account, and we basically use the A option, which is add the user to the supplementary groups, used only with the -G option. And what is the -G option? -G is the group, so a list of supplementary groups which the user is also a member of. Each group is separated, etc., etc. If the user is currently a member of a group which is not listed, the user will be removed from the group. This behavior can be changed via the -A option, which appends the user to the current supplementary group list. So basically here, if we pull up our previous command using the up arrow, we can see that we're adding to the group Docker the user EC2 -user. So with that being done, we can now log out and log back in again to pick up the new Docker group permissions, so that those can be those could start functioning. And then so let's do that, and then we just log back in, and then we can see if it's actually working. Docker info, and there we go. Docker's up and running. Do we have any containers up? No. Do we have any images? No. But Docker's there. It's up and running. So that's pretty cool, right? Now all you need is an image or Docker file in your application. Now you can get it running on here without having to worry about any other dependencies, because you'd have taken care of those in your Docker file. Now, lastly, let's look at how we can install an Apache server. Now, I personally don't use Apache server too often because I'm not a web developer, but it is a very common thing, and obviously there's Nginx as well, and other options. But let's go ahead and just try for Apache. And so let's first clear our screen, Control L. So let's install the Apache web server using sudo yum install httpd x86_64. Let's go ahead and install it. And that was quick. So I've cleared the page again. So we can start the web server using system control start httpd.service, and then we want this to persist throughout our sessions. We don't want it to stop every time we exit or log out, right? So we have to enable it. Sudo system control enable httpd.service, and now we can test to see if the web server is actually up and running. If it is, right, it should be returning something on the port 80, because this is a web server. And there we go. We get a very simple static web page, just an HTML file, a web page. So this means that on the local machine, so this is not exposed. Remember, we do not have port 80 exposed to the public, exposed to external traffic, but internally within our network on port 80, we now have a web page that is showing, and that's because the Apache web server is up and functioning. So curl just basically lets you fetch or access a URL. So by default, right, it's just pulling in the page or whatever is existing in the URL that we supplied it. In our case, it's localhost 80. So now because this is a kind of an ugly web page here, we can actually change it. So we see this ugly yet simple static HTML page that is presented to us, showing us that the Apache web server is running on port 80 and is successfully serving pages, web pages. Now, because this is a very ugly page, let's replace it with just a simple, hello world or something like that. Just, so we don't have to deal with this. So we can actually, what we can do, so echo is a function within Linux, or a command, if you will, that basically lets you display a line of text. That's all it does. So if you write echo hello world, it just prints hello world. And if we pipe this instead into a file in var/www/html/index.html, now we've basically written hello world into this file, and we can view that using Nano. It's a very simple text editor within Linux, and we see that we've written hello world into this file. Okay, so now when we do curl localhost 80, we're presented with a very simple web page that just contains the text hello world. So that's pretty cool, right? And in fact, what we can do is you can get your host name like so. So this is our host name. We can see our local IP address and then compute.internal, and we can serve a web page that gives the user, the one who accesses the web page, the host name of our instance, right? That would be pretty cool. So we can do hello world, let's say from host name, and that just runs that command and gives the output of it. So like, see hello world from, and that's the host name. So the $ and the parentheses, it'll just run that command and it'll give you the result of it within your text. And so we can pipe that into var www/html/index.html, and then now if we do a curl localhost, we get this page. So this is actually a web page, and in a couple of sections I'm going to show you how to set the security group so you can view this page from a browser. You'll see that we will be presented with a web page that contains this text. So that's pretty cool, right? So we're basically giving the host name of our instance to anybody who accesses our instance through the port 80, which is the HTTP port. So that's so that's very cool. This means that we have a functioning and working Apache web server up and running. So again, you might not be interested in Apache web server. It might not be what you need for your line of work, but it is very common. So I wanted to give you some more technical hands-on experience, just installing something that's more, that we can play around with. And hopefully that gave you some good exposure to Linux as well. Again, this is not a Linux course, so I'm not going to be going into any further depth, but you are advised to, learn as much as possible when it comes to Linux if you do intend to be a high quality DevOps engineer. So in the next video, I'm actually going to show you how we can put all these commands into a single file and supply it to AWS as something called user data, so that AWS can actually run these commands for us while initiating the instance, and therefore we won't have to log in and do all of that on our own, and we can have Git, Docker, Apache, or any other software program installed on our instance while it's being initiated. Hello and welcome back. So now that we've got a very good basic understanding of what EC2 is, and we've actually created our first EC2 instance, and we know how to walk through those steps, those 7 steps, and to run the instance and just be able, we know our way around that tab, that instance tab, and we can just look at the IP address. We can view the some specific information like IP addresses and so on and so forth. The next thing we want to do is to actually access our instance. So we want to get into it. Remember, an instance is essentially just a computer somewhere on AWS's servers or in AWS's data centers. And so a computer is just an operating system. And because we're dealing with servers and administration, that kind of stuff, we prefer the operating system to be Linux. And therefore, we'll be using Linux commands and so on and so forth. But it's essentially just a computer running Linux. And so we want to access it. Maybe we want to install some certain software on it. Maybe we want to put our application on it. Maybe we want to put up a database on it, set up an API or whatever the use case may be. We want to actually access it. We want to be able to log in to that computer, to that virtual remote computer, and do whatever we want with it. So for that, we're going to be using SSH, which is, Secure Shell Access. And I'm not going to be going into too much detail because this is not a Linux course. And this is not a system administration course by any means. I'm expecting you to be at least familiar with what Linux is and how to use Linux just very roughly, and to know what SSH is. If not, do go and watch some tutorials on that. But it shouldn't be too much of a problem as long as you follow what I'm teaching here. So we want to connect to our Linux instance using SSH. First thing you want to do is, before you connect to your Linux instance, you should complete some prerequisites. So check your instance status. After you launch an instance, it can take a few minutes, as you saw, right? When it took some time for the instance to be ready, so that you can connect to it. If you remember, there was a status column and it was initializing. So we can't connect to it while it's initializing. So just make sure your instance is ready and check that your instance has passed its status checks. There were 2 out of 2 status checks that had been passed right after a few minutes had gone by. And you can basically just refer to the status check column in the instances page. So once you've made sure that your instance is initialized and it's running properly, next would be to get the public DNS name and username to connect to your instance. So I showed you where you can find the public DNS name down below, and where when you select the instance, you see down below some details on the instance. And I showed you where you can find the public DNS name. You could also use the public IP name, but the important thing is that public. The keyword here is public. You can't use the private IP address or the private DNS name to access it, because the private IP address is used only within your system, within your VPC, for other services to refer to and address and communicate with your EC2 instance. So it's not exposed to the public, and when you do expose your instance to the public, you have to use the assigned public IP and the DNS names. So just make sure of that. That's a very common mistake that newcomers make. They either try to use the private IP address or they use the public IP address, and then for some reason they reboot their instance, and then a new public IP address is assigned, and they're not aware of that, because every time you reboot or you restart an instance, a new public IP is assigned unless you allocate a elastic IP for that instance. So they don't realize that, and they continue trying to connect using the previous public IP, and that obviously doesn't work. So after you do that, go ahead and install an SSH client on your local computer as needed. Now, this will be easier for some. Your local computer might have an SSH client installed by default, especially if you're using a Linux or a Mac computer, or I think even the latest Windows computers now do have it installed by default. You can verify this by typing SSH at the command line, and if your computer doesn't recognize the command, that means obviously it's not installed, and so you should install an SSH client. So recent versions of Windows Server 2019 and Windows 10 should have OpenSSH included as an installable component, and early versions of Windows allow you to download and install OpenSSH. And obviously, if you have Linux and Mac OS, you can download and install OpenSSH without a problem. So there are other clients as well. So I'm going to leave this up to you. This is so it differs so vastly between different operating systems and different devices and that kind of stuff that I'm not going to bother in this course trying to troubleshoot every possibility and every problem that might arise, because it's not really an AWS issue. SSH access is very important. It's very crucial for you to know how to access your EC2 instance. But thankfully, AWS does supply or give us a way to access our EC2 instances directly from the browser. So for this course, I'm going to be relying on that, and I'm going to show you that in a few slides. But know that traditionally you would access your EC2 instance as you would access any other server through a client, an SSH client. And so, it is advisable, if you do have the time, to just go and figure out how to do that for your particular operating system and your particular computer. Now, and then, once you have your client installed, you can access it, you can access your instance. And the key things you need to know are the path to your key that you downloaded when you created your instance. If you remember, a .pem file, .pem file that you downloaded. This is the private key, and AWS has the public key. So you're going to need this to access your instance. And so you have to specify the path to it. And you need to obviously know your public instance DNS name here and your instance username. The instance username will change depending on the operating system of your instance. For example, Ubuntu comes with a default username Ubuntu with lowercase letters. The AWS Linux 2 server comes with a default username of EC2-user. And if you're using any of the other servers, you'll have to look that up. But it's probably something very standard. So for example, in our case, we have a AWS Linux 2 server. So you would write EC2-user @ and then your public DNS name. And then obviously, the command is SSH-I. So you type this in to your client, to your terminal, your client terminal for SSH access, and you should get a response like this. And if there's a timeout, like if nothing loads and it looks like it's trying to access it, but nothing loads, that means that you probably don't have your security groups properly installed. This means that or attached or configured, which means that most probably you don't have your SSH port 22 open for access, or you have it open for access, but you specified a certain IP and you're not accessing it through that IP. For example, maybe you specified my IP, but then your IP has changed since then, or something of that sort. So generally, if it just keeps trying to connect but nothing loads, go and check your security groups and make sure that you have the proper ports configured properly. And so if you do see this, then congrats. That means that your port 22 is open and you're able to access it. And just enter yes, and then you should get something like this, and now you're connected. Okay, so it's not that complicated. Just a couple things that you should make sure you don't forget. It should be your public DNS name. Just go back into your instance in AWS on the console, right, and just make sure that you have the correct public DNS name. Make sure your username is correct. Make sure that you're using the correct private key file and that you've specified the path correctly. And then it should be fine. There are some problems that might come up, especially when you're dealing with Windows, but they're all pretty well documented. Just search it on Google. You should be able to find an answer. Now, if you do receive an error while attempting to connect to your instance, you can search for like troubleshooting connecting to your instance AWS docs or something like that into Google, and you should be able to find a nice documentation page clearly explaining all the possibilities for your problem. However, for our case, and most probably for your most of your use cases as well, EC2 Instance Connect should be enough. So now we're not going to be dealing with SSH clients and all of that, because if I were to use an SSH client to connect to my instance for you in this tutorial, in this course, it's not going to be directly applicable to your case. It's not going to be easily reproducible by you. You might have a different operating system or a different version of the same operating system, or you might even just have a different version of the SSH client. Like, there are so many ways that it can go wrong. And since the focus of this course is not, just general Linux remote access, but rather it's AWS, I'm going to try to stay within the confines of AWS. So I'm going to be using this feature that's very pleasantly available in AWS called EC2 Instance Connect. And this basically allows you to connect to your instances in a simple and secure way. And you can do this directly from your browser without having to download anything, which is very useful. So Instance Connect handles the permissions and provides a successful connection. So because you're connecting directly from the browser window and directly from your instances page in your AWS console, AWS already knows the public DNS, and AWS already has the keys. So there isn't anything you really need to do. You just connect. As long as you know the username of your instance, you can very easily connect to your instance, and it saves a lot of hassle. Now, there are a couple things you need to make sure of. The instance that you're running should have one of these two Linux distributions. So as of now, these are the two that support Instance Connect. By the time you're watching this video, some other versions might also adopt support for Instance Connect. But for all intents and purposes, right, we're not going to really need ever to use another type of instance unless you're doing something very specific. Maybe you're a .NET programmer or something like that. But you're either going to be using Amazon Linux 2 or Ubuntu, and hopefully something at 16.04 or later. So you shouldn't have any problem connecting, but just make sure that that you're not trying to connect with Instance Connect to another type of instance. Another thing to make sure of is that port 22 is open. Now, this does seem so simple, and it does go without saying, but unfortunately, a lot of people do make this mistake. They try desperately to connect to their instance, and they troubleshoot everything, and then they find out that their port, their SSH port, is closed or doesn't have the proper configuration to allow for their IP address. So always make sure that port 22 is open. You can't connect to an instance through Instance Connect without port 22 being open, and that is because Instance Connect is essentially an SSH connection. It is an SSH connection, and so that's probably the cause of the confusion. People who are not familiar with Linux and not familiar with SSH just have been spoiled by the fact that Instance Connect exists, so they've never had to learn what SSH is and what port 22 is. And so they don't make that connection, right? That they need to have port 22 open in order to use Instance Connect, right? They're probably thinking, I'm here in the browser, I can see my instance here, the details of it in AWS. Why can't I just connect to it? But don't forget, your instance is a virtual computer in the cloud. It's somewhere far away, and it has its own credentials and has its own security. And so you need to follow those steps to be able to access it, even if you're accessing through the browser within the same AWS console that the details of your EC2 instance lie. You're gonna still have to use SSH to access it, right? So don't forget about that, and make sure that the instance has a public IPv4 address. And your EC2 Instance Connect does not support connecting using IPv6 address, but that's not a problem because we're not going to be dealing with IPv6 addresses anyway. But just, it's worth a mention. So now let's jump straight into our AWS console and get some hands-on practice connecting to our EC2 instance. Again, we're not going to be using an SSH client downloaded onto our computer, but we're going to be using the Instance Connect feature, which is a browser-based SSH client. So here we are exactly where we left off in the last video. We have our instance. It's still up and running. And remember, we have to check to make sure that it's passed its status checks. So 2 out of 2 checks passed. So this is up and running. This is now ready to be connected to. We do have port 22 open inbound as an inbound rule, and it's allowing all IP addresses, so that's okay. And if we go into here, we have, okay, let that refresh. Let's click on our instance again, and we do have a public DNS. So if you did download an SSH client, this is what you would use using the command I gave you, the SSH command, and using the location of your private key as well as the username. So in our case, the username for this instance is EC2. I can write it here for you, EC2-user, because it is a AWS Linux 2 instance. So the way we're going to connect to this is by using connect here. That's how simple it is. And this is the Instance Connect feature. We click on it, and here there are some other options, right? But we're concerned with EC2 Instance Connect, and it's confirming that, you know, it's this is the instance we want to connect to, and this is its public IP address. So this is what this browser-based client, which is EC2 Instance Connect, will use to connect to the instance, because remember, we need to use a public IP address. We can't connect remotely to anything using its private IP address, because that private IP is only used within that private network, and we don't have access to that private network. In our case, that private network is our VPC. So the username is EC2 user, and we connect. And hopefully, if our port is open and everything's correct, we should be able to log in. And there we go. We are now within our instance. This is our instance. You know, we can do a, you know, simple, you know, man cd, you know, just any Linux command, and, you know, just to show that it's working. And, you know, we're here. We're in our instance, and you can see that, you know, we have the user EC2-user, but then for IP here, this IP doesn't look like our public IP, right? If we go back into instances, our public IP address starts with 52, and that starts with 172. Why? Because that is actually the private IP address. So we're confirming that that is the private IP address of our instance. So this means that we're in, right? We have access to the internal local network. So you can do Control L to clear everything that's there. So if we do ifconfig A, we can see that the eth0 is set to the private ID. So by the way, so, you know, now we're in Linux. Again, this is not a Linux course, but, you know, you should know some simple commands. So if you have any, you know, if you ever need to look something up, like ifconfig, you can just write help, and this is the pipe operator, and then just pipe it into the function more. So you can get some information on what that function is and how to use it, or that command, I mean, like its usage, and, you know, some descriptions of it. If you want a more detailed setup description for, or just pull up the manual pages for that command, you can use man. So ifconfig, and here ifconfig, it says configure a network interface. It pulls this in from the Linux system administrator's manual, and, you know, these are just some quick ways to use it. A note, it says this program is obsolete. For replacement, check ip-adder or ip-link. For statistics, use ip.dash.link, that kind of stuff. So, etc. So, like, anything you want to know about this command, basically description. Options, we use the -a option, so display all interfaces which are currently available, even if down. And you can use J to scroll down, and then you can press Q to just exit it completely, and then Control L to clear the screen again. So these are just some basic Linux commands. Now we will be coming back into the instance in the next video, where I'll show you how to install, some stuff, some software that you might need, like Docker or Git or an Apache server and that kind of stuff. But for now, we don't really need to do anything here. So, we've successfully accessed the instance, which is very, very good. And we can just exit, and that logs you out, and you can just close this tab. Now, I want to show you a couple things. First of all, if we were to go into security, and if we were to remove this security group, now again, we haven't gotten to security groups yet, but if we edit inbound rules and we just delete these and we save, okay, don't worry, I'm going to be going into the details of security groups in the following videos. But for now, if we go back into our EC2 instances, by the way, after we did create the instance, if you were to come back in the dashboard, you would see that we have one instance that's running. We still have not allocated an elastic IP because that's not done automatically. When you create an instance, you have to do that yourself if you want to. But we have a key pair, remember, because we downloaded it, and you can actually click here and you can see, the name. Remember, we gave it the name my-first-instance. And then we have now two security groups, because now one was created for this instance, and we have obviously an instance. So let's go back into instances, and we click on our instance. And now if we go into security, we see that we have no inbound rules. So that means that port 22 is closed. This means that if we try to connect to our instance, it's going to keep trying to connect, but it's not going to show anything, and eventually it'll time out, right? So this is a timeout. If you're using an SSH client, then you'll get some other form of timeout screen. But that basically means most probably that you have a problem with your security groups. You should go back in and make sure that you have port 22 enabled. You should make sure that you have port 22 enabled for your instance. Okay. Now, another important thing to keep in mind is that this public IP address will change, okay, depending on, so this is temporary, right? So let's make a note of this, right? Let me copy this, okay? And let me reboot my instance, okay? So if you select your instance and you click on instance state, so far we've used connect, and this is just the refresh button, and we've used launch instances. We haven't used actions yet, but basically, connect is there. Other stuff we'll be using later on is all there, but we want to change the instance state. We can terminate it, but then we can never recover that instance. We'll have to create a new one. Again, I'm going to be going over this in the instance lifecycle video, but we can stop it and start it again, or we can just reboot the instance. So let's reboot it. Okay. Now, this refresh button is pretty important because keep in mind that the actions that you're doing, right, in your AWS console, in your dashboards, when you click on something, this is affecting physical hardware, right? When you launch an instance, right, something physically is being created, right, is being allocated for you. And likewise, when you terminate it, right, an actual computer is being shut down, right? So it's not always easy for AWS to automatically update everything, current state of everything on your screen. So you will need to use a refresh button to make sure that everything is up to date and does reflect the current state of everything. So now let's wait a little bit longer, or in fact, in order to just make this more guaranteed, and for me to show you what I mean by there being some latency in terms of updating the information, let's just go ahead and stop the instance. Okay, now be careful, don't terminate it, because if you do terminate it, you can't restart the instance, it's gone. Okay, so now we've stopped it, but if we refresh, and we remove this filter, we'll see that the instance state is still stopping. It hasn't stopped yet. It has not stopped as of yet. And it still has its IP address. Now we have to refresh it again, and there we go. See, it has stopped now. So now that it's stopped, all its public IP addresses, and DNS addresses have been stripped, and it no longer has any public IP address or any public DNS address, and therefore it's not, and it's not saved anywhere either. So now if we were to restart this same instance, the very same instance, right? The same ID, the same name. I named it my first instance, and it's pending. Let's refresh. It's still pending, and there we go. It's running, but now it has to initialize. But if we click on it, even though it's still initializing, we do have a new public IP address and a new DNS. So this is what I wanted to show you guys, that when you do restart or reboot your instance, or you shut it down and you start it back up, you will get a new public IP address. Remember, our old public IP address was this 52.15.168.32, and the new one is 18.219.77.81. So that's very important. This means that if you're using an SSH client and you have your login credentials saved as this IP address, and then all of a sudden you can no longer access your instance and it's just timing out, what's wrong? Maybe if you do have port 22 open, maybe your public IP address has changed because you've rebooted your instance. So that's something you got to keep in mind. And now, right, when we go into launch instances, when we go into connect, right, AWS is smart enough that it updates the IP address because it knows, right, it's the ones that gave you the new IP address in the first place. But you have to also make sure on your end, when you're using a non-browser based or non-AWS based SSH client, that you're also updating the IP address. So now we can connect with this new IP address, and obviously we can't connect because we do not have port 22 open. So we can just go into the security group very quickly, and again I'm going to show you how to do this all. And we go into SSH, and we want anywhere save rule, and now we should be able to retry, and there we go. We have access, and this is the new updated public DNS that is used, and we still have the same private IP, which is very, it never changes unless we terminate the instance completely and delete it, right? So that's how you connect to your EC2 instance using Instance Connect from here. And now that you know how to access your EC2 instance, in the next video I'm going to be showing you how to actually download and install important programs and software on your EC2 instance that you might want to use later on, such as Docker and Git and an Apache server. This video will be just a hands-on video, no slides for this one. I'm just going to be showing you how to install just some common software onto your Linux instance, your EC2 instance. And I just picked the top 3, probably the most common piece of software that people who would use AWS EC2 instances would be installing on their servers. And these are actually not Apache, but Git and Docker are probably, for me, the single most installed piece of software on EC2 instances, because obviously I pull in my application codes from Git, from a private repository, from GitHub using Git, and then I always use Docker just to standardize my work environments and my dependency, that kind of stuff. So whenever I initiate an instance, first thing I do is install Git and Docker. And in the next video you'll see how you can actually use something called user data to have AWS actually run these commands for you directly when you initiate an instance, so you never have to run them again manually. And then still further on, I'll show you how to create AMIs, where you can actually create images of your instance with these pieces of software installed, and all you have to do is create a new instance from an existing image, and you don't have to ever install anything again. But for the sake of this video, we want to get our hands a little bit dirty using Linux and actually installing stuff and seeing how that works. So again, I just picked these randomly, just so we can have some experience installing stuff on the instance, and just so we know we have a list of commands that we can use to later automate this process using user data. So with that said, let's jump right back into our AWS console, and here we are. We have our instance that's running. So obviously the first thing we want to do is we want to make sure that our ports are open, yes, and our status checks have been passed, and then we can just select our instance like so and connect. We have the proper user, EC2 user, and we connect. So probably the easiest example, the simplest thing to install be Git. But before we install anything, we just want to make sure we update our instance, because there might have a new software updates or some security patches or some anything that might have come out since we first initiated this instance. So we can use sudo yum. Those of you who are familiar with Ubuntu or Debian based distributions, you might be used to apt-get. But for Linux, for the AWS Linux 2 instance, we're going to be using yum to install stuff, and update, and we can do -y, which just lets if it asks for any confirmation, we just give it a yes. And no packages marked for update, and that's probably because I'm recording this all in one day, and so I've already I've just created this instance maybe a few hours ago, so obviously there haven't been any updates since then, so that's not a problem. We can just go right into installing Git. So again, for that we're going to use sudo. Again, for those of you who are not familiar with Linux, I do advise that you do go and watch a couple of very quick introductory videos on Linux and how to use the command line interface, or like the terminal for a Linux operating system. Sudo basically gives us root privileges for that particular command. So if you were to just write su, for example, so like sudo su, or some variation of su depending on the distribution, it would actually change our user to the root user, but that's not advised. Just like we don't advise you to log into AWS using your root user credentials. That actually comes from Linux administration, where it's not advised that you use your root user for daily tasks. So instead we use sudo, which gives root privileges to that command, and that's it. And so that's it. It keeps stuff pretty safe. When you don't use it, you don't have root privileges, and when you do use it, you do have it just for that instance. So now we're installing Git first, just because it's a little bit easier to install than Docker or Apache. So let's use yum again. Install Git -y, and there we go. It's installing. Let that install, and we're done. Now we can just use git clone and just put in address of any repo, any Git repository, and you can just clone that repository right on into here. So that's pretty cool. Let's now install Docker. So since we're using an Amazon Linux 2 instance, Amazon actually makes it easy for us to install Docker. Amazon Linux extras, install Docker. So this is kind of the benefit of using a AWS backed instance, because they have put in, some useful software and that kind of stuff for us to easily access and install. Otherwise, it might be a little bit more difficult and require a little bit more knowledge of Linux. So if we run this, there we go, Docker is being installed, and it's asking us if we're okay with 270 megabytes being downloaded, and we are, or 65 megabytes being downloaded and 270 being installed. We are, because our instance has enough juice to manage that. Otherwise it would be pretty useless. So let's just let that install, and there we go. Docker is now installed, and we can start the Docker service or the Docker daemon like so, and we can create, or we can add an EC2 user to the Docker group, or we can add, our EC2 dash user to the Docker group, so you can execute Docker commands without using sudo. And we can do that like so. Again, for any of these commands, if you're confused, you can just easily look them up. Linux has been around for so long that every question has pretty much been asked and explained. For example, you can pull up the man pages for user mod, man user mod, and it's modify a user account, and we basically use the A option, which is add the user to the supplementary groups, used only with the -G option. And what is the -G option? -G is the group, so a list of supplementary groups which the user is also a member of. Each group is separated, etc., etc. If the user is currently a member of a group which is not listed, the user will be removed from the group. This behavior can be changed via the -A option, which appends the user to the current supplementary group list. So basically here, if we pull up our previous command using the up arrow, we can see that we're adding to the group Docker the user EC2 -user. So with that being done, we can now log out and log back in again to pick up the new Docker group permissions, so that those can be, those could start functioning. And then, so let's do that, and then we just log back in, and then we can see if it's actually working. Docker info, and there we go. Docker's up and running. Do we have any containers up? No. Do we have any images? No. But Docker's there. It's up and running. So that's pretty cool, right? Now all you need is an image or Docker file in your application. Now you can get it running on here without having to worry about any other dependencies, because you'd have taken care of those in your Docker file. Now, lastly, let's look at how we can install an Apache server. Now, I personally don't use Apache server too often because I'm not a web developer, but it is a very common thing, and obviously there's Nginx as well, and other options. But let's go ahead and just try for Apache. And so let's first clear our screen, Control L. So let's install the Apache web server using sudo yum install httpd x86_64. Let's go ahead and install it. And that was quick. So I've cleared the page again. So we can start the web server using system control start httpd dot service, and then we want this to persist throughout our sessions. We don't want it to stop every time we exit or we log out, right? So we have to enable it. Sudo system control enable httpd.service. And now we can test to see if the web server is actually up and running. If it is, right, it should be returning something on the port 80 because this is a web server. And there we go. We get a very simple static web page, just an HTML file, a web page. So this means that on the local machine, so this is not exposed. Remember, we do not have port 80 exposed to the public, exposed to external traffic, but internally within our network on port 80, we now have a web page that is showing, and that's because the Apache web server is up and functioning. So curl just basically lets you fetch or access a URL. So by default, right, it's just pulling in the page or whatever is existing in the URL that we supplied it. In our case, it's localhost 80. So now because this is a kind of an ugly web page here, we can actually change it. So we see this ugly yet simple static HTML page that is presented to us, showing us that the Apache web server is running on port 80 and is successfully serving web pages. Now, because this is a very ugly page, let's replace it with just a simple, hello world or something like that. So we don't have to deal with this. So we can actually, what we can do, so echo is a function within Linux, or a command, if you will, that basically lets you display a line of text. That's all it does. So if you write echo hello world, it just prints hello world. And if we pipe this instead into a file in var/www/html/index.html, now we've basically written hello world into this file, and we can view that using nano. It's a very simple text editor within Linux, and we see that we've written hello world into this file. Okay, so now when we do curl localhost 80, we're presented with a very simple web page that just contains the text hello world. So that's pretty cool, right? And in fact, what we can do is you can get your host name like so. So this is our host name. We can see our local IP address and then compute.internal, and we can serve a web page that gives the user, the one who accesses the web page, the host name of our instance, right? That would be pretty cool. So we can do hello world, let's say from host name, and that just runs that command and gives the output of it. So like, see hello world from, and that's the host name. So the $sign and the parentheses, it'll just run that command and it'll give you the result of it within your text. And so we can pipe that into var www/html/index.html. And then now, if we do a curl localhost, we get this page. So this is actually a web page, and in a couple of sections I'm going to show you how to set the security group so you can view this page from a browser. You'll see that we will be presented with a web page that contains this text. So that's pretty cool, right? So we're basically giving the host name of our instance to anybody who accesses our instance through the port 80, which is the HTTP port. So So that's very cool. This means that we have a functioning and working Apache web server up and running. So again, you might not be interested in Apache web server. It might not be what you need for your line of work, but it is very common. So I wanted to give you some more technical hands-on experience, just installing something that's more, that we can play around with. And hopefully that gave you some good exposure to Linux as well. Again, this is not a Linux course, so I'm not going to be going into any further depth, but you are advised to, learn as much as possible when it comes to Linux if you do intend to be a high quality DevOps engineer. So in the next video, I'm actually going to show you how we can put all these commands into a single file and supply it to AWS as something called user data, so that AWS can actually run these commands for us while initiating the instance. And therefore we won't have to log in and do all of that on our own. And we can have Git, Docker, Apache, or any other software program installed on our instance while it's being initiated. Hello and welcome back. In this video, we're going to be going over something called user data. And this pertains specifically to instances, hence why this section is called instance user data. User data, contrary to what you might be thinking when you hear the word user data, has nothing to do with users. User data is just a way for you to specify certain functions, to specify certain commands that you would execute in your instance after you've had it initiated, to set things up. And you don't want to do that every time, so you compile it onto a file and you supply it to the wizard when you're creating the EC2 instance. And after it gets created, AWS will run that file or those commands on its own. So by the time you get to logging into your instance, you'll have all of those already executed. And so whatever you installed, for example, in our case, I'm going to be using the same examples we used in the last video, where we're going to be installing Git and Docker, and as well as an Apache server, and also get that Apache server to output the host name when a user accesses it. And obviously we want that to persist, right? So that even if you log out of the instance, it should continue to be able to do that. So basically everything we did in the last video, but this time it's going to all be compiled together and supplied to the wizard during instance creation. And so we're not going to have to go in and run that again. And obviously the use of this is that, when you're creating a new instance, let's say you had to terminate your instance, or you just had to create extra instances, you never have to do all of this work manually. That's one benefit, right? It saves you time and effort, but also it keeps everything consistent, right? You know exactly what you're running every time. For example, if there's a certain version of a program that you're installing or downloading, it's not going to change, right? You're not going to have to remember which versions you did, or which order you did everything in, or which file names you saved stuff under, so on and so forth. So this is very useful. I myself find it very useful. The one thing that would be more useful than this would be to actually create images, so you'd never have to even install anything. But we're going to learn about that later on. So for now, this will save you a lot of time. Me personally, I worked for a long time on AWS without even knowing that this feature existed. But when I did find out, it saved me a lot of headache. and made a lot of things much easier for me. So let's just go through some very quick information on user data, some things to keep in mind, some things to know about user data. So obviously, like I mentioned, user data is passed into your launch wizard during launch. So when you're, remember when we had the first 6-7 steps that we were clicking through. So in one of those steps, we'll be passing in the user data. And then the purpose of user data is to perform common automated configuration tasks and even run scripts after the instance starts. And then you can pass in your user data in a number of different formats. So you can either pass it in as plain text, which is what we'll be doing. So basically we'll just be writing in all the commands that we would have normally run, or that we actually did run in the last video. We'll be typing those in manually. If you have it saved somewhere, you can copy and paste it as well. But you could also input user data into the launch wizard as a file, and this is useful for launching instances using command line tools for more automation, right? Or as basic stay encoded text. So we're going to be focusing on plain text, but a file would basically be the same thing as well. As long as they're not developing some very high level automated systems, you probably just want to make your life easier while launching instances, maybe because you want to save time and effort, or maybe because you're just launching more than one instance at the same time and you don't want to have to go and configure each of them on your own. So user data shell scripts must start with the hashtag ! Characters, and then obviously the path to the interpreter you want to be interpreting your script. So this is most commonly bash, and it will, and that's also what we will be using. So you want /bin/bash, and then finally keep in mind that all commands that are run from the user data that you supply the launch wizard will be run as the root user. So this means you do not need to specify specifically that the commands should be run as root users, as the root user, as we did in the past video, where we had to explicitly write sudo before each command that we wanted to be run as a root user, because we by default were not logged in as a root user. We were logged in as EC2-user. But in the case of user data, it's all going to be run as the root user, so you do not need to specify. In fact, you shouldn't specify. So don't use the sudo command. We will be erasing all of those from our user file data. So with that, let's jump straight into AWS and let's start using user data. So here we are. I just logged in as my user, and we are in the correct region. For me, at least, we're in the correct region. Make sure you are in the region that you're using EC2 in. So here we are. We've just logged into our console, the AWS management console, as our user that we created, not as the root user, and we are in our region. So watch out for that. Make sure you're in the right region, the region you're using your EC2 instances, or everything you've been doing your AWS so far in. You won't see your other instances in another region. So let's go into EC2. Now we have one instance running. Remember, that is the my first instance. So we've done a lot of work on this, right? We've launched it, we've logged in, we've installed Git, we've installed Docker, we've also installed Apache server, we've even configured it, right? So that it prints basically the host name of the instance onto the port 80. And we even tested that using curl on localhost :80. And we weren't able to test this in an actual browser yet because we still don't know how to do the security groups and how to expose port 80 to the world, but I'll be showing you that in the next video. Anyway, so a lot of work was done on this instance. Now, that work was a lot of manual work, time-consuming work, and not very easily scalable. So we want to essentially reduce all of that and put that into user data, and that's what we're going to do. So in order to do that, we have to launch a new instance, and because we do not want to exceed the limits of the free tier and end up paying, let's go ahead and terminate our first instance. Now I know that might seem a little scary, but the purpose of me deleting this is actually also to give you a little bit more courage in experimenting and trying stuff In AWS, you'll learn a lot by just redoing a lot of stuff, right? Just like, for example, going in and launching instances, or setting up different systems and that kind of stuff. Because generally, every time you redo it, you'll discover something new. You'll find a better way to do it. You'll find a new option, new feature, that kind of stuff. So you should not be scared or nervous about playing around with this stuff, right? You've created this instance, and it's like, your first instance, and it has some special meaning for you. It has a special place in your heart. But we don't care. We're going to go ahead and terminate it. And why? Because we can just as easily create another one. And now even easier, right? Even more easily, because we're going to be using user data. So let's go ahead and go into instance state, and we terminate this instance. That's it. Now the instance is shutting down. Now don't forget, instance termination means that the instance will be gone forever, and you can no longer access it. It's gone. It's done. Unlike when we stop the instance. Now notice that we have to refresh it to update the instance state. Don't forget that there's an actual server in the backend that's being shut down, that's being closed right now. So that's why it might take some time, and that's why it might take some time for it to shut down. That's no problem. So now that this instance has been shut down and terminated, that's it. You can no longer connect to it. If you're using your own SSH program to connect to it, or if you're using here, you can't even, there's no way to connect to it. That's it. It's gone. But no worries, right? We remember everything we did to install everything we wanted to install on it, and we know all the steps. So we're just going to go right into launching a new instance. It's as easy as that. And now, since we're familiar with these steps, right, we don't have to think too much. Obviously there's a lot still to learn. I'm going to be teaching you guys about, AMIs and about different instance types and that kind of stuff. But for all our intents and purposes at the moment, we just know what to do, right? We go ahead and select Amazon Linux 2. And then from here, we're going to select the t2.micro instance type. And then we want to configure instance details, because that's where we're going to put in the user details. The user data, I'm sorry. So we don't want to just review and launch right away. Let's go ahead and configure instance details. And so down here in a section called advanced details, this might be collapsed in your version, but go ahead and open that up. And down here, you'll see a spot called user data. And this is where we'll be inputting our user data. Now, let's hover over this informative icon. It says you can specify user data to configure an instance or run a configuration script during launch. If you launch more than one instance at a time, the user data is available to all the instances in that reservation. So that means that up here, if we decide to launch more than one instance, let's say you want to launch 100 instances for some reason, this user data script file or text or whatever you put into here will be run across all of the instances. So essentially, you'll be configuring and installing and loading and doing all the things you were doing to all of your instances. So this is a huge advantage of user data, as I mentioned in the slides, scalability and just automating all of it, right? If you were to launch 100 different instances, you can't go into each individually and install everything you're going to do. That's not feasible, right? So let's go ahead and start writing our user data. Now, ideally, you should have this, in a file saved somewhere, right? And then you just copy and paste it. But for the sake of this video, we're going to be remembering or trying to remember everything we did. And in the last video, everything we did manually, and we're going to write it into here and go ahead and launch the instance. So now the first thing we have to do, if you remember the slides, is we have to start with the hashtag !bin/bash, because we're using the bash interpreter. Again, it's up to you. Bash, is not it's very common in Linux administration, and it will definitely help you, and there's definitely no harm in learning it. But for unless you're doing some very complex configuration and setup in the beginning, that requires loops or some sort of complex processes, then you probably don't need to learn Bash too badly. But obviously it doesn't hurt if you want to be a top-notch DevOps engineer. In our case, we're just going to be writing just the same commands that we would have written into the terminal directly, so we don't need to know any Bash programming. But Bash is the interpreter that will be interpreting our commands. The first thing we did, if you remember, I can't remember if we installed Git first or Docker, but let's just go ahead and install Docker first. Okay, so remember how we wrote sudo Amazon Linux extras install Docker, and then so now actually I think we updated the instance first. I guess in this case it would be the most updated version, but just for good practice, let's go ahead and update our instance first. So if you notice, we're not putting in sudo at the beginning. Why? Because all of these commands will be run as the root user. And remember, the purpose of sudo is to run the command, to tell Linux to run the command as a super user or as a root user. So we go ahead and delete the sudo. Now, it's very important to note that you can't write any commands here that will require user confirmation. Remember, for example, if we don't write -y here, and -y stands for yes. So if we just were to run this, right, so operating system would ask us to confirm that we want to continue downloading or installing, the software that's listed there. And so we would have to respond with a yes or a Y or something of that sort to confirm. So that's user confirmation. There is no way for us to receive any requests like that, right? Because this is going to be user data. It's going to be run by AWS directly. And so we have to force confirmation. And that's why we have to make sure to write the -y if we do think that the command will ask for confirmation. So now the next thing we did was to install Docker. And because we're using Amazon's Linux 2 distribution, they have a handy way of installing software like Docker. And then so we install Docker, but then we have to also start the Docker service. So at this point, the Docker will have been installed, because this will have run. It will have run its course, and Docker will have been installed. So then at this point, we can actually run the Docker daemon using service docker start, service docker start. And then, by the way, I did change my screen, so the layout and that kind of stuff might be a little bit different. It's not because AWS has changed while I'm recording this. It's just because the screen ratio and size changed. So, but it should stay the same for the rest of the course, so that shouldn't be a problem. Now we created our, we added the EC2 user to the Docker group, like so, and then we installed Git. So yum install Git, confirm as yes if anything is asked, and then we installed the Apache server. And if you don't remember what we did, just go back and review the last video. But then we started the Apache server service, and then we enabled it. So remember, the point of enabling the service is that it can persist, so that it can persist. If we don't enable it, it will work in that session, but then when we log out and back in, it will no longer be running. And in this case, this is extra important because AWS will be running this, and then it's done. It logs out, and then we're going to be logging in. And by the time we log in, the service will have stopped. And so we won't be able to see port 80, we won't be able to see Apache running. So that's why we have to enable it after starting it, so that it persists across sessions. And then finally, we put hello world from, and then we ran hostname, the long version, into index.html. And this essentially created a change the web page that appears on port 80 by default from Apache to the hostname of the instance. So this is what and we can go ahead and just make that a little bit longer so we can see everything. So this is our script, right? It's just a line by line version of the commands that we ran in the last video. We're updating the instance. We're installing Docker. We're starting the Docker daemon. We're adding our user to the Docker group so that we don't need to use the root user to access it. And then we're installing Git, and then we're installing Apache server. And then we are starting the Apache service, and then we're enabling it so it persists across sessions. And then we are changing the index.html file to display the host name of the instance. So just make sure you have no typos, because like when you're actually in the instance and you write something and you have a typo, you see it right away and you can fix it. But in this case, we're not going to be able to see it right away until we log into the instance and discover that it didn't work properly, and then we'll have to go back and change our file and launch a new instance, or we'll just have to continue manually in that instance, right? So just make sure you don't have any typos. I hope I don't have any typos because I did not copy and paste. I wrote this all in front of you so that you could have a more immersive experience. So we're just gonna hope that this works. We do select as text. If you had a file, you could have selected as file. So let's go ahead and review and launch our instance. We just want to review and launch. We can review. We have port 22 open by default, so we can connect to it. And then we have our instance details. Oh, I was about to make a huge mistake. I was showing you guys as an example to launch 100 instances, and I was about to launch 100 instances. So that's the importance of reviewing, so that you don't make a mistake like that. Okay, do not launch 100 instances. I don't know why anybody would ever want to, unless you're like Netflix or something, but in that case, you'll be automating all of this anyway. You won't be using this launch wizard, right? It'll be all code anyway. But yeah, we just saved ourselves from a big mistake. There we go. We have one instance, and we do have user data. Now the user data has been encoded. And so, obviously we can't read it here, but it's, we do have it. We do have user data, as opposed to if we didn't. Let's go back. Let's go ahead and cut this. And let's go into review and launch. And user data, there's nothing there, right? So let's go ahead and paste. This should be HTTPD, because that's the name of the Apache server. That's what we're installing, right? Up here. HTTPD. So be careful, right? If we had run this would not have worked. It would have successfully installed Docker and Git, but here it would have thrown an error, and then obviously this wouldn't have worked either, and then this wouldn't have worked. So that's all right. We could have just manually fixed it, but just make sure you don't have any bugs or typos or anything of that sort. Review and launch, and yeah, we're pretty much good to go. Let's launch our instance. Okay, so obviously you have to select a key pair. We still have the first one we created, and it's completely all right if you reuse that. I guess we should have called it my first key pair instead of my first instance, but we can just reuse that. And then we just launch our, and your instances are now launching. We can view our instances. So there we go. Our instance is here. It's running. but it's still initializing. So wait till it initializes, because during this initialization is when the user data will be also run, because it has to first, the instance starts running, and then AWS does whatever it needs to do to initialize the instance, and then once it's ready, it'll run the user data. So we can technically connect to it now because it is running, but it will not have finished initializing and running the user data. So don't connect until the status check is complete. And obviously that does take time, because remember, there's an actual server somewhere in AWS's warehouses or data centers right now being physically allocated. Obviously it might not be a physical complete computer. It might just be a piece of a computer, right? It might just be a partitioned part of a computer, or a container within a computer that contains other containers as well. We don't know how. We do know, we could find out, but I'm saying, what I'm trying to say is that there is something happening, right? This is not just some software here, right? It's going and it's communicating with a computer, and it's allocating space and that kind of stuff. So it's normal for it to take some time, but in the meanwhile, we can name our instance my second instance, because we have terminated our first instance. And so let's refresh to see what's up. And yes, it has passed its checks. And right now, this instance is ready to connect to, and it should have run our user data, installed Docker first, and then Git, and then Apache, and then configured Apache's index.html file to display the host name on port 80. So let's go ahead and see if all of that worked. Connect, and let's connect, and this is the moment of truth. We're logged in. Let's go ahead and check if Git is installed. We write Git. There we go, Git is installed. Let's check if Docker is installed. Yep, Docker is also installed. We can check for running images, we can check for images, so on and so forth. Running containers. So Docker PS checks for running containers, and Docker images checks for images. And then let's go ahead and see if Apache is running. Let's curl localhost port 80. And there we go. We get hello world from, and that is the IP address of this instance. So that's pretty cool, right? We didn't have to install anything. We wrote all the commands as user data in the launch wizard, and now when we log into our instance, we have all of that there for us and ready to use. So that's very powerful. Like I said, it's helped me a lot, and unless you use images or something like that, this will pretty much help you with streamline a lot of your work. And that's it for this video. In the next video, I'm going to be going over security groups, where we'll actually expose this port 80 so that we can open up or we can access directly from the browser without having to just do curl here. So then you'll really understand what's going on when we do that. So in this section, we're going to be going over something that I've alluded to quite often earlier in this section, and that is security groups. So security groups are essentially the first step of network security in AWS. They're one of the most useful skills to learn for troubleshooting network related issues. I mentioned to you before that, if you're trying to access your instance and it's getting a timeout, you're not able to access it, it's most probably an issue with your security groups, because remember, we need to have port 22 open in order to access it through SSH, and that's determined in a security group. So for now, we've been using the default security group that AWS gives us when we initiate or when we launch a new instance, a new EC2 instance. But these are actually completely configurable, and that's what we're going to be learning about in this video. So security groups act as a virtual firewall for your EC2 instances to control incoming and outgoing traffic. Okay. Now, if you take a look at the image in the top right corner, you can see that there is a security group or a box that has been labeled as a security group. And then we have our EC2 machine here. And essentially all traffic that goes out of the EC2 instance or into the EC2 instance passes first through the security group. So it passes into here, all inbound traffic, and based on the security groups and their permissions, it's either let through into the EC2 machine or it's blocked. And same thing goes for outbound traffic. And this security group is completely in our control. We can configure it to our needs. Inbound rules control the incoming traffic to your instance. Outbound rules control the outgoing traffic from your instance. And when you launch an instance, you can specify one or more security groups. So you don't have to specify all your permissions within one security group. You can have different permissions spread out across security groups, and you can assign multiple security groups to one instance. And if you don't specify security group, Amazon EC2 uses the default security group, as we've seen. And the default security group is, one that allows for SSH to go through. And you can add rules to each security group that allow traffic to or from its associated instances. So these rules are, what I mean by permissions, right? These are what specify what can be passed and what can't be passed through that security group. And you can add rules for a security group at any time. So you don't have to have these already, thought up in your mind, already prepared. When you're launching your instance, you can go ahead and launch your instance and not touch the security group section at all, as we've been doing. And so you get just very minimal access. You just get SSH access. Everything else is blocked, which is good. It keeps your EC2 instance secure. And then you can think about, how that particular instance will play into your larger application, into your larger system, and what exactly you need to give it access to or for. And then based on that, you can go back and you can add a new security group to it at any time, or you can add rules to an existing security group. So there's no reason to panic about, which rules to set during launch of an instance. Now, new and modified rules are automatically applied to all instances that are associated with the security group. So the advantage of a security group is very similar to the advantage of having groups in the IAM section. Remember how we created a user and we gave it certain privileges, certain permissions, but we didn't want to do this for every single user every time. So instead, we removed the permissions from the user and we created a group that had those permissions. And now whenever we create a new user, we can just assign him or her to that group and they will automatically get the same permissions, and then you can change it and those changes will be applied to all the users that are in that group. So security groups work in the same way. And that's the advantage of security groups. If you have a certain set of rules for a certain type of instance that you'll be launching, and you want every time you launch an instance that will be, a version of that type of instance that you're working with in your application, you want it to have the same security rules or permissions for inbound and outbound traffic, then you can just specify that in a security group. And when you're creating your new EC2 instance, you can just select that security group. So all the rules are automatically applied to that instance. And then in the future, if you have to change something, like let's say while testing, you had to keep a port open, but in production, it's going to be closed, but you have like 10 instances. So all you have to do is you have to go into the security group itself and block that port, close that port, and it'll be closed for all those instances. When EC2 decides whether to allow traffic to reach an instance, it evaluates all of the rules from all of the security groups that are associated with the instance. Okay, so it's not recommended to use the same security group across different instances, but it definitely does have its advantages. So let's look at security group rules, because rules are actually what we'll be specifying within a security group. A security group just gathers a set of rules together and packages them together to make it easy to assign to different instances, but it's the rules themselves that will be changing within the security group. So the following are the characteristics of security group rules. By default, security groups allow all outbound traffic by default, because there's really no security risk when your EC2 instance can, send its traffic out, right? There's no security risk for your instance, but obviously it'll block all inbound traffic by default except SSH, which will keep it secure until you open up a port that, or ports or a range of ports. So security group rules are always permissive, which means you can't create rules that deny access. So you only specify what is allowed. And security group rules enable you to filter traffic based on protocols and port numbers, as we'll see in the hands-on section. And for each rule you specify following. You'll have to specify a name, and that's the name for the security group. So for example, you can name it my-security-group, right? So just like how we've been naming key value pairs and that kind of stuff. So a name can be up to 255 characters in length. And again, pretty similar to how we've been naming things before. If you're used to programming, it's just like a variable name. There are only certain characters that are allowed, and you can't start with certain characters and that kind of stuff. But it's okay, because Amazon will warn you if you try to use a name that is not suitable. And then protocol. So you have to specify the protocol to allow. And the most common protocols are like TCP, UDP, ICMP. Now, this is not an IT networking class, so if you're not familiar with those, that's okay. But if you do need them for your application, you'll have to go and learn about them, obviously. And then port range, you have to. So for TCP, UDP, or a custom protocol, the range of ports to allow is what you need to specify here. And you can specify a single port number, for example, 22 in the case of SSH, or a range of ports, for example, 7,000 to 8,000, right? And then you have to specify the ICMP type and code. And this is only for ICMP protocols. Again, I'm just adding this in here just for extra information, but I've never had myself have to specify, I've never worked in domains where I've needed ICMP. So, this is just, consider this extra knowledge. It's not crucial for this course. And then you have to specify the source or the destination. So the source is for inbound rules, and the destination is for outbound rules for the traffic. Okay. So specify one of, either an individual IPv4 address, and that's basically what we're going to be using. But you can also specify IPv6 addresses and that kind of stuff. But you can also specify another security group, and this allows instances that are associated with the specific security group to access instances associated with this security group, which is very cool, to say the least. And choosing this option does not add rules for the source security group from the source security group to this security group. And you can specify one of the following security groups. So you can specify current security group, a different security group from the same VPC, or a different security group from a peer VPC in a VPC peering connection. So again, these are some more advanced topics of how to allow your EC2 instances to communicate with one another and that kind of stuff. But it's good to know, right, that they exist, and when you do need it, it'll be easy for you to look it up. And then obviously you have to specify a description if you want. It's optional, but it helps for you to identify your security groups later. So when you specify a security group as the source or destination for a rule, the rule affects all instances that are associated with the security group. So incoming traffic is allowed based on the private IP addresses of the instances that are associated with the source security group, and not the public IP or elastic IP addresses. Okay, and we're going to be covering IP addresses in a later video, but just keep that in mind. One last thing to keep in mind is that if there is more than one rule for a specific port, Amazon EC2 applies the most permissive rule. For example, if you have a rule that allows access to a TCP port 22 for SSH from just some random IP address, let's say, and then another rule that allows access to TCP port 22 from everyone, everyone has access to that port, to TCP port 22, because EC2, the service will immediately pick the most permissive, the one that allows for the most. So watch out for that. If you've had a larger range of IP addresses allowed for a certain port, and then later you wanted to limit it to a certain IP address, you might not realize that you still have, you're still giving access to the whole range because you haven't removed that particular rule. So, these are some things to keep in mind for security purposes, security best practices. And other security best practices are to always close unnecessary open ports. So large port ranges, when open, expose instances to unwanted attacks, right? Naturally. More than that, they make the traceability of vulnerabilities very difficult. For instance, your web servers, they only require 80 and 443 ports to be open, but not all. One of the most common mistakes is when users open all ports, using 0.0.0.0/0, and they do this in a rush when they're first creating their instance, because they're in a hurry and they just want to give complete access to the instance, and they think they're going to fix it later, but then they forget, and so the instance remains open to everybody, and that's a very big security threat, right? And when running EC2 instances, you must expose your apps only to those ports enabled on the corresponding security group level. Okay, so things to keep over your head. You still don't know what security groups are, you've never had experiences with it, but you can always refer back to this video. And again, my job here is to give you as much exposure as possible, but then obviously you have to go and do some more studying on your own, as with everything, right? So don't open ports for 0.0.0.0/0 unless specifically required. So this is what you specify in your range of IP addresses if you want to allow all IP addresses to access that port. So don't do that unless specifically required. There's really no need to do it, even for SSH. Even if you have security, other security measures in place, like a key value pair and a password and that kind of stuff. Generally, it's best to just pick my IP, because most probably you're the only one that's going to be accessing it. And even if you do allow multiple people to access it, instead of just allowing for everybody to access it, it's best to just receive from them their IP addresses, like request their IP addresses from them if it's like a developer or somebody, and just specify those specifically. Now, minimize the number of discrete security groups. So security configurations in AWS are dynamic. So an administrator can change these configurations at any time. With the presence of unattached security groups, the risk of misconfiguration increases because it makes it difficult for an administrator to figure out attached and unattached security groups in a large scale infrastructure. And so the chances of him or her changing the configurations of wrong security groups or accidentally attaching them to public instances becomes very high, and this inadvertently opens up your environment to attacks. So a pro tip in this case, in this situation, would be that the easiest way to identify unused security groups is to browse. I'm going to show you this, but you can browse through security groups lists, and then if you select them all and you try to delete them, AWS will tell you that you can't delete the security groups that are currently assigned or attached to instances, and so it'll delete everything else. And so obviously it's best to automate this using some sort of programming or something if you can, but the worst case, you can do this. So just like an administration can accidentally misconfigure a security group, another IAM, other IAM roles with access to modifying security groups can misconfigure them as well. So you should authorize only specific users to modify resource-specific security groups. So you should restrict access to EC2 security groups, and be alert when using multiple security groups in the same EC2 instance. And always maintain one separate security group for SSH access. Security groups are always associated with a VPC. That's something to keep in mind in the grander scheme of things when it comes to security. Now let's go and have some hands-on practice using security groups. So here we are back in the AWS Management Console. Now, since security groups, when we're talking about security groups, we mean, EC2, right? We're talking about security rules and inbound and outbound rules for EC2 instances. So naturally, security groups will be located within the EC2 service. And so let's go on in. And here we are. We have our instance running, right? This is the last instance that we used user data to launch, and it should have Git installed, Docker installed, and an Apache server that is displaying a very simple page to its port 80. And that page, remember, we're the one that we created it ourselves, and it displays the host name of the instance. But we weren't able to use an actual browser to view it. We had to use curl from within the instance to view it locally, but we were to view it on the private network, not locally, but on the private network. But we weren't able to view it on the public network because we didn't have port 80 open for the instance. And now, using security groups, we're going to be able to open them up. So we're going to be able to expose port 80 to the world publicly and then use a browser to actually view the instance. Now, we have one instance running, one key pair, one volume that's by default attached to the instance, and we're going to be covering volumes in a later section. But if you go here and you see the security groups, there happens to be 6. And the reason is I created some extra ones just to show you how we can delete all the ones that are not currently associated with an instance. So of these 6, not all are associated with the running instance or with any instance at all. And so remember, we said it's good practice to not leave security groups laying around if you're not using them. And so I'm going to show you the quick way of getting rid of extra security groups. So let's go into security groups, and we can actually access the security groups dashboard from the sidebar as well. Now, we're pretty familiar with the sidebar by now. We've mainly been using the instances tab here, but if you go down into network and security, the first option there is security groups. So we can just click that as well, and we're here. So it's not even letting me click it because it's the same page. So we have all these different security groups now, and we don't know exactly which ones are associated with which instances, but we don't need to. We can go ahead and select them all, and then under actions we can delete security group. And look, AWS tells us that some security groups cannot be deleted. Specifically, this security group here and this one here can't be deleted, or will not even be deleted, because this is a default security. So first of all, this is the default security group that AWS uses, right? When we said that if you're not using a security group, Amazon attaches one by default. So the default security groups can't be deleted. Whereas this one has one instance associated with it, and you can actually click this to go into and see which instance it is. In our case, we only have one instance anyway, so there's no need to do that. So we have to either terminate the instances or associate them with different security groups. So deassociate them with this one in order to be able to delete the security group. And so, but the rest are not associated with anything, so we can go ahead and delete them. And so we have to confirm by writing delete. And when we press delete, everything will be deleted except for those 2. Okay. Now we can go into the default security group. Okay. Security group name. Let's click on it. And we can see immediately that there are some inbound rules and there are some outbound rules. And basically the inbound rule allows all traffic, and for all protocols and all port ranges, it allows all of them to come in. And outbound rules does the same for outbound traffic. And this, is something that we do not advise, right? Because it's too much exposure, too much security risk. But we're not going to edit the default one. We're going to go back into security groups and select the one that's currently associated with an instance. And here we can see that this was created during launch, and it has an inbound rule that allows for TCP port 22 access for all IP addresses. And we said the description is optional. And then outbound rules, it allows for all outbound traffic, because again, we said that outbound traffic is not a risk, it's only inbound traffic. So this basically limits the inbound rules to an SSH port 22. Now, let's go ahead and edit the inbound rules. We have this existing one, which we can modify. For example, we can remove all, and we can specify an individual IP address, or we can specify another security group like we said, or we can, if you click on my IP here, I'm not going to do it so you don't know my IP, but if you click on this, your IP will pop into here. So that would mean that you will have access, only you will have access through your IP address to the TCP port 22 of the instance. And so generally that is best practice to just select my IP. But in the case where you're not sure who's going to be accessing it and so on and so forth, it's better to pick anywhere on port 22 than to just not have any rules and have complete access to all ports on your instance. So at least you're limiting the access to port 22, and they would need key value pair or something to access it, unless they have some high level hacking skills or something. But either stick with custom or my IP, but if not, anywhere is better than having no rule and just allowing complete access using the default security group. So we're going to add a rule. And by the way, you can delete rules as well. So there we go. We deleted it. Again, don't be scared to do stuff like this. All we have to do is we have to just create a new rule. And we can just go ahead and click SSH from here. And then we'll allow anywhere. From anywhere. That's what we'll call it. And we can add a rule. And now we can add HTTP access. So HTTP is port 80. So as opposed to HTTPS, which is port 443. But we know that our Apache server is currently running on port 80. So we don't want HTTPS, we want HTTP. And then we can allow access from anywhere, because a web page should have access from anywhere, right? And so HTTP access from anywhere. And we can save the rules. There we go. Now, this security group gives access to any instance associated with it to port 8080 and port 22. Okay? From anywhere. And how can we test this? First of all, let's go back into our EC2 dashboard. Let's go to running instances. And if we click on, let's just click on my second instance. Down in here, we know this page, right? Public IP address, private IP address. But if we go into security now, we have the security groups that are associated with this instance. So if we click on this, we jump right back into where we were. This was the security group that we were editing, Launch Wizard 5. Okay. So, and we can see we have 4 inbound rules or 4 inbound permission entries. Now, if we go back under security, we don't even have to click into the security groups page, because we can see the inbound rules and the outbound rules directly from here. We can't edit them, but we can see them. and that's very useful. Now, so we're confident now for sure that that security group, Launch Wizard 5, that we just added, port 82, is associated with this instance. And this instance does have Apache running on port 80. And so we can now access this publicly through a public network. So now we should be able to access this instance through port 80 using its public IP address or its public IPv4 DNS. So these two will essentially, direct you to the same instance as long as it's on port 80. Now, port 80 essentially means it's an HTTP connection or an HTTP port, which is, how websites are accessed through the browser. So we don't need to worry about specifying port 80 at the end of the address because the browser automatically does that for you. So we can just click on open address here, and AWS conveniently pops up a new tab, and this is the public DNS. Now, remember, this is very important to, that I keep re-emphasizing this. Security groups are or should be your go-to place for network connection issues, right? Right now, we have the public DNS name of our instance up in the browser, up in the URL spot of the browser, but there's no connection happening. There's a timeout, and if we, connection timed out, and if we go back in here and we check our security group, we see that in fact we do have access to port 80, and so we shouldn't be having any problem. So there's no problem on this side. So then if we click this, we can see that in fact the problem is that we're trying to access port 443. HTTPS accesses port 443. We don't have port 443 open. We only have port 80 open. So we have to make sure that this is HTTP, which is port 80. And now when we press enter, there we go. We have our page. This is the page that we created, if you remember, using, when we edited index.html in our instance. And so, we had a display hello world from, and then the host name for the instance. And if we compare this with the private IP address, right, it's the same. So this is the same instance. So this is a success. We have successfully connected to our instance through port 80. So that's essentially how security groups work. Now, it's generally good practice if you go into security groups and you create separate security groups for, internet access and separate for SSH access. So let's create a security group now. What we've done so far is modify an existing security group, but let's create one. And let's call it SSH access. Allows SSH access for everyone. And we only have one VPC, which is a virtual private cloud. So, you don't have to worry about that. You just select that. But if you do have different virtual private clouds, you will have to specify which one you want your security group to be created under. And we add inbound rules, SSH, anywhere. And we're just going to ignore the description for now because we have a description for the group itself. And then outbound rules, we can just keep the same. And we can create the security group. Now, you can see that, we have SSH access and we have inbound rules, access to port 22 by everyone. Let's go back into security groups and let's create another security group. HTTP access allows HTTP access for everyone. We add a rule, HTTP anywhere, and that's it. We create it. Now when we go to security groups, we have 4 security groups. We have SSH access, HTTP access. Now let's go into, but the thing is, look, these 2 are not associated with any instances, but this one is still associated with our instance, and it has access to port 80 and port 20, and we want to split this up into 2 groups, right? So let's go back into our instances. So let's select our instance that we want to modify, whose security groups we want to modify. And up here, under actions, under security, we can change the security groups. Now that we're here, we can see the associated security groups. We can add security groups, and we can remove existing security groups. So let's go ahead and remove that. Now what happens when this is removed? It's associated with the default AWS security group that we saw earlier. And you can go back and check the details of that again, the inbound and outbound rules. But now we want to add SSH access, and we want to add HTTP access. Now let's save. Let's go back into here and let's refresh. And we refresh. There we go. We still have access to port 80. And if we try to connect to this instance, we still have access to port 22. Now, if we were to go back, and let's say that we're done, right? We're done with testing and developing. Now, this is going to be a public application, public web page, and we don't want anybody to have SSH access at all. We want to remove that privilege completely. So we can just go back into Actions, Security, change security groups, and we can just remove access to SSH. And the advantage of that is whatever IP addresses you had specified there, you can just remove it, and later when you want to add it back, you can add it without having to keep track of the IP addresses and that kind of stuff, because it's going to all be still saved under the security group. You're just disassociating the security group with this instance, but the security group still exists. So if we click save and we go into our page, we refresh, we still have access to the page, to the instance. But if we try to connect, we're going to get a timeout because we do not have access to port 22. So I'm not going to wait because, to not waste your time. But if you continued waiting, you'd get a timeout. You would not be able to access TCP port 22 of your instance. So let's cancel. So that's and then you can always go into security and you can view, just to keep track of what you did. Now, we just have access to port 80. We can see that, and we don't even have to go down into here because we aptly named our security group. So we can just look at this. So we have HTTP access. So that, that's essentially what security groups are. Obviously there's a lot more depth to them, and I'm going to let you figure that out. One last thing though, let's just go ahead and try to launch a new instance. And let's select our existing instance. Configure instance details, and we can jump right into configure security group. And here, instead of creating a new security group, so by default, the launch wizard is creating a new security group for SSH access. So this is not the default one that AWS will give you, but this is the default one that the launch wizard will create for you. Instead of doing that, from now on, we don't have to continue doing this every time and making sure that we've selected the right things, because that can be very error prone. Instead, we just select an existing security group here, and we have all these security groups that we can select from, and we can, for example, add SSH access. We can add HTTP access. And then we can review and launch. And now we have these 2 security groups attached to our instance. So we have access to port 80 and port 60, port 80 and port 22. Okay. Now let's cancel. Let's go into security groups here. Now that we're no longer using this one, we can delete it. So we can delete security group. And there we go. Now we have a very clean layout. We know exactly what we have. We have a SSH access, HTTP access, and we have a default security group. Now you can also do some, let's say that you want to create another security group that only gives SSH access to your developers. So it limits who can access the port. If you go into actions, you can go ahead and take your time going through each of these, but we're focused on copy to new security group. So it takes everything within that security group, it copies it all. This is especially useful if you have a very complex set of rules. And then it allows you to create a new one. So we can add in like SSH access developers, SSH only for developers IPs, okay? And then we can specify custom, and we can just, you know, type in the IP addresses for our developers, let's say, okay? And then we can create new security group, and we'll have a completely new security group, but that's copied from SSH access. I think that's enough of an introduction for security groups. I'll let you continue your learning and your exploration into security groups, because if we go into too much depth for every single feature within every single service in AWS, we'll never ever finish this course, right? So you have enough knowledge, enough foundation now to go into AWS docs and just pull up the security groups chapter and just start reading and understanding everything, and maybe just jump right to the more advanced parts. In this video, we're going to be going over a very quick topic, discussing the life cycle of the instances you're launching. We've had some exposure to different states, right? We've terminated an instance before, and we've seen when instances are running, and that kind of stuff. So we have some familiarity with instances. This video is just intended to be a very comprehensive, like just for you to see all the different possible states that an instance can be in, so you know what your options are. Now, so before we get into the details, let me give you a bigger picture of what's going on. There's this very nice diagram that AWS prepared in its EC2 documentation. Now, if you're not familiar by now about the EC2 docs, go ahead and search on Google for EC2 documentation, or just type docs.aws.amazon.com into your browser URL, and from there just navigate to Amazon Elastic Compute Cloud, and you'll see a very comprehensive set of documentation on EC2 there. So everything that I'm covering in these slides are in accordance with AWS's documentation, just so you know you're getting the up-to-date information and the information that AWS themselves considers to be important for you. So you can find more in-depth details and explanations and information on everything I'm covering in this course in the documentation, and it's highly advisable for you at the end of every video to just go and search. Like here, for example, we have EC2 Instance Lifecycle. So just write EC2 Instance Lifecycle Amazon Docs or something into Google, and you'll find the page for the Instance Lifecycle that Amazon themselves have prepared. So they've prepared this very nice diagram here, or this very nice illustration, which shows you the transitions between the different states that your instance can be in. So we're going to see in a little bit in the AWS console how we can switch to different states, but there's also, you know, transitions that happen between the states. So, you know, you can pause the video and take your time understanding this illustration, but essentially initially we launch an instance, and we do that from an AMI. And we're going to be covering AMIs and how to make custom AMIs in the next video. But for now, we're just using ready, pre-prepared AMIs from AWS. And the one we're using in particular is the Linux 2 machine, right? And so we'll launch it, and immediately it goes into a pending state. But this state results from us taking this action of launching this instance. So because we launch it, it goes into a pending state. Now, from pending, right, it can go into only running, because that's the whole point. We're launching an image or launching an instance so that we can run it. And so it'll go into running, and from here you can either reboot your instance. So it'll go into rebooting and then it'll go back into running, and that's the definition of reboot. And then, or you could also terminate it, and once you terminate it, it goes into shutting down and then into terminate it. And remember, when you terminate it, that's it. Your instance is gone. It no longer exists. You can never retrieve it again. It's gone. You just killed your instance. If you don't want to do that, if you do see yourself, possibly restarting your instance and you just want to temporarily stop it, you have two options. You can either stop or you can stop hibernate. And I'm going to be going into more detail on stop hibernate, which is a relatively newer addition to EC2. And in that case, it goes into stopping. And then when it's successfully stopped, it goes into stopped. And then you can, from there, you can terminate it if you want, or you can start it back up. And so it ends up in pending and then in running. So this illustration basically, demonstrates all the different states and transitions your instance can take. Now, when it comes to different states, they might have different billing statuses. So some states might be billed while others are not billed. And, that might be important to know in your case. And it might also be asked, on the exam. So here's a quick table you can refer to check for whether or not a particular instance is being billed or not. And so you can see that most of them are not being billed. So if an instance is shutting down, or it's terminated, or it's stopped, right, you're not being billed, which is expected. And if it's pending, you're also not being billed. But if it's running, that means it's up and ready for use. So obviously you're being billed. And if it's stopping, it depends on whether or not you stopped or stop hibernated your instance. So when you stop hibernate your instance, you will be, and it's in the stopping state. Because of that, you will be billed, just because of how stop hibernate is different from being, just being stopped. When you stop an instance, it's completely stopped. But when you stop hibernate, it's not exactly completely stopped. It's recoverable. So I'm going to be going into detail on that shortly. But just, this is just a quick reference you can refer to. And now keep in mind, pending, you can end up in the pending state because of two reasons. You can end up in the pending state because you're just launching your instance, or because you've stopped it and you're starting it back up. So those are the two reasons you might be in pending. In both cases, you'll end up in pending. So yeah, just pause the video, refer to this. Again, a lot of this stuff, might seem too technical and too unnecessary. And, it's stuff you can easily look up when you need to. And that's correct. But you do need to know some of this stuff for the exam. And, again, it doesn't hurt to know that these exist. And, you can easily look them up when you need to. But if you never knew that, these existed, you wouldn't know what to look up, right? So my job here is to give you exposure to as much as possible so that you have a solid foundation that you can build on your own, hopefully. One thing I should mention is that this will not necessarily hold for all instance types. And we haven't covered instance types yet, but there are, for example, instance types called reserved instances, which basically you pay for beforehand. They're reserved for you, and because of that, even if you do stop your instance, you will have to continue paying for it until the end of the instance's term. So that'll depend on your payment option. So keep in mind, these are all general, just general pieces of information, but depending on your situation, depending on your particular features that you've selected, the tier you're in, your payment types, your instance types, other services that you have integrated, obviously you have to consider all of those as well, right? If you have a S3 bucket that's connected to an instance, and when you stop your instance, the S3 bucket continues to exist, so you will continue to pay for the S3 bucket, for example, right? So don't take these as gospel. Always be aware that there are other possibilities and other options, such as reserved instances. And before we jump into AWS, I would like to spend some time on the hibernate state. And the reason for that is because this is a relatively newer state in the EC2 service. So it does merit its own slide. Essentially what EC2 or what Hibernate does is it saves the contents from the instance memory or the RAM to your Amazon EBS root volume. And Amazon EBS we will be covering in the EC2 storage section of this course. But essentially that is the root volume that is assigned or to your instance. And so it saves the RAM into there. So the instance is Amazon EBS root volume, and any other attached Amazon EBS data volumes are persisted. So as opposed to stopping your instance where everything is lost, in this case, there is persistence. And when the instance is restarted, the EBS root volume is restored to its previous state. Processes that were previously running on the instance are resumed. Previously attached data volumes are reattached, and the instance retains its instance ID, as opposed to being, what happens when the instance is just stopped and everything is lost and everything is reassociated from anew when it started. So usage is charged while in the stopping stage, as we mentioned, but it is not. You do not get a charge for keeping an instance in the stop state if you've hibernated it. So again, this does come with its fine print. For example, your instance state and everything will be stored within an S3 bucket. So you will have to pay for the S3 bucket, but you're not paying for the instance itself. Okay, so that's something to keep in mind. And not charged for usage fees, but charged for storage of any EBS volumes, including storage for RAM data. So yeah, you will be charged for storage, but not for having an instance. And you can hibernate an instance only if it's enabled for hibernation. And there are hibernation prerequisites that an instance needs to meet in order to be hibernatable. And you can find a list of those prerequisites. It's too detailed for me to include in these slides. It's not worth making everything too detailed. But if you just search for like hibernation prerequisite EC2 AWS docs or something on Google, you will find a list. And it does matter on like the instance image and the instance type. For example, it does need to be an Ubuntu image or like a Linux 2 image or something like that. And you can't just have any image hibernate, at least as of recording this video. That might change in the future. The instance RAM size must be less than 150 gigabytes. The root volume must be EBS, and it must be encrypted, and it must be large. And it's only available for on-demand and reserved instances, and so on and so forth. So there are some prerequisites. If you are not able to hibernate your instance, just make sure, the reason might be because of it not meeting those prerequisites. So just make sure that if you are relying on hibernation for your specific task, then make sure that you are selecting the right image and the right instance to allow for that. And the instance retains its private IPv4 address. Some uses of Hibernate, you might be wondering what the benefit of Hibernate is. So imagine, a situation in which an instance or an application takes a long time to bootstrap and build a memory footprint to become fully productive. You can use hibernation to pre-warm the instance. So essentially, what you would do is you would launch your instance with hibernation enabled, and then you would bring it to a desired state, and then you would be able to hibernate it and ensure that it's ready to be resumed to the same state as needed. Since you're not charged for instance usage for a hibernated instance when it is in the stopped state, you're charged only for your instance usage when the instance is in the stopping stage. So this would potentially save you both in terms of getting your instance started up and in terms of cost, because maybe in the past, maybe you would have to have maybe you would have had to keep your instance running just so it's ready to be fully productive, or it's already fully productive when when it's needed, when it's called. But now you can just start it up from a hibernated state. So I'm sure there are a lot of very useful applications for it, but it depends on your particular domain and usage, and it's going to be up to you as the the architect or the AWS expert to decide in which situation which features of AWS would be most useful. So let's go and do some hands-on with the instance lifecycle and see how it all works. So here we are in our EC2 dashboard, or not in the EC2 dashboard, but in the instances dashboard. And we're immediately presented with a very familiar screen before us. Let's close the AWS management console. And so we have our one instance that's running, my second instance. And, yes, I am keeping this running because remember, we're using the free tier and we're not being charged for running one instance because you have up to 750 hours of free EC2 usage a month, as long as you're using the T2.micro instance type. And so there's no way to exceed that unless you have more than one instance running, because if you multiply like 31 by 24, that's like 744 hours. So assuming that the longest month, assuming that you're in a month that has 31 days, which would be the longest possible month you can have, you would not be able to exceed it with one instance. So there's no harm in keeping it running. Now, if we click the drop down here, we see the different instance states. So we can stop an instance, we can start an instance, we can reboot an instance, we can hibernate an instance, and we can terminate an instance. Now, in order to do any of that, we're going to have to click on the instance we want to perform these actions on. And when we click on this, we're presented with stop instance, reboot instance, and terminate instance. Now, there are two instances, there are two states that are not accessible. One is the start instance, and that's because our instance is already running. So we would be able to access this if the instance had been stopped, but the hibernate instance is not accessible because it hasn't been enabled while launching the instance. So you have to make sure that you're enabling the instance to be hibernatable, and also you have to make sure that you're launching an instance that is hibernatable in the first place, that option exists. So let's stop this instance. Okay, let's stop our instance for now, and we stop it, and it's stopping, and right now it's not being billed. It stopped being billed because we're not stop hibernating it, we're just stopping it, and so we're not getting billed for it. And if we refresh, we will see that our instance is still stopping. It might take some time to stop. So it's still stopping. And there we go. It has been stopped officially. And when we come into here, we can now start the instance back up, or we can terminate the instance. But currently, it's not terminated, so we can still start it back up. We still have access to it if we want to, but we're not being billed for it right now. Now, in order to create an instance that we can hibernate instead of stopping, let's launch a new instance, and we'll launch the same Amazon Linux 2, the T2 Micro, configure instance details, and in this page here, and in this step, we can go down into here, and you see an option here called Stop Hibernate Behavior. So hibernation stops your instance and saves the contents of the instance's RAM to the root volume. You cannot enable hibernation after launch, and that's the problem that we faced. We had not enabled this when we launched our second instance, and now we're not able to hibernate it. So this is something you have to think about beforehand, whether or not you want this option to exist in your instance or not. So enable hibernation as an additional stop behavior, correct. Yes, we want that. And AWS gives us a little note. To enable hibernation, space is allocated on the root volume to store the instance memory, or the RAM. Make sure the root volume is large enough to store the RAM contents and accommodate your expected usage. So we got to make sure that we have sufficient storage in the root volume. And to use hibernation, the root volume must be an encrypted EBS volume. Okay, so that's important. So let's go into add storage, and here AWS gives us a warning. AWS tells us to use hibernation, encrypt the root volume. So we do that from here. Under encryption, we can just pick the default encryption, and just to make sure we have sufficient storage, we can increase this to like 30 gigabytes. And let's go ahead and let's add a tag. So we can just add a tag, name EC2 with hibernate, okay, and configure security group. This is fine. Let's create. Since we've created a security group, we can just pick the SSH access one, and we do not want to give the HTTP access at the moment. But if we want to, it's going to be very easy for us now that we have configured security groups. Then let's review on launch. When we go into instance details, stop hibernate behavior has been enabled, and we launch. We pick our existing security key, the key value pair, and we just go ahead and launch the instance. View instances. Okay, now it's in the pending state. It's being launched. It's transitioning from not existing to running, and so it's going through pending. So this is a transition, right? Stopped is a state. Now let's wait for this to start running. And keep in mind, if you are following along with me, you might be charged very slightly just because we gave it a bigger storage, but it should be fine. So now we're in the running state. Now when we click on this, first of all, let's go ahead and start my instance, my second instance. Let's start this. So let's start. Click instance state and start. You can also right click and then go into whatever you want from here. But now this is starting, or it's pending, right? So it's in the pending state. This state here still hasn't initialized. It hasn't passed its status checks. But when we right click, or when we just click on EC2 with hibernate and go into instance state, now we have hibernate instance enabled. Whereas with the second instance, we do not have it enabled. It's still not running. We have to wait for it to run. There we go. My second instance, when we click on it, it doesn't have hibernate enabled. So what is the difference practically between stopping and hibernating your instance? To see that, let's go into my second instance. And let's connect. We do not have SSH enabled. If you remember, we had disabled it. That's very easy to deal with now. We just go into security, change security groups, and we can go ahead and add a security group. Let's add the SSH one and save it. And now when we go into instances, let's just check. Okay, they have passed their status check. So now when we go into our instance, it just started, right? So if we check for uptime, it's been up for 2 minutes. Okay, right now it's been up for 2 minutes. Let's exit this. Let's go into instances. Let's stop my second instance. While that's stopping, let's go into EC2 with hibernate. Let's connect. Remember, my second instance has been up for 2 minutes, but then I stopped it. Now we'll look into this. This has been up for 4 minutes, okay? Let's hibernate this now. Hibernate instance, hibernate. Now they're both stopping. This one is still being charged because the reason it's in stopping is because it's been hibernated and not because it's stopped. This one is not being charged. This one had an uptime of 2 minutes. This one had an uptime of 4 minutes, okay? But they're both stopping right now. So now they're both stopped. And let us start them both back up. They're both pending. Essentially what we want to check is, let's go back into this one. This is running now. Let's connect. And let's check the uptime. Remember, it was 4 minutes when we stopped it, or when we hibernated it. And now it's 5 minutes. This means that the RAM, or the state of the instance, has been completely preserved. That's the benefit of hibernating. It started back up from where it was when it stopped. It was at 4 minutes, right? Uptime, and then it started back up, and a minute has passed. Now it's 5 minutes. It's not 0, or it's not 1. That's the benefit of hibernating. Everything you had going on is preserved. The RAM is stored. So when you started back up, you start right back up from where you left off. Whereas if we now go into my second instance, it's still pending. Okay, there we go. Uptime, it's 1 minute. Remember, it was 2 minutes when we stopped it, but the RAM was not stored. It was stopped. Everything was removed and erased, right? And when it started back up, it started afresh. So that's why it's at 1 minute. And that's effectively the difference between hibernating and stopping an instance. So, we have experience terminating. Oh, let's go ahead and terminate, because we don't want to continue getting charged. Let's terminate this one. And you can experiment with reboot and all of that. So that's basically everything you really need to know about the instance lifecycle. So now it's shutting down because we terminated it. And you could also terminate after stopping. And I'll also go ahead and stop this one, because I don't want to get charged for. I've already used up some extra time by having both of them running. In this video, we're going to be going over Amazon Machine Images, or AMI for short. You've had some exposure to this already when you were launching your own instances. We were using ready-made AMIs, or AMIs that had already been prepared by Amazon for us. But now we're going to learn how to create our own, and how to copy them, and how to essentially streamline any work that you might need to do in terms of preparation, or preloading, or pre-installing anything onto your instances. We were able to achieve some streamlining in that regard using user data, but that still involved some work. We had to still copy and paste the whatever script we wanted to run, and so on and so forth. And for more complex applications, you might not even be able to do all of that, right? There might be some configurations and some other stuff that you can't really achieve easily using a script. And so AMIs will allow you to overcome that, and we'll see a little bit. And I'll show you what I mean in a little bit. So basically, AMIs provide the information required to launch an instance. So we've been using an AMI called Linux, Amazon Linux 2. So essentially, it's just a piece of software, an operating system, that's had some stuff preloaded onto it, pre-configured, preset, maybe the security, other aspects, and you're just basically using that image to launch a new instance. Okay. It must be specified when the instance is launched, since the instance will be launched based on that image. It's not something you can modify after launching the instance. It's too late. And you can launch multiple instances from a single AMI when you need multiple instances with the same configuration. Okay, this is very important. Imagine you're building web apps, and all your web apps require, Node.js and Docker and other stuff like that, and they need a particular configuration in order to work with your application or your ecosystem or whatever the situation may be. And you're going to be launching quite a bit of instances that require this exact same configuration, exact same system. And so all you'll have to do is configure this once and create an image from that. And then you'll be able to launch an unlimited amount of instances using that image with the same configuration. And you can use different AMIs to launch instances when you need instances with different configurations. So you could very well have a list of different AMIs with different configurations that you can use to launch your instances based on different needs. And this could be, you can have an AMI that's configured for a certain database setup you have, and then you can have an AMI that's configured for a certain REST API setup that you need for your app, and so on and so forth. And whenever you need a particular configuration, you just use that particular AMI to launch your instance, and your instance is ready to use. And this is sort of the process that is taken by AWS when you create an AMI. And so, it's registered, and you have to deregister it if you want to delete it. And you can launch from there. You can copy an AMI into another AMI, so like across regions, and so on and so forth. Now, just so it's very clear exactly what AMI is, I'm going to be, trying to explain to you. I added this extra slide with some more descriptions of what an AMI is, so you get a better understanding. So it's essentially a template that contains a software configuration. For example, a particular operating system, like in our case, we have a certain configuration of the Linux operating system and a particular distro of that system, and we're able to just launch it directly by clicking on Amazon Linux 2, for example. Or it could be an application server, or just applications in general, web applications, whatever it may be that you're developing. So any particular software configuration that's specific to your needs that you yourself have configured, you can convert into an AMI image and later use to launch instances from it. So from an AMI, you'll launch an instance, which is a copy of the AMI running as a virtual server in the cloud. And you can launch multiple instances of an AMI, like we said. And this shows you how you can have one AMI image, and you can have one instance here, and then you can have multiple instances like so. Now, so by default, the AMIs you create will be private, and I will show you how to make them public, or to at least share them. But essentially, public AMIs can be found on the Amazon Marketplace. So I'll show you how to find the Amazon Marketplace as well. Now, you should be careful when using the Amazon Marketplace. And the reason for that is because essentially you're basically launching an image that somebody else prepared. So there might be malware on it. There might be some malicious software. So you just got to be careful. And honestly, I don't think you should trust public AMIs too often unless it's from a trusted source or it's from somebody that you know. And there might be hourly charges for some public AMIs because it might be a very customized configuration of some software, or just something that really streamlines your production or something like that. And so the creator of the AMI might charge you. So you're gonna watch out for that. And yeah, definitely check the ratings of your AMIs. Make sure that they have good ratings and there's no suspicious software or anything that's on it. And again, don't use public AMIs without checking for malware, like we discussed. So there will be advantages of creating your own custom AMIs. Like I mentioned, you'll avoid charges and you'll avoid the threat of malware and that kind of stuff. And you can also pre-install any needed packages, right? It's highly unlikely that somebody else would have installed the exact same package that you need. And maybe they might have, but they might have also installed extra packages that you don't need. So when you create your own custom AMIs, you're completely in charge of what you're creating. And there are no malware threats. The boot times will be much faster. No hourly charges, maintainable over time since you're the one that created it. And so that's highly advisable. Now, when it comes to AMI storage, the root device for your instance contains the image used to boot the instance. So an Amazon machine image is essentially stored in an S3 bucket that we're going to be covering later on. And so it is not directly accessible. It's just meant for storage, the S3 bucket. And so your AMIs will be configured and specific to your account and region. And so when you create an AMI within an account and within a region, that AMI will not by default be accessible within another region in that account or from another account. You'll have to go in and edit that, and I'll show you how to do that in order to make it available across regions or across accounts. And since they are stored in an S3 bucket, AMIs are not very expensive. So the S3 charges are very minimal because it's just long-term storage. And so that shouldn't really be a problem. And do make sure to remove AMIs which are not of any use. So you'd have to deregister them, and I'll show you how to do that as well. There's no need to keep them around if you're not going to use them. And let's go and get some hands-on creating, copying, and sharing some AMIs. So here we are in our instances dashboard, and we currently have no running instances. If you remember, we deleted the instances in the last video. So let's go ahead and first, let's launch an instance. And while we're launching, let's make note of this first page. Before, we were just skipping through this very quickly. We just select Amazon Linux 2 and just click select and go on. But now let's pay some close attention to what's actually on this page. So this step is called choose an Amazon machine image, AMI. So this is where the AMI or the Amazon machine image that your instance will be based on is selected. And these are all pre-existing ones that Amazon has prepared for us. And they're all images. They're all essentially AMIs, and it's even in the name Amazon Linux 2 AMI. And so this means that this comes with a particular configuration of software, right? So it provides a Linux kernel, so that's one particular piece of software that that's on there. It's tuned for optimum performance on Amazon EC2. So there's been some configuration and some stuff that's been done on it. It has all these other pieces of software, so on and so forth. So Amazon has essentially created an image for you that has certain configurations and certain pieces of software that make your life easier, and they've saved it into an AMI and they've let you access it. And so now you can base your instances off of this without having to create like a fresh Linux instance and then have to do all of these configurations and installs on your own. Now when we create our own AMI, it'll show up here under my AMIs. Currently we have no AMIs. You have not created any AMIs. You can launch instances using AMIs provided by AWS, our user community, or through the Amazon Marketplace. So the Amazon Marketplace is found here, and here you can browse through a bunch of different AMIs based on your particular domain or your particular line of work. You can find some AMIs on that have pre-installed blockchain piece of software or whatever, whatever the case may be. Data analytics, there's over 900 different AMIs, that come, with some sort of configuration that makes data analytics easier or faster to production or whatever, right? So you can just go ahead and explore. Again, watch out for the ratings, right? This is pretty poorly rated. Just make sure, this is, it's directly from the company, and it has a very high rating. So this shouldn't be too risky. But again, don't forget that there will be hourly charges on the higher quality ones. Like this one, it starts from almost $2 an hour. And it's going to be like $15,000 a year. They're most probably basing that price off of the yearly, how much they actually sell their software for. But anyway, so keep watch out for that. But right now we don't have any custom, we don't have any of our own AMIs. We don't want to work with the Amazon Marketplace for now. And community AMIs, right? You got to be extra careful here. Because this is a free for all. But we don't have anything right now, so we're going to go ahead and just continue with what we know what to do. And just so we don't waste time configuring the instance on our own, because we've already done that. There's no need to repeat that. I'm going to copy and paste the same script we used in the previous videos right into here. This is where we had, this is, the same script we used for installing Docker, and then starting up the Docker daemon, installing Git, installing the Apache web server, starting it, and then having it display hello world from and the host name of the instance. So this is the same exact script that we used in that video. If you don't remember, go back and rewatch the user data video where we go over this, and even the one before that where we do this manually within the instance after launching it. So remember, user data means that this will be run when launching the instance, so we won't have to do all of these on our own manually. Let's go into review and launch, but let's actually configure security group. Let's assign from an existing security group, let's assign the HTTP access and the SSH access security groups to this instance. We'll review and launch. Use the same existing key pair that we've been using this whole time. And then we can just jump right into the instance. Let's click on it, refresh. So it's pending. I'm going to jump to when it's running. Okay, now the instance is running. If we refresh, it's still initializing. So it's still running our EC2 code. It's still running our user data code. So it's installing Docker and Git and setting up the web server and all of that. So let's just give it some more time. And there we go. The checks have been passed. So let's go ahead and check that our user data worked. Let's connect to our instance. And in fact, we don't even need to connect. What we could do is we could even just go into, we can just copy the public IP address and paste it into here. And if we see the web page, and there we go, we see hello world from, and this is the host name of the instance. So this means that the web server is working, but we can still check to make sure that Docker has been installed and Git has been installed. Yep. So there we go. Our user data worked. So essentially what we did here was basically configure this instance, right? We added our own software. We added Docker. We got it running. We added Git. We added web server. We even added a very, very simple custom web page. Okay. All of that has been installed and configured on this instance. Now, if we were to terminate this instance and start up a new one, we'd have to go through that whole process once again. So instead, we can just click on our instance, go into actions. Under image and templates, we create an image. So we can go ahead and call this image web server. In the description, comes with Git, Docker, and Apache web server. And then we can just go ahead and click create image. And now when we jump into AMIs, we will see that there is an image being created and its status is pending. It has its own AMI ID. We called it web server. Down here, we see that it comes with Git, Docker, and Apache web server. And so let's wait till it finishes loading. So let's wait till it finishes being created. And there we go. The image has been created. Its status is available. And now we can use this to launch our own instances. Let's go back into running instances. We have one that's running. Let's terminate this. We're going to terminate this instance. So that's shutting down. It's going to be gone. Okay. And now, if you go into AMIs and we click on our instance, we can do a number of different things with this instance, okay? But before we go into all of these, let's go ahead and see how it is launching an instance from this image. So when we go into our AMIs and we right click, we see a number of options before us. The first one is launch. If we click on it, we end up right back in this familiar wizard, launch wizard, and we can see that we're on step 2, because in step 1, essentially, normally when we always start from the quick start, now we're starting from my AMIs, and we have an AMI here, which is our web server, comes with Git, Docker, and Apache web server, and this is the one we select. It's automatically selected because we came in here through that image. And then we can just, next, configure details. We don't need any user data because everything that we want installed is already installed on this image. And then we can, continue. Let's go ahead and add HTTP and SSH access as a security groups, and we can launch this. And just to make sure that, it is different than the one we're just terminating now, let's go ahead and add a tag. Image web server. So it comes from the web server image. We just added a tag, and we can review and launch. And now when we go into our instance, it's pending. It's currently being launched. But this is a brand new instance. It's different from the one we just terminated. And we can, clarify that by clicking on tag. So it's from image web server, and it's running. Let's wait for its status checks to pass. Now, keep in mind that this will be faster to launch than what we did with our user data, because what happens when you use user data is the instance launches, and then your script is run, and each command is put into the terminal, and a piece of software is installed, and everything that you specified happens. And so that's time consuming. But in this case, we have everything baked into the image. So it's very straightforward for the image to launch. It doesn't have to run any code. And so it's going to be quicker. And there we go. The status checks have been passed. Now, let's go into the details. And as you can see, we have a completely new public IP address. Let's see if this is working. And there we go. We are able to see the HTML page that displays the host name for the instance. And this means that even though we didn't do any configuration for this particular instance, because it's based on an image that has the web server installed and everything configured properly, we just launched it, and automatically we had access to the web server. And if we go into it, if we connect to it, you'll see that we have Docker and Git also installed. And we did not have to specify any user data, or we did not have to even go into the instance and manually do any configuration or installation. So that's very cool. Okay. And now that you have this image, right, you no longer have to do all of that manual work, and that's very powerful. But what if you have another account or another client and you want to share this image with them? Or what if you want to launch instances in other regions, right? This image was created in the Ohio region, and we want, maybe we want to, have it also be created in the Hong Kong region. So what we can do is we can right click, and we can go into copy AMI, and from here you can copy into any other region you want, and you can give it another name and another description, and essentially you'll copy that AMI into any other region, and you just press copy AMI. You could also modify the image permissions. So currently it's private by default. You can make it public just like that, or you could specify which other accounts have access to it. So if you have more than one AWS account, for, if you have multiple clients or something like that, you can type in the account number or the alias for the other account, and you can add a permission for them to be able to view this image. So that's how you can share it as well. So that's it for this video. Don't hesitate to experiment and play around. Go ahead and copy this into another region. Go ahead and share this with, a friend or something like that. In this video, we're going to be briefly discussing placement groups, which is an important concept when you're dealing with EC2 in AWS, especially when you're creating applications that require multiple instances, and these instances might, be communicating with each other, or they might be communicating with other networks or other applications outside of your VPC. But whatever the case, you're going to want to have a strategy based on how you want your multiple instances to be organized within an availability zone or within a region to maximize certain aspects. That could be speed, latency, it could be resilience against failure and that kind of stuff. So placement groups are what will allow you to do that. They are logical groupings or clusters, if you will, of instances in a selected AWS region. You can create a placement group using one of three strategies. So there are three different types of placement groups you can create. The first one is called a cluster, and this essentially packs instances close together inside a single availability zone. And for each of these strategies, I'm going to be elaborating and expanding on each of them in the following slides, so don't worry. And then the second one is called a partition, or the second type of placement group you can have is called a partition. And this essentially spreads your instances across logical partitions in a way that groups of instances in one partition do not share the underlying hardware with groups of instances in different partitions. So this helps protect against failures and creates resilience within your applications. And then there's one that's even more focused on keeping everything separate, and that's called spread. And this strictly places a small group of instances across distinct underlying hardware to reduce correlated failures. Okay, and there is no charge for creating a placement group, much like many of the other services like IAM and those kind of stuff that just come as extra settings or extra features with an existing service like EC2. There's no charge associated with it. Obviously there will be a charge based on if you're going to be creating multiple instances just so you can have a placement group, you'll be paying for those instances obviously, but just changing between cluster and spread will not change in the amount you're paying per instance. So let's start with the first one, the cluster placement group. And this is meant to illustrate how it looks. And this is from the AWS documentation. Again, I'm going to keep reminding you throughout the course to refer to the AWS documentation as much as possible. It's absolutely crucial, especially with the fact that AWS is constantly changing its settings and its features and all of that. So you got to get, stay up to date on that. So cluster placement groups are essentially a logical grouping of instances within a single availability zone, as you can see here. And even if they're within a single availability zone, they can span peered VPCs in the same region. Okay. And these are recommended for applications that benefit from low network latency and high network throughput, or both. So, especially if you're having instances that are constantly communicating with each other, right? You want very low network latency, high speed of communication between those instances. So you want to keep them as close together as possible. And that's where you'd benefit from a cluster placement group. And if you're not worried at all about, your application going down, when would you not be worried about that? Like if you're not really worried, if you're not serving a customer, or if you're not serving a user, like let's say you're doing some heavy data analytics or something like that, or some big data work. So you're just using the different instances to, to spread the workload of your data processing across multiple instances because, it's too much for one single computer, something like that. So you want, low latency, you want speed between instances because you're performing data analytics. But if it does go down, right? There's nothing on the line really. You know, all you have to do is restart your analysis. It's only you that's going to be affected, right? It's not like you have users that are trying to access your application and you're letting them down. So that would be a very good use case for a cluster placement group for that kind of big data work. And it's also recommended when the majority of the network traffic is between instance groups. So that's exactly what I was saying. You know, when the sole purpose or like the main goal of your application is inter-server communication, like just communication between your instances and you're not serving anybody specifically. And so the reason they're very prone to failure is, or they have less resilience, I would say, is that they share the same rack and availability zone. So if the rack fails, all the instances will fail at the same time, as opposed to one of the other placement group strategies where you have your instances spread across different racks. So even if one rack fails, you still have your other instances on your other racks. Now, the partition placement groups are a little bit different. They help reduce the likelihood of correlated hardware failures for your application, and that's because they are not all sharing the same hardware and they're not all in the same rack. Each group is divided into logical segments called partitions, hence the name partition placement groups. And each partition within a placement group has its own set of racks. Okay, so there will still be some instances that might still share some racks, so within one partition, but you will have multiple partitions. So you could set it up in a way where the critical instances are spread across multiple partitions. So even if one partition fails, and along with it all the other instances on those racks in that partition, you still have the other partitions to work with. Each rack has its own network and power source, and that adds to the resilience. And no two partitions within a placement group share the same racks, allowing you to isolate the impact of hardware failure within your application. So these are each partition is logically separated from the next, and they do not share the same racks across partitions. Now, in most cases, this will be what you'll want to use. Again, this will change on your use case, but as we mentioned, cluster placement groups have a very specific use case, when you're not really serving somebody. So if you're planning on making actual application to serve users, cluster groups will not be that useful for you. You could have part of your application be placed within a cluster placement group, but the front end, or the part that's going to be serving the front end user, would not benefit from a cluster placement group, but rather would benefit from a partition placement group. And then we also have spread placement groups, and these are essentially when each instance is placed on a distinct rack, and each rack has its own network and power source. So this is even more spread out, hence the name spread placement groups, from the partition placement group. And it's recommended for applications with a small number of critical instances that should be kept separate from each other. And the reason we say small is because you're limited to actually 7. And so it reduces the risk of simultaneous failures that might occur when instances share the same racks. So remember, even in the partition placement groups, within a single partition, you might be sharing the same rack. So there is still some possibility of problems happening there. But if you really need to isolate each one of your instances and you have a small number of instances and they're all critical, then the spread placement group is the way to go. And you can have your spread placement groups span multiple availability zones in the same region, and that just adds even more to its resilience. But you can only have a maximum of 7 running instances per availability zone per group. So keep that in mind. Now let's go on over to the AWS console and learn how to actually create placement groups and use them. So here we are in our EC2 dashboard, and let's very quickly just review the things we've gone over in the sidebar. So we've learned about instance This is what we've been using instances primarily, and then we've learned about AMIs, and we've learned about security groups. So we've gone into instances, images, and network and security. Now for placement groups, we're gonna be continuing with network and security, and then go into placement groups here. Okay, so go ahead and click on placement groups, and we do not have any placement groups in this region at the moment. We're going to go ahead and create a placement group, and we can name this placement group, like, let's call it like big data analysis, right? And so we want a cluster for that. We want a cluster group, or let's stick with the AWS naming conventions, big data analysis. Okay, and we want a cluster placement strategy for that, right? Because we want low latency and high speed communication. We don't care about failures that might affect the whole application, because we can just restart our analysis or pick up where we left off. We're not trying to please any end users or any customers. So let's go ahead and create this group. Now we have a placement group, okay, not to be mixed up with other groups that we've gone over, like groups in IAM. So it's called Big Data Analysis, and its strategy is of type cluster. So it's a cluster strategy placement group, and it's currently available. And let's go ahead and create another one. Let's just create, my application, and we want, we don't require the incredibly high low latency of a cluster group, and we don't have many instances that will communicate with each other frequently, but rather we have a large application and that we're serving this to the public. So we're going to just use a spread placement strategy. And by the way, my job here is to give you information on the different, I'm introducing you to the fact that there's something called placement groups, and they have different strategies and so on and so forth. But the use cases of AWS and its various services are endless. So, I'm not here to give you very specific examples on all the different ways you could possibly use the different features within AWS services. That's going to be up to you in your domain, in your work, to gain experience, to work with a senior, maybe go find a book or something like that, that just goes through like real world applications and that kind of stuff. So keep that in mind. I'm just giving you, from my experience of using AWS, how I would use these. But depending on your domain, depending on your company structure, so on and so forth, you might have, there might be completely different use cases for all of these. And, it's up to you to learn about that and to further develop yourself in that regard. My bad. We're gonna select partition. So don't get mixed up by the order. In the slides, we went through this in the order of cluster, partition, spread, but here it's cluster, spread, partition. So don't let that confuse you. Remember, spread is the one where everything is completely spread out, and nothing is sharing anything in common, and that's for very highly critical applications. But here we just want my application, just a normal application. So we're going to use partition, and we can specify the number of partitions we want. We can specify up to 7 different partitions. Okay, let's just go with 3, and let's create our group. So we have my application, we have big data analysis. My application is a partition strategy placement group, and then let's create one more, and this will be called critical app. Okay, it's highly critical, so we require a spread strategy, and we can go ahead and create that. So now we have 3 placement groups. Now you can create as many different placement groups as you want, and you don't. The only reason I created 3 and each of them having different strategies so I can show you, right? But you probably only need to use 1 or 2. There's no reason for you to go in and create 3 different strategies, but you can, right? This is potentially endless. So how do we actually use these, right? How do we actually launch instances in a particular placement group? For that, let's go into instances and let's launch. Let's go ahead and terminate this. No need to keep it running. We can terminate this one as well. So let's go ahead and launch a new instance. We're going to go with what we know, Amazon Linux 2, t2.micro, and we're going to go into configure instance details. We're quite familiar with this page by now, right? We can add in multiple, we can create multiple instances at once. We can put in user data, but now, and also we can, remember, we can turn on or enable hibernation. But right for this video, we're concerned about this section here. You can see placement group, and we can again use this very informative launch an instance in a placement group to benefit from greater redundancy or higher network throughput. Select an existing group or create a new one. So if we want to launch this instance in a particular placement group, we're going to have to check this box, add instance to placement group, and we can create a new placement group from here. So we can, create, a cluster placement group, and we can name it. Or since we've already created our placement groups, we can just add to an existing placement group. And here, when we click here, we can see all the different placement groups that we have created or that we have available within this region. So essentially, let's say we wanted to create 10 instances, and we're going to be using this for some sort of distributed big data work, right? So we're going to create 10 instances, and we can add them to our big data analysis cluster strategy placement group. And so now if we review and launch, which I'm not going to do because I don't want to launch 10 instances, but essentially we're going to be launching these 10 instances within the big data analysis cluster. Now, maybe we want to create another cluster, and we're not going to be doing the big data analysis, but we're going to be doing something else. Then you can go ahead and just create, my second cluster, and then, cluster, and then you just create it. And this cluster, cluster strategy placement group will now show up under your placement groups where we initially created the other 3. And also these 10 will be added to that group. So, likewise, if we were just going to be launching, just 3 instances, and each of them would be part of our application, we can just add it to my application. Or, if we're doing something critical and we require them all to be separate from one another, completely separate, then we can just use our spread placement group. Now, you'll see a note here that says you can only launch up to 7 more instances into this placement group, because a spread placement group can have up to 7 running instances per availability zone. So this is not 7 more on top of this 3. This is 7 more on top of what's currently within that group, which is 0. So for example, like I can't launch 10 under a single spread placement group, and we can even try, and it's not going to let us. A spread placement group supports a maximum of 7 running instances per availability zone. So that's basically all you need to know about security groups. And by the way, when you do want to launch within a partition strategy security group, you can select whether or not you want AWS to determine how it's distributed across the partitions. Remember, we created 3 partitions. So select the partition in which to launch the instances. If you select auto distribution, Amazon EC2 tries to distribute the instances evenly across the number of partitions. Amazon EC2 doesn't guarantee an even distribution of instances across all partitions. So they just say that to be on the safe side. But depending on the architecture of your application, you can, individually, decide on, which partitions the different instances will be launched on. If you have some sort of strategy or architecture that you've mapped out on paper, to maximize security or resilience or whatever it may be, you can go ahead and do that. But in most cases, auto distribution will be enough for you. And there are quite a lot of instance types, and you are expected to know quite a bit of them for the exam. I would advise you to just go ahead and memorize as many as you can. There is a system to how they are named and how they're, the letters that are used and so on and so forth. So just go ahead and try to memorize as many as you can. At least be aware of which ones refer to, which sizes and that kind of stuff. So before you can launch an instance, you must select an instance type to use. For up until now, we've been selecting, and this is after we select the image that we're using, the AMI image. So we select Amazon Linux 2 as the AMI image, and then we go into the next step where we select the instance type. Up until now, we've been selecting T2.micro, and that's because that's included in the free tier. And we just want to stick with what's free for now. We don't want to waste any money. And so that's what we've been using. However, obviously, depending on your use case, depending on your application, depending on your company, or whatever you're using AWS for, you're going to have to pick an instance type that is best suited for your use case. So this might depend on your requirements. And some of the requirements might be, availability zone or the region. Not all instance types might be available in all zones or all regions. And so this might be a deciding factor in which instance type you choose. Also the computational power, how much juice you require from the machine, how computationally intensive is the work you're doing or the application you'll be launching. Memory, likewise, some applications don't require as much memory, some require a large amount of memory. Maybe you're doing some work, some deep learning work or something like that requires memory as opposed to hard disk space, and so on and so forth. Networking, even the pricing, right? In our case, pricing was the deciding factor, because that's the reason we picked T2.micro. It was free for us. And storage, right? So again, here there's really not much to learn aside from just you getting, just opening up AWS and just memorizing. There's nothing much else to do here. It's going to all depend on your particular use case. If you're studying for the exam, again, you have to memorize these, but I'm trying to give you more of a practical know-how. And so, when you're about to go into a project, assess the requirements of your project and then go and search for an instance type that will best suit your project. So let's jump into the AWS console, and I'll show you very quickly how you can view instance types. So here we are in the EC2 dashboard, and on the left here, we're going to go into instances, instance types. Okay. Go ahead and click instance types, and here you'll see a complete list of all the different instances that are offered by AWS. There are 331 different instance types, so you can page through them here. And by memorizing, I don't mean to memorize. I'm not telling you to memorize 331. There is a system in the way they're named. You can notice that these are all T. And these are all A, these are all C, and there's dot large, dot X large, dot 2X large, so on and so forth. So if you do need to memorize it, you can use the system to memorize it, or at least be familiar with the different naming conventions that are used. So in general, what will change will be the CPUs, the memory, the network performance. For example, immediately you can see that these ones here, T2.nano through T2.medium, or even T2.large, have low to moderate network performance. And you'll also see the on-demand Linux pricing. We're not concerned with the Windows pricing, but here you'll be able to see, and you can filter by the cheapest. So the cheapest would be T4G.nano. This might change based on region and based on availability zone, just based on Amazon. So keep that in mind. You could filter for the best network performance. They're C5N.18X large, and so on and so forth. So this is where you can really explore the different instance types. Now, the way that AWS breaks these down is in terms of, general purpose instance types. So like, for example, the T's are in general, intended for general purpose. M's, the ones starting with M, are also M5 would also be like general purpose. And then they have compute optimized. So the ones that start with C are compute optimized. And then like memory optimized, the ones that start with R, you can think of it as, RAM, R for RAM, or even the new X instance types, they're memory optimized. And then you have accelerated computing instance types, like the P3, the G3, the F1, and then the storage optimized, which would be, H1, D2, I3. So, that information is very easy to look up, but that's how AWS breaks down their instance types: general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. So depending on your use case, you'll just have to look it up. Obviously you can't expect to memorize 331 different instance types, but be familiar with the different abbreviations. And again, as long as if you're studying for the exam, that's another story. But if you're going to be using AWS for practical purposes, people like to pretend like they can't Google anything and they have to know everything on the spot. But seriously, like when you're going to use, and when it's actually crucial for you to decide on an instance type, it's not too hard for you to look it up and to find different websites for comparisons. In fact, there's a very common one, and this is it: EC2 Instances.info. And here you can get a more an easier way for you to filter and compare the different instance types. This is a very famous website. In fact, this was around before AWS even had a mechanism for showing all the options. So you can, very easily look through and explore your options, and, look at the full names of each instance type. You can compare the selected ones. So you can compare these two, for example, if you selected it. So this one has a ridiculous amount of memory. That's for like some deep learning or some image processing or something. And it's also ridiculously expensive. That's the on-demand cost, the reserve cost. That's going to depend on your purchasing options, which we'll go into in the next video. But then, so this is a website you can use to refer to the different instance types, and it's easy for you to filter by region as well. But keep in mind, this is not affiliated with AWS, so you gotta always keep in mind that this information might not align 100% with the AWS information. So just when you do decide on an instance from here, go ahead and make sure that it's correct using the AWS console. So again, I was even thinking of skipping this video in the section because it's really not, there isn't really much theory we can go into, but I just put it in there as some extra material. So keep that in mind. Welcome to this video in which we will be discussing a very important topic, especially for those who will be taking the exam, and that is instance purchasing options, previously I guess known as instance launching types. But yeah, don't take me on my word for that. But what are now known as instance purchasing options. And the reason these are so important for your exam is because they are, topics that are very easy to create exam questions on. Very good questions can be created on, asking you in which situations which purchasing option would be preferred, and so on and so forth. So in the hands-on section, I'm going to be showing you most of these, but I'm not going to be going into too much technical detail as to how you would arrange the different settings and configurations and that kind of stuff, because what's more important for you is understanding the difference between the different purchasing options, and knowing when to prefer one over the other, and also the advantages of them, of each purchasing option compared to the others in terms of price and that kind of stuff. So with that, let's go ahead and start by seeing the different purchasing options that Amazon EC2 provides you. And the main driver behind purchasing types is obviously the cost. Whereas with instance types, we select our instances based on, whether we want to optimize our memory or maximize our storage or whatever, right? But with purchasing options, you're trying to minimize your costs. So you're trying to come up with the best purchasing option that will give you the lowest costs for your goals. So you might have just a website that you want to keep up and running for the next 10 years, right? So there's a purchasing option that will make that as cheap as possible for you. Whereas, in another case, you're not going to keep it up for 10 years. You just want a quick data processing job done, and for that, you don't care about the reliability or the length of your instances. You just want to have as cheap as an option as possible, and so there's another purchasing option that will make that more economically viable for you, and so on and so forth. So that's the main reason why you would have to put thought into which purchasing option you should consider. Now, the on-demand instances, these are the ones we're familiar with. These are the ones we've been doing so far. The default is an on-demand instance, and this is essentially what, where the power of cloud services like AWS come into play. The fact that you can literally on-demand, completely elastically allocate, virtual computational space for yourself and terminate it whenever you want, and you have complete control over it, and you only pay for what you use. This is what so revolutionary about services like AWS. And so you just pay by the second for the instances that you launch. That's it. And you only pay as long as your instance is running, and if you stop it, you don't pay. That's it. You have complete control over your instances. Now, there's a new purchasing option by AWS called savings plans, and these reduce your EC2 costs by making, by allowing you to make a commitment to a consistent amount of usage in USD per hour for a term of 1 or 3 years. So most of the purchasing options for EC2 that allow you to do long-term commitments, they'll either be in terms of 1 year or 3 years. But saving plans is a relatively new purchasing option, or actually it's quite new. And we're not going to be going into it too much in this course. It's a little bit more of an advanced topic, but if you're interested, you can definitely go into it. I'll still show you how to get to it. It'll open up your cost management console on AWS, and so that's a whole nother beast right there. So reserved instances, however, also allow you to reduce your EC2 costs by making a commitment, but this time to a consistent instance configuration. This includes instance types and regions for a term of 1 or 3 years again. So I'm guessing, again, savings plans are a pretty new purchasing option. So I'm not sure if it would be in the exam, but if it would be, most probably they might ask you guys a very specific question on, what the difference between a savings plan and reserved instances are. But I doubt it, since these are still pretty new and it's being established. But again, for safe measure, you can focus on studying the difference between these two. But my slides should be pretty, they should be quite comprehensive, at least enough for you to really understand the difference between these instance types. But if you do want to study further, maybe you do want to look up specifically what differentiates saving plans savings plans from reserved instances. So I will be going into more depth on reserved instances, but not savings plans. And then we have a very interesting purchasing type called spot instances. And these allow you to request unused EC2 instances. And this will be what will truly significantly reduce your costs. If you really are looking for the cheapest possible use of cloud computation, spot instances are the way to go. And I'm going to be showing you how to do all of that and how to look at the prices and that kind of stuff. And yeah, so I'll go into more depth in the following slides. I don't want to give too much away now. And then we have dedicated hosts, where you pay for a physical host, and this becomes completely dedicated to you and your instances. And so you can bring your existing licenses and so on and so forth. This will probably be very I doubt a lot of you will have to use this. This is very, or maybe you will, and this is very enterprise here, but. And then we have dedicated instances, where you pay by the hour for instances that run on a single tenant hardware. So single tenant is where you have, the hardware is dedicated to you, but you're paying for the instances, not for the hardware, as in the case of dedicated hosts. Again, I'm not going to go into too much detail on these, just as long as you memorize, these, you should be good to go. You can maybe look up some use cases on the differences, but it's pretty straightforward. And then we have capacity reservations. These are also pretty new, if I'm not mistaken, and they allow you to reserve capacity for your EC2 instances in a specific AZ for any duration. And again, these also I won't be going into too much. So mainly the 3 or 4 main purchasing options that you should really know very well are the on-demand instances, the reserved instances, the spot instances, dedicated hosts or instances. Okay, so on-demand instances, we're familiar with these. You pay for compute capacity by the second, and the prices are fixed, right? You can look them up based on the region, based on the availability zone, and you have no long-term commitments. You can terminate at any point. You don't have to sign on for a year or for 3 years or for any period of duration for that matter. And you have full control over your instances life cycles. You get to decide when to launch, stop, hibernate, start, reboot, or terminate your instances, quite comprehensively so far in this section. And these are recommended for applications with short-term irregular workloads that cannot be interrupted. Now, the reason for that is, as opposed to, for example, a reserved instance where, you'll be paying for, you'll essentially be reserving for at least a year or 3 years. And so, if you have an application that doesn't require, being up for that long, there's no point in paying for all of that. So on demand is the way to go. You could ask why not spot instances, since they're much cheaper, but spot instances can be interrupted, and they will be interrupted, and so they're not suitable for applications that cannot be interrupted. So that's why on-demand instances definitely do have their place, and they are very useful, and you will be using them quite often. Now, when it comes to reserved instances, they provide you with significant savings on your EC2 costs compared to on-demand instance pricing. And the reason for that is because you are paying up front, or even if you're not paying up front, because you get to choose how you pay, but you're at least guaranteeing that you will be paying for at least a year or 3 years. And because of that, because of the wholesale effect, you can get a much lower price. Now, reserved instances, you might argue, are somewhat contrary to the concept of cloud computation, where the whole focus is on demand and elasticity and that kind of stuff. And so AWS does allow you to sell these on a secondary market. So that kind of alleviates the problem of being locked into a year or 3 year contract. So The reserved instances are not physical instances. They're just a billing discount that's applied to an on-demand instance in your account. So by guaranteeing, right, by promising that you will be paying for that on-demand instance for a year or for 3 years, you get a billing discount. So that's essentially what a reserved instance is. And that might be a question on the exam as well. So watch out for that. And in order for on-demand instances to qualify for this billing discount, they must match certain attributes. And this can be based on instance type or region. And you can look that up because that might be subject to change, right? So when you do plan on purchasing a reserved instance, you can definitely look it up very easily on AWS docs on which instance types and regions will be granted this billing discount. So like we said, you can purchase them for a 1 year or 3 year commitment. And obviously, due to the wholesale effect, the longer the commitment, the cheaper the discount, or the greater the discount, I should say, the cheaper the price. And hypothetically, you could save up to 75% in cost by choosing reserved instances over on-demand ones. So this is one of the biggest mistakes I see from people. They have an application that they're going to keep running for as long as they can, right? They have no intentions to take it down. And they just, when they first started out with the project, they launched an on-demand instance and they just keep the app running on it. And why? If you're going to keep it, if you intend to keep it on for at least a year, why not just purchase a reserved instance and save up to 75%, right? So that's something that you could really use to save costs for your corporation. Or another reason this might happen to people is because initially they're on the free tier, so they're not really caring about saving on costs. So they just launch an instance in the free tier and they keep it running, and after a year it runs out and they start paying. And by then, they still haven't thought about using reserved instances, or maybe they don't know about them. So definitely watch out for that. And that's something you can really boast about to your boss, right? That you're really saving them on cost. And so, yeah, basically reserved instances are very good if you have applications, like I said, that will be running for a long time, or you're willing to commit to this longer term because you know that you will be getting your money's worth because you will be using that instance for that long. And AWS has acknowledged the fact that reserved instances are somewhat contrary to the cloud computation philosophy. So they have created something called a reserved instance marketplace. It's basically a second-hand marketplace where you can sell your reserved instances, and therefore alleviating the burden of committing to a longer term than you would for an on-demand instance. So you could I myself don't have too much experience selling reserved instances on the reserved instance marketplace, but I'm sure that you might be able to still get quite a bit of a discount without having to commit to a year or a 3 year contract, or not having to pay for a year or for 3 years, because you'd use as much as you need to. Let's say 9 months you need a server for, and then you could potentially sell it on the marketplace, and it would potentially be cheaper than you having rented out an on-demand instance for 9 months. So that's something to also look into. Now, spot instances are a very interesting concept, and I'm going to try to do it justice, and I'm going to try to give you more of a practical hands-on approach in the latter part of this video. But bear with me, try and understand this concept. Essentially, spot instances are unused EC2 instances that AWS normally would have to just leave unused, because they're just those those spots within their data centers that remain unused for certain parts of time, for various reasons, right? And instead of it remaining empty, which that's what was happening for a long time, they've decided to utilize this empty space instead of saying, and keep in mind, when I say empty space, I'm not talking about like racks and racks next to each other of empty, of unused computational space. I'm talking about, maybe there's a partition, or maybe there's, a placement group that's using up, certain racks, but they're not using up all the space on certain racks. So like in between different partitions, in between different users and different availability zones, there are some instances here and there that briefly remain unused, and so on and so forth, because it's impossible for AWS to constantly have all its instances being used. Obviously, if that were the case, that would be critical. That would not be a good thing for AWS. That would mean they're running out of space. So essentially, AWS came up with Spot instances as a way to utilize this empty space. So on their end, they're able to utilize it, so it's a win for them. And on our end, as the user, we are able to rent them for very cheap prices. So it's a win-win for both parties, and because otherwise, they would remain unused. So AWS said, AWS figured that instead of them remaining unused and them making $0 off of it, they could make a much smaller amount than they would on on-demand instances, but that's infinitely more than 0, right? And then we'd also get cheap instances. So that's essentially what Spot instances are. Their costs are much less than on-demand prices on the on-demand instances, and so if you design your whatever you need to use EC2 for around the concept of Spot instances, you can get significantly steep discounts and really lower your EC2 costs. And I'm talking like quite a lot. So it's good to know how to request Spot instances and all of that. I'm going to try to show you how to do that. Now, the hourly price for a Spot instance is called a spot price, and this will change based on the demand of the Spot instances. So you can look at the historical data of what different what instances in different Spot pools have been at, and based on that, you can bid on a price. And if your price is higher than the Spot instance price, then you will be granted that Spot instance. So again, it does sound a little bit confusing at first, but just bear with me. It's a very cool concept, and it's not too difficult to understand. So the Spot instance is set for each instance type in each availability zone by Amazon EC2. So there are things called Spot pools, and these all share the same instance type, the same availability zone, the same operating system, etc., and they will share a spot price, and that spot price will fluctuate. And the spot price is adjusted gradually based on the long-term supply and demand of Spot instances. So if there's higher demand, and you might notice a great variability between availability zones. If there's a higher demand for Spot instances in a particular availability zone or a particular region, the prices there might be higher. So if your application is not dependent on availability zone or region, that might also be something to consider to really reduce your costs. So Spot instances run whenever capacity is available and the maximum price per hour for your request exceeds the spot price. So essentially, if the spot price is at X currently, and you've bid X plus 1, and you've put in a spot request, you will be granted it as long as there is capacity available, right? Because there is a chance that your maximum price per hour of your request is much greater than the current price of the Spot instance, but there might just not be any capacity available. So these two conditions have to be met for you to be granted your request. Spot instances are an effective choice if you can be flexible about when your applications run and if your applications can be interrupted. So they are definitely not good if you're going to be using a single spot instance to, launch a website that is supposed to be running full time, or a database, or anything that's critical that depends on constantly being online. Then a single spot instance would not work for that. You could use a fleet of spot instances. They're called spot fleets, and then like a load balancer or something, so that you can just jump between spot instances, and when one is interrupted by Amazon, you could just jump to another one. So a very good example for when spot instances would be well suited for your particular task would be for like data analysis or batch jobs, background processing, optional tasks. So anything that is not critically dependent on the app being constantly online or constantly connected. When you're running data analysis, it's okay if one of your spot instances gets interrupted for some time before another one is allocated for you, right? Like, it's okay. Instead of your analysis finishing in 5 hours, it might finish in 5.5 hours, right? That's okay. It's not critical. Or like I said, if you have some sort of load balancing in place where you can send users to the spot instances that are available, that do have capacity, and you have enough spot instances in your fleet that at any one time you at least have one up and running. So if you can manage all of that, you will see quite a bit of discount in how much you're having to pay for your EC2. Since spot instances are such an important topic, I added on another slide just to give you a little bit more information. So you can get up to 90% off on your instances if you use spot instances compared to on-demand prices. So that's the most cost-effective purchasing option. Neither the reserved instance or the other ones will give you that much, right? But that comes with a trade-off. Like you do get this potential for a 90% off, but your instances can be interrupted at any point in time. But they will give you a 2-minute notification before they do that. So they will let you know that they need their capacity back. But if you're using a fleet, that shouldn't be a problem. And also, if you set it up so that if a spot instance is reclaimed by Amazon, a new request is put in automatically, so that as soon as another spot instance is available with capacity, it will be allocated to you. Now, when spot instances are actually running, they're the exact same as on-demand instances, because remember, we said spot instances are just the extra instances running around, laying around, the extra on-demand instances, the instances that would normally be sold at on-demand prices, but they're not, they're just empty and they're waiting. And instead of them waiting, Amazon offers them up for use. So, when they're running, you treat them exactly as you would any on-demand instance. And they're not suitable for workloads that are inflexible, stateful, fault tolerant, or tightly coupled between instance nodes. So, for example, databases and other applications like that. One important term, I briefly defined this, but it's good for it to be up on the screen for you to see. Spot instance pool is a set of unused EC2 instances with the same instance type. For example, M5.large, operating system, availability zone, and network platform. So essentially, when you specify a type of instance, and obviously you specify the operating system, the availability zone, and the network platform, then within the spot instance pool that corresponds to those selections, there will be instances that are available that have capacity, and those that don't, and the instances in that pool will have, you know, a spot price, and essentially you will be getting an instance from there based on your request, you know, if your request aligns with that pool, right? And a spot fleet is a set of spot instances that is launched based on criteria that you specify. So this essentially allows you to put in multiple requests with these, you know, for the same instance type, operating system availability zone, you know, etc. But, you know, Amazon puts them in for you. So you specify it in the beginning, and then Amazon will be putting in those requests for you. So you don't have to put in individual spot requests for each instance you want, if you want more than one. Now, that's enough for spot instances. You're going to get some more exposure to them in the hands-on section of the video. Let's go ahead with dedicated hosts. So dedicated hosts are a physical server with EC2 capacity fully dedicated to your use. So you're basically renting it out. You're not sharing with anybody else. It's completely yours, and you get to decide what to do with it. And this allows you to use existing licenses and so on and so forth. And it also allows you to, you know, determine your own placement groups. And you are able to allocate dedicated hosts for a year or a 3-year term. And you have full control of EC2 placement groups, like I said. And you avoid the sharing of physical computing resources with other AWS customers. So this might be something that's very crucial for your company or your enterprise. And this is a gateway into AWS for a lot of companies that do have, you know, legacy enterprise security in place, where, you know, they have a phobia of cloud systems. They don't want anything leaving their company, so on and so forth. So, you know, this might be a way for them to transition into trusting something like AWS, because at least with dedicated host, you are getting access to that hardware completely, you alone. Nobody else is going to be sharing it with you. Now let's jump into the AWS console for some hands-on with instance purchasing options. Here we are again in the EC2 dashboard. Now we will be able to finally explore the rest of these options under instances. So let's just go ahead and close these. And, you know, we've already had a lot of exposure to instances here, and in the last video to instance types. And now let us actually start off by going into spot requests. So spot requests are what will allow you to put in requests for spot instances. Let that load. So right now we have no resources in this region, and AWS acknowledges that this is somewhat of a difficult topic to master, so it sends you to a getting started page. So you can go ahead and definitely check that page out if you want to really know what you're doing before you go ahead and do anything. But before we do anything, actually, we can just go into pricing history here. And here you can see the history of different the pricing for different spot pools, and by default it's set to 1 week. You can do, you know, put this up to 3 months at the max, and you can select. So for us, you know, we're familiar with the T2 micro, T2.micro. So let's view the spot price history for that. Now remember, a spot pool is determined by the availability zone. So, you know, there are 3 availability zones in each region. So by the availability zone, the instance type, and the platform. So for the instances that, you know, fall into, let's close, for example, these 2 availability zones. So that fall into US East 2A, that have an instance type of T2.micro, and that have a Linux platform. Of all those instances, the spot price for that pool has fluctuated like so. Now, what's striking is that despite the fact that, you know, spot instances prices do change based on demand and supply, they are quite steady. So it's not too difficult to bet on them, especially when compared with, you know, the worst case price and the on-demand price. So, you know, essentially, if you really want to be on the safe side, you could bid at 0.008 cents or $0.008, 0.8 cents, and be on the safe side. You know, here you would be, you know, you have a much significantly bigger chance of a discount by bidding low. But if you want to stay on the safe side, the worst case you could do is you could bid up here, and it's highly unlikely that the price will ever pass that in the future. So you would have a pretty stable application, but AWS does still claim the right to take back any of your spot instances. So, you know, you gotta live with that possibility always. Now, you know, this is for this availability region, but if we look at the other ones, for example, this one, you can see that it's been a pretty consistent, you know, 0.00, let's say $35. So you could pretty safely, you know, bet on 0.004 and expect, you know, a 99% chance that the price will never pass it. So that means you're saving essentially, you know, 70% on the on-demand price, because this is what the on-demand price would be for this instance in this region. For this platform, the on-demand price would be, you know, close to $0.12. So you're saving quite a bit, 70%, right? And likewise, you can check for any other instance you want. So for example, you know, instead of getting an on-demand instance for, you know, 0.012, maybe you can get like, and that's a T2 micro, maybe you can get like a T2 X large spot instance that'll be around the same price as a T2.micro, and so on and so forth. So you can do your own comparisons, but it's pretty good that, you know, the historical price is pretty stable and it's not fluctuating like, you know, some currency or something, but, you know, there's always a chance that they will be reclaimed. So watch out for that. Now, to put in a request, you just click on the orange button there, and a lot of these configurations are new to AWS. They've done, you know, they've observed, you know, the most common use cases for spot fleets and spot instances, and they've come up with configurations, you know, quick configurations to help you with that. For us, you know, this is something that's, I guess, pretty common. Stick with load balancing workloads. This is the example I mentioned, where you have a website running or like a web service running or web app or something, and you just want to, you know, have a cheap set of servers that might fail at any moment, but you have like a load balancing or something set in place where, you know, you would be able to redirect the user to the running instance, so you wouldn't have a problem with them being interrupted. And then you just continue from here, just, you know, selecting your instance type. You can change your instance type. For example, we can change it to a T2.micro. So let's search for T2.micro. Let's select that one. And then, you know, we only have one VPC. We don't prefer the availability zone. We'll just let Amazon deal with it, and our key pair name. And then here we have the option of launching more than one instance, and this becomes essentially a fleet, you know, spot fleet. So we can put in 10 requests, and if we select maintain target capacity, if any of those 10 get interrupted, then AWS will put in, you know, renew its request on our behalf, so that when another one becomes available, it's put back into our fleet. So in this way, you can average, you know, at least, I don't know, maybe 5 or maybe even 8 instances that are constantly running, but you get the advantage of having a spot price on all of them. And there are some extra configurations. And then you can also apply recommendations. So this means that in the case where the particular instance type or the particular spot pool that you requested has nothing available, what other pool might EC2 reach into on your behalf to make up for that? So in this case, we picked T2.micro, but T2 small is also pretty similar to that. So in the case that no T2.micros are available, we're telling EC2 by allowing them to recommend this, that they can actually supply this as well. But even with that, the fleet strength is weak. So you could potentially add more to make it stronger. So adding more instance types or availability zones will increase the likelihood of fulfilling your request at the lowest price. 2 instance types times 3 availability zones equals 6 instance pools. Okay. And so on and so forth. So right now we have 6 instance pools because of the 3 different availability zones and the 2 different instance types. But 6 instance pools is classified by AWS as being, a weak fleet. And so you might want to adjust that in order to make it stronger. But given that, and based on the historical price, you are getting a 70% savings amount compared to on-demand instances. And this ends up being the price. And this is basically, this is a price that you'd probably be able to rent a single on-demand instance for. So you're essentially getting 10. And this is definitely pretty advantageous if you do master how to use spot instances, and you do make sure you have a budget in place and that kind of stuff, so you're not accidentally going overboard. But the thing is here, you have to set the maximum cost for spot instances so that you don't accidentally go overboard. And that's the real beauty of this. There's no way to spend extra on accident, right? With on-demand instances, if you don't have other measures in place, right, alerts and alarms and that kind of stuff in place to check for when you exceed a certain limit, you can potentially go, keep going up and up and up in terms of costs, right, if you're not paying attention. But with fleet instances, you specify like $1 max cost per hour. So if what's available now is more expensive than $1, you won't get anything, right? You won't be allocated any instances, so you won't be able to run whatever you're running, but at least you won't be charged more than that, right? And hopefully, if the historical prices hold up, you could make this quite a low amount compared to an on-demand instance, and you would still be getting access to instances and servers. So I'm not going to launch this just because I don't want to launch 10 servers, but essentially, if you do launch it, that's what's going to happen. And you can try this out on your own if you want. Now let's go back into the sidebar and let's go into reserved instances. So here is where you can reserve instances, and you have to purchase reserved instances. You can select, your platform, instance type, tenancy. So by default, it's shared. If you want a dedicated machine, you have to set dedicated. So, if you have security concerns or something like that, and then the term 1 year or 3 years, so on and so forth. And essentially from here you can purchase a reserved instance, and this is pretty similar to how you would purchase a server on any other platform, a non-elastic, a non-on-demand platform, just like a server for a year or for 3 years for a website or something. So this is essentially AWS's version of that. And then if we go into dedicated hosts, here is where you can allocate dedicated hosts. Again, I told you earlier that I'm not going to go into the technical details. They're pretty straightforward. By now you should have had pretty good exposure, right? A name tag, instance family, right? These look familiar to you. You know that this refers to instance, the families of the instance types, and then instance type, availability zone, etc., the quantity, so on and so forth. So I'm not going to go into technical details because, quite frankly, you don't need it unless you will actually be using a dedicated host, in which case you should review documentation before you do anything anyway, right? Even if you know it very well. But for the exam, all you need to know is when a dedicated host might be needed and why it might be preferred over another purchasing option. So let's go back into EC2, and yeah, that is pretty much, like I said, savings plans are pretty new, capacity reservations are pretty new. You can go and learn some more about that, but I don't want to make this video too long and to give you too much. These are essentially the ones I cover are the core purchasing types of EC2 and AWS. So make sure to learn that well, review the slides, memorize the definitions. But this is not an IT course, so I will not be going into anything serious when it comes to public and private IP addresses and how they're structured and how they work and how networks work and that kind of stuff. This is an AWS course, so I will just be showing you what matters in relation to AWS, and we'll be also focusing mostly on a service or a feature within EC2 that AWS provides called Elastic IPs. But let's briefly get acquainted with what public and private IP addresses are. So a public IP address is the address that is assigned to a computing device, or in our case, an instance, which is a computing device, to allow direct access over the internet. So if a computing device or an instance wants to be accessible over the internet, for example, in our case, the instances that we launch, if we want people to be able to access it through the internet, or even if we want to access it ourselves over the internet. So this could be through, an HTTP protocol, or it could be through SSH, right? Like we've been doing. Whatever the case may be, it needs to have a public IP address so that, it can be referenced, it can be referred to on the public network. A private IP address, on the other hand, is assigned to devices within a private network. And that private network is local and it's private, and it's not directly exposed, or it doesn't directly expose all the devices within its local network to the public. And so the local devices, can have IP addresses that, other devices in the world might also have, but since they're not exposed over the internet, it doesn't matter if they're unique or not, as long as they're unique within the local network. And so this allows, for example, in our case, it allows instances to communicate with each other within the same VPC without being exposed to the public. So you could have your port 80 closed, you could have your port 443 closed, so people can access the instance over the internet, but you would still have a private IP address that can be used within instances that are also located within that same private network. So again, I'm not going to be going into details on how, these IP addresses are structured, different ranges that exist, and so on and so forth, because this is not a networking class. It is not an IT class. So if you are curious about that, you can go and, there are a lot of resources online, but I'm just going to be talking about what concerns us when it comes to AWS and EC2. Now, EC2 and VPC support both the IPv4 and the IPv6 addressing protocols. And again, I'm not going to go into the differences between them. IPv6 is a newer addressing protocol, and it's meant to help alleviate the short supply of IPv4 addresses. But in our case, and by default, IPv4 is used by Amazon. And in our course, we are only concerned with IPv4 as well. So don't bother with IPv6. If you're curious about the difference, you can go and look it up. But by default, it's IPv4 that's used both by Amazon, EC2, and by us in this course. Now, private IPv4 addresses are what allow you to communicate between instances within the same VPC. And these are, you can assign or allocate more than one private IPv4 address to your instance, but the primary one is allocated at launch. So at launch, your instance comes with a private IP address. Now, this private IP address remains associated with the network interface when the instance is stopped and started, or hibernated and started, and is only released when the instance is terminated, because that's when the instance is dead anyway, and you can't come back from it. So there's no need to preserve the so there's no need to preserve the private IP address. Now, when it comes to public IP addresses, you can use public addresses for communication between your instances as well, right? You can, you don't have to rely on private communication. You can, if you really want to modularize your application instances and allow for, plugin type of modules and units, then you can prevent any private communication between your instances and solely require them to communicate through a private public network. But additionally, now they have exposure to the internet as well, to other users and others who want to access it. And public addresses are also assigned by default on launch, and it is assigned to your instance from a pool of public IPv4 addresses, and these addresses will not be associated with your AWS account, meaning they might, there are situations in which they might be released, and when they are, they just return back to Amazon's pool to be reassigned to somebody else later on. And when when a public IP address is disassociated from your instance, it's released back and you can't reuse it. So you have no ownership or right to that IP address. And you cannot manually associate or disassociate a public IP address from your instance. So that's just done by AWS. It's associated on launch, and in certain situations, it's just released from you. And I'm going to go over those in the next slide, in which situations the public IP address will be released from you, and you have no control over, the association or disassociation. So that means you can't really depend on your public IP address for anything long term, and that's where the elastic IPs come in. So in certain cases, the public IP address from your instance is released or a new one is assigned, and those are when your instance is either stopped, hibernated, or terminated. So in any of these situations, the public IP address will be released, and a stopped or hibernated instance receives a new public IP address when it is restarted. So this is very important, and this is a very common mistake, right? If you have like a web service that's running on an instance and you've exposed it through to the internet, and you pass out your public IP address for people to access it, you might find that all of a sudden they're not able to access it. Why? Because you've rebooted your instance, you've stopped it or you restarted it or something, and so the public IP address has been released and a new one assigned. So that's something to be careful about. If it's crucial that you have a stationary public IP address, you need to allocate an elastic IP or use another type of solution where you have, internet gateway, and then that communicates directly with, through a private IP address with your instance or something like that. And another situation in which your public IP addresses are released is when you associate an elastic IP address with it. So you can't associate an elastic IP address with an instance and then unassociated with it, remove the elastic IP address and expect to keep its same public IP address. So when you disassociate, it receives a new public IP address essentially. So if you require a persistent public IP address that can be associated to and from instances as you require, use an elastic IP address instead. And that's the topic of our next slide. So elastic IP addresses will save you in the situations where you need a persistent public IP. So it's essentially a static IPv4 address designed for dynamic cloud computing. And it allows you to mask the failure of any instance or software by rapidly remapping the address to another instance in your account. So essentially, if the port of entry or the reference address to your web service or whatever you have on your instance for the public is your Elastic IP address, and that's the only point of communication, that's the only point of entry into your instance, you can essentially take away that instance and put another instance in its place and associate it with the same Elastic IP address, and the user would not know the difference. So this means that if you have an Elastic IP address, which is something you control which instance to associate it with. If something happens to your instance and it goes down, you can easily replace it with another instance, and the user will still be accessing your service through the same IP address. Whereas, with a public IP address, it's gonna be reassociated with a new public IP address, which the user is not aware of. And so you'll have to reissue inform them about, on the new IP address. So that's the use of an Elastic IP address. And Elastic IP addresses, unlike public IP addresses, are allocated to your AWS account, and it is yours until you release it. And you do have to release it. It's not enough disassociating your Elastic IP from an instance. Once you allocate one, even if you don't associate it with an instance, it remains on your account. So you will have to actively, you will have to go in and release it if you no longer want it. And, it essentially gives you a public IP address that is reachable from the internet. And, just to keep the service manageable and to avoid people hoarding the Elastic IP addresses, because they are a limited resource, AWS does charge you for keeping an Elastic IP address if it's not associated with a running instance. So as long as you allocate your IP address and then associate it with a running instance, you're fine. It's free. You're not charged. But if you just hoard Elastic IP addresses, so you just allocate them and they're just sitting there in your account and they're not associated with any running instance, in that case, you will be charged. And that's just to incentivize you to release them back so that this limited resource can be used by others who do need to use it. And so you're not charged for it as long as your instance is running. And you, again, for the same reason, because they are, IPv4 public IPv4 internet addresses are a scarce public resource, so you are limited to 5 per account per region. Even if you're willing to pay for it, AWS does not allow that, because that would definitely cause problems, and people that are willing to pay lots of money for it would just hoard IP addresses, and that would cause a problem, right? So you are limited. So let's jump right back into the AWS console, and I'll show you how to allocate Elastic IP addresses. Here we are in the EC2 dashboard, and right away you can see that we have 0 Elastic IPs. We do have 3 placement groups. Remember, we created the 3 different placement groups, and we have 5 security groups. Some of those are left over from terminated instances, but we do not have any Elastic IPs. So we can either click here, or we can go under network and security and click on Elastic IPs right here. We've gone into security groups, we've gone into placement groups, we know about key pairs. We'll do network interfaces in the next video, but now we're at Elastic IPs here. And we can allocate an Elastic IP address, but we're going to be charged for it as long as it's not associated with a running instance. So let's go into instances and let's quickly create for ourselves, or launch an instance for ourselves. And in fact, we can just go into my AMIs and just launch from the AMI that I created instead of going through all these steps. Once again, remember, we created this web server AMI that comes with Git, Docker, and Apache server. So we're just going to select that. review and launch, skipping everything, and just launch directly. And now we have an instance that is being launched. It's pending. It'll be running soon, and then it'll go through its status checks. In the meanwhile, okay, so it is running now. If we click on it, we will see that it has been allocated a public IP address and a private IP address. So this is what can be used within the VPC, the virtual private cloud, to communicate with this instance, right? If you have another instance within the same VPC, within the same region and AZ, then you can use this to communicate with it, even if it's not exposed to the public in any way. Now, to access it through the public network, through the internet, we'd have to use this IP address. And again, you can go back into the slides and review of, when these are released. The private IP address will stay with this instance as long as that instance is in existence, until it's terminated. But the public IP address, has a high chance of being released. If it's stopped, it'll be released, and so on and so forth. Now, we want to access this instance from the browser. And because we used our image, the AMI image that we created, the web server one, we know that this has an actual web server running on it, right? So if we go into the instance and go into security, it's exposed through port 22. However, it's not exposed from port 80. So let's go in to the instance, go into actions, security, change security groups, and let's assign it the HTTP access security group. Let's save it. And the checks have been passed. This means that now, using the public IPv4 address, we can, on port 80, so HTTP, we can actually access our instance. And let's just let that load. Let's check to make sure we have the right port. Okay, so for some reason we did not save, apparently. We didn't click save, I guess. So let's just add HTTP access. Okay, we didn't add security group. That was our mistake. So you gotta click add security group, click save. And now if you come into here, there we go. We have access to our instance through the internet on its public IPv4 address. But again, this one doesn't work, right? The private one will not work. That's not going to work, right? So, okay, let's copy the old address so we have it on hand. Let's stop this instance, not terminate it. Let's stop it. And it's been stopped. Let's now start the instance back up. We have to wait till it finishes stopping. Now that the instance has been stopped, we can start it back up. It's pending. Look, since it's stopped, it no longer has a public IP address. That public IP address has been released back into the AWS pool of public IPv4 addresses for other people to use. So now you can see that we have a completely different public IP address that has been associated with this instance. And what this means is, if we try to use the old IP address, it's not going to work. Okay, this was the old IP address. It's not going to work. We have to copy the new one. And then we have to use that to access the same instance. As you can see, the IP, the private IP has stayed the same. So this is a problem, right? How do you expect to have a service running on your instance if it, if it's going to have a new IP address every time it goes down or every time it's rebooted? So how do we solve that? We solve that using elastic IP addresses. Right now we have no elastic IP address associated with this instance. let's change that. Let's go into Elastic IPs. Let's allocate for ourselves an Elastic IP. So we want to allocate an Elastic IP. And there we go. It's allocated. We now have an Elastic IP, which is a public IPv4 address. And this is the address. And it's been allocated to our AWS account. So now we are, the owners of this IPv4 address, if you will. However, it's not associated, if we click on it, it's not associated with any instance. There's no instance that's been associated with it. And this means that if we do not associate it, and if we continue keeping it like this, we will incur charges. And that's to motivate us to release it back. But we want to associate this with an instance. We don't want to get charged for it. So let's go ahead and click Associate Elastic IP Address. And then we select the instance we want to associate it with. Right now, we only have one instance. And so it's easy to pick. And then, or we could pick based on the private IP address of that instance. So it doesn't matter. It's the same thing. And then we want to allow this this Elastic IP address to be reassociated. So this means that, if you terminate your instance or your instance goes down or something, do you want to be able to use this Elastic IP again and associate it again with a new instance? So we're going to go ahead and click that. Let's associate before we get charged. And there we go. We now have this instance associated with this IP address. And when we click on it, on the instance, and go into the instance, we will see that now we have a different public IP address, different from the new one we just got from rebooting our instance. But this one is now here to stay, right? This one now we can use. We can now use this. Let's copy it. This gives us access to our instance. And if we stop the instance, and then we restart it, you see when we stopped it, we didn't lose the public IP address. This would have normally been gone, but because it is an Elastic IP, it is still there, even though the instance has been stopped and is currently restarting. So there we go. Our instance is up and running again after it's been stopped, and it still has the same IP, public IP address. And if we refresh it, we still have access to the same instance. So that's how you allocate and associate an Elastic IP with your instance. And now, if we wanted to, we could disassociate this IP address from our instance. And so we go into Actions, disassociate Elastic IP address. Yes, we want to disassociate. But now we still own this Elastic IP. It's still allocated to our account. So if we don't do anything now, we will start getting charged for it. So what we want to do is go into Actions, and we want to release this IP address, Elastic IP address, back into the wild. And just like that, we no longer own that Elastic IP address. Now be careful, don't do that if you have a service that's relying on that IP address, to have users connect with your service. So be careful. And welcome to the last video in this section, where we'll be going over Elastic Network Interfaces, or ENIs. And now this is normally somewhat of a more difficult topic for people to grasp. But now that you've had exposure to IP addresses and the idea of elasticity when it comes to allocating Elastic IPs and that kind of stuff, it shouldn't be too hard for you to wrap your head around. And in fact, we've been dealing with Elastic Network Interfaces, or ENIs, indirectly for quite some time now. We just haven't realized it. So an Elastic Network Interface is a logical networking component in a VPC that represents a virtual network card, okay? It can include the following attributes: a primary private IPv4 address, one Elastic IP address per private IPv4 address, one public IPv4 address, one or more security groups, etc., etc. You can include MAC addresses, and it can include a description and a lot more. But you can create and configure network interfaces in your account and attach them to instances in your VPC. Now, what's the point of that? You can create a network interface, attach it to an instance, detach it from an instance, and attach it to another instance. And what happens is the attributes of a network interface follow it as it's attached or detached from an instance and reattached to another instance. So just like how we were able to manage failure and that kind of stuff by allocating or by associating and disassociating elastic IPs, you can do that on another level using elastic network interfaces. So instead of associating and disassociating elastic IPs directly to the instances, you can have elastic network interfaces that have their own, public and private IP addresses, that have their own elastic IP addresses, so on and so forth. And then you just associate that with an instance, and all of a sudden, all the attributes are now associated with that instance. So if you're using a private IP address, now you can use it on that instance. If you're using a public IP address, elastic IP, whatever it is, a MAC address, now it's associated with the new instance. So it's like a larger or more high level version, the concept that we've been working with. Now, a network interface is moved from one instance to another. Network traffic is redirected to the new instance. So that is the main advantage of ENIs. And you have to keep in mind that they are bound to a specific availability zone. So keep that in mind. Okay, now let's just jump straight into AWS for just some quick exposure to elastic network interfaces. So here we are in our EC2 dashboard. We have our elastic IP, we have our running instance, and now we want to create ENI, which is an elastic network interface. And to do that, we can go into here under network and security. But before we do that, let's go into our instance and let's open it up, and we can see, and let's go into networking. And here we can see the ENI that is associated with our instance. So since we have, when you launch an instance, a new ENI is automatically created and is associated with your instance. And that's where your instance gets its public IP address as well as its private IP for a private IP address. So essentially this ENI or this network interface is associated with this instance, and that's where this instance is getting that from. Now if we were to go ahead and launch a new instance, and let's just use our image that we created. We would now have another ENI that has been created that is now associated with this new instance, and that we can see here. So, if you compare the two, you will see that they are different ENIs. They have different IDs. And they essentially have different public IP addresses. They have different private IP addresses, and so on and so forth. And each of them belong to a different instance. Now, they also, I mentioned in the slides that they can also have a security group associated with it. So this ENI, for example, has this security group associated with it. If we were to go into our instance and go into security, we would see that it also only has port 22 associated with it. So let's change security groups. Let's also add HTTP access, add security group, save. And let's go to networking, and let's go into ENI. Let's click on that security group. It still only has access to the SSH. Okay. Whereas our instance has access to the port 80. but we can also assign this security group to the ENI as well. Now, here's the thing now. When we go into networking, if we click on the ENI and we come here, we can see that we have two ENIs. Why? Because we have two instances, and these ENIs were created for those instances. Now, where it gets really interesting is that we can actually create our own ENIs. So here we can create, second ENI, and we just pick any subnet, and we want to assign to it HTTP access and also SSH access, and we can go ahead and create our network interface. And now we have our second ENI here. It's available, it's not in use, and it hasn't been assigned to any instance, and therefore it does not have a public IPv4 address, but it does have a private IPv4 address. So now if we click on this and we go into actions, and we can associate, or we can attach the ENI. One thing that you have to keep in mind that we did not keep in mind is that I mentioned in the slides that ENIs are specific to certain availability zones. This means that you can't associate an ENI to an instance that is in a different availability zone. So the mistake we made here was that we created this ENI in the US-East-2B availability zone, whereas my other two instances are in two other availability zones, even if they're within the same region. So let us go ahead and delete this ENI. That's all right. We're just getting more practice. And now we can pick, for example, this subnet that belongs to this availability zone. And we'll just call this again second. And so you can actually assign it a custom private IP address, but we're just going to let it auto assign. And we're not going to go into Elastic Fabric Adapter in this section, but we can associate with it HTTP access, SSH access, and let's create the interface. And there we go. It's the second ENI. We called it that, right? And so you can see it's a completely different network interface, and it has its own private IP address, but it has no public IP address because it's still available. Now let us attach it. And we can choose an instance. The only instance within the same availability zone is this one. So we can click on it and we can attach it, but it doesn't deattach the other one. So if we go back into our instance, this is the instance, we go into networking. First of all, here we see it right off the bat that we have two public private IP addresses now, and down here we have two network or ENIs, Elastic Network Interfaces, associated with it. There's only one public IP associated with it, but it does get a second private IP address from it. And so now essentially what we can now do is we can create another, if we had another instance within this same availability zone, we would be able to deattach this from this instance and attach it to the other one. So let's go back into here. Right now, this is attached to this instance, and this is also attached to the same instance. Now, so if we were to, let's go into instances. Let's delete, or let's terminate this one, terminate instance. Let's launch a new instance. This time, let's make sure that it's launched in the correct availability zone, that we want it to be launched in this availability zone here. So let's review on launch instances, view instances. Now we have two instances now that belong to the US-East-2A availability zones. Let's call this one 1, and we'll call this one 2. And that one's terminated. Now, if we go into network interfaces, we will see that we have, let's refresh this. There we go. We have now 3 ENIs. This ENI is the one for the new instance that we just created. This is the one, the original one for the last one, the first instance, and this is a second ENI for the first instance, okay? So this means that this instance here has 2 ENIs and therefore 2 private IP addresses and you know, 2 of everything basically, because of the 2 ENIs here. And this one here only has 1, and it was freshly created. What we can now do is we can detach this ENI from this instance and attach it to this one here, okay? And how we do that is we select the second ENI, we detach it first. We gotta wait for it to detach. And there we go, it's now available. It no longer has a public IP address. And now, you know, it's detached from this one, from this instance. So if we refresh it, not working, there we go, it's no longer there. Now we want to attach it to this instance here. So 587, instance 587. So we want to attach this one to this. So we can now go ahead and attach this ENI to our second instance that starts with 058. So it's 058. Oh, and we can see the name of it here. So it's instance 2. And reattach it. And now there we go. We have now this second ENI attached to our second instance. So if we refresh this and we go into networking, we should see that we have our second ENI attached. So this gives you a lot of flexibility and control, and allows for high availability in your applications. You know, you can just build your networking on ENIs and then just use those to associate with instances. So this essentially allows your instances to be dispensable, especially if you're using images or you know, containers and that kind of stuff. So it really gives you versatility and robustness in your infrastructure and your architecture. So if we're done with this ENI, we can go ahead and detach it and then wait for it to get detached and to be available. And then we can go ahead and delete this ENI. And there we go, we're back to our default DNIs that came with our instances. So that's the end of this section. I will see you in the next section. Amazon EC2 storage. We have just completed our section on Amazon Elastic Compute Cloud, or Amazon EC2 for short. And in this section, we're going to be focusing on just the storage when it comes to EC2, the different options that are available, and within those options, the different configurations, and so on and so forth. Now, as is common with AWS in all their services, they provide you with complete control and complete access to all the different options you might ever need for any type of use case. So it's up to you as a solutions architect to become familiar with these different options in order to properly assess which are applicable in your given context for your given, you know, company or your given project or whatever it might be. So let's start off Amazon EC2 with Amazon EBS, which stands for Elastic Block Store. So this will be the most common attachable storage you might use for EC2. And it's a standard one. It's the one that, you know, the instances that we've been creating so far have been coming in default with. So there is something called an instance store which some instances will come with by default, and they're ephemeral storage devices. They're not even devices, but in our case, we've been using the burstable instances, right? The T instances, and those come with, by default with a root volume that is actually an EBS volume. So what is EBS? Let's learn a little bit more about EBS. EBS provides block level storage volumes for use within EC2 instances. So the key terms here are, they're block level and their storage volumes. And they behave like raw, unformatted block devices. So, once they're attached, you have complete control over what to do with them, in which way you want to format them, whatever the case may be. They're just raw, unformatted block storage devices. And you can mount these volumes as devices to your instances. And the advantage of these volumes is that, they are exposed as storage volumes, but they persist independently of your instance. So, just like imagine with the Elastic IP, we could have, stopped or even terminated an instance and started a new one, but we can still attach the same IP, the Elastic IP address to the instance. So it's, independent. It persists independently of the instance itself, which was a huge advantage, right? In the case of failures and that kind of stuff, to be easily able to switch them up. The same thing with the ENIs, the Elastic Network Interfaces. So that's what the term elastic essentially means. So that's why these are called elastic block store volumes, because they're elastic. They're independent of the instance. Any information you store on it will be independent from the life of the instance itself. And since they are raw unformatted block devices, right? Remember, they're block level storage volumes. You can create a file system on top of these volumes, or you can use them in any way you would use a block device, right? Such as a hard drive. And you can also dynamically change the configuration of a volume attached to a device. So this is a huge plus, right? You can dynamically change, you can do all of that dynamically while the EBS volume is attached and being used. Now, I want to give you a little bit more information on EBS because it's such an important topic. It's recommended for data that must be quickly accessible and requires long-term persistence. So those are the two key terms: quickly accessible, long-term persistence. Quickly accessible in the sense that, it'll be attached directly to your instance. So it's as quick as you can get, right? Whereas, with S3, or if you have an RDS instance set up or something like that, that's going to be located somewhere else. And obviously there will be some latency, so on and so forth. So, the fastest accessible storage device that you can set up for your EC2 instance will potentially be an EBS volume. And for long-term persistence, again, instances aren't themselves, they might be temporary, they might shut down, they might reboot, you might stop them, terminate them, whatever, you plan on doing with them. Any storage that comes, pre-allocated with the instance, something like an instance store, is not persistent. It won't stay with the instance forever. You might lose it depending on the different actions you take with it. And so this is why EBS is also a huge advantage for data persistence. Now, it's particularly well suited for use as the primary storage for file systems or databases, or for any applications requiring fine granular updates and access to raw unformatted block level storage. So again, there are a lot of use cases here. This course is not meant to cover all possible use cases, but those of you in your different domains will know which of these will be best for your use case, right? Whatever you need, you're able to do it. You just need to know the options, which I'll show you in this course. Now, it is well suited for database style applications that rely on random read and writes, and for throughput intensive applications that perform long continuous reads and writes. So again, this will depend on your volume type, which we'll cover shortly. And basically with Amazon EBS, you pay only for what you use. That's the advantage of having a cloud service. You just pay for what you use. That's it. So it's very much like an EC2 instance in that regard. And you don't have to pay for, a whole hard drive. If you're not using it, you're just paying for what you're using from it. And this is a huge advantage. Now, here are some features of Amazon EBS. So EBS volumes are created in a specific availability zone and then can then be attached to any instances in that same availability zone. So this means that you can create your EBS volumes, so essentially your storage, right? Storage devices independently of any instances, and you do not, this will increase the resilience and the availability and the robustness, etc. of your applications and your infrastructure, because you will not be dependent on an instance either to be running or to survive or whatever when it comes to your storage. You'll have an EBS volume, you'll have whatever you need on that EBS volume, and as needed you can attach it to any instance you want. And even in some, if you meet some criteria, if you're using the specific EBS volumes, etc., you might even be able to use a feature or a service of AWS that allows you to connect multiple volumes to, or the same volume to multiple devices, which we won't be covering in this video, but that's also possible. Amazon EBS provides essentially four different main volume types, though there are other ones like a magnetized type and so on and so forth, but these are the four that you really need to know, and we're going to be covering them in depth in the following video. They're general purpose SSD, which will be the most common one, and provisioned IOPS SSD. By the way, IOPS stands for input output per second. So how many input outputs per second there are, and then throughput optimized HDD, and cold HDD. So we're going to be covering these in depth, and you will need to know what are the advantages of each and the disadvantages of each. And each has their own purpose, their own use case, and it's very likely that you will see questions from these on the exam. It's a very typical AWS question. They'll give you a problem and they'll ask you which one of these would be the best for that particular problem or that particular use case. You can create your EBS volumes as encrypted volumes, and this will help you meet, if you have, certain companies, they have very stringent or strict encryption requirements for data regulation or auditing or whatever that may be, and you're able to meet those criteria. Again, we won't be going to too much depth. We will cover encryption, but when it comes to different encryption, the different encryption protocols and so on and so forth that exist, and compliance with them and so on and so forth, that's going to be up to you if your company needs it for you to research further. But it is possible. You can encrypt volumes, and when you create snapshots, they're automatically encrypted, and so there's definitely possibility for high security if needed. By default, they're already pretty secure, but there's a whole way of encrypting them that we'll cover as well. And you can create point-in-time snapshots of EBS volumes, and these will be stored on S3. So you will be charged for using S3, but it'll be the minimum charge of S3. S3 is pretty cheap, and you can really manage how you want the snapshots to be created. And these snapshots are by default encrypted, and you can also use this method to transfer your EBS volumes or to copy EBS volumes to different availability zones or different regions through snapshots, because you can create an EBS volume from a snapshot, which will essentially create an exact replica or exact copy of your EBS volume. And you can also view different performance metrics such as the bandwidth, the throughput, latency, average queue length, etc., as you would view any other health performance or whatever for an EC2 instance. So you can very closely monitor these metrics if needed. Now that's it for this video. This was just meant to be an introduction to EBS. EBS will be accessed through the EC2 service, so it's not a service on its own. you have to click into EC2, and it's going to be located on the sidebar. Let me just show you very quickly. So here we are in the console. We are located in Ireland for some reason. Let's go into US East Ohio. Remember, EC2 is region specific. So let's go into EC2. And here on the right, we've covered instances, instance types, spot instances. We've covered AMIs. We've covered security groups, elastic IPs, placement groups, key pairs, network interfaces. We'll be covering load balancing and auto scaling later on in the course. But here under Elastic Block Store, this is EBS. So this is where we'll be dealing with EBS. So we're going to dive straight into EBS volumes. So before we get into the various types of EBS volumes and how they differ, let's just go over again quickly, what they are and what their benefits are, basically. So remember that EBS volumes are durable block level storage devices that you can attach to your instances, and they're block level. They're block storage, so they don't come with any file system or anything like that. You're basically going to have to format the device if it, in whichever way you want to use it. And I'll be showing you how to set up a very simple XFS file system format on your attached block devices. So after you attach a volume to an instance, you can use it as you would use a physical hard drive. So essentially, it's just another hard drive that you attach to an instance, and you can just read and write from it, and that's basically it. They're very flexible for current generation volumes. Attached to current generation instance types, you can actually dynamically increase size and modify the provisioned IOPS capacity and change volume type, etc. on live production volumes, which is a huge plus, huge added flexibility. Also, the most important thing, persistent independently from the running life of an EC2 instance. This means that you can create an EBS volume independently of any instance, and you can attach it to any EC2 volume, and you can read and write from it, and then you can also detach it from that EC2 volume, and you can attach it to another one, or you could just keep it somewhere, or you could take a snapshot of it. You can store it. If it does support, multi-attach, you can attach to multiple devices at once. That's going to depend on your instance type and your volume type. If you terminate your instance, you can specify whether or not to terminate the EC2, the EBS volume, even if it's the default root device that's attached to the EC2 volume when you're creating it. And I'll show you how you can change that option. Obviously, you have to set it while creating the instance, but I'll show you how to do that. You can attach multiple EBS volumes to a single instance. This, the instance must be in the same availability zone, and there are some other criteria to allow for this multi-attach feature. You can't do it on all instance types, but you should definitely, if you're interested in it, just look it up on the Google Docs. And volume types differ in performance characteristics and price, and I'm going to be going over those in the following slides. So that's just a very quick introduction to EBS volumes. Now let's get into some of the benefits of actually using EBS volumes. So there are 5 primary benefits as stated in the AWS docs, and these might come up on the exam. So number 1 is high availability. Okay. When you create an EBS volume, it is automatically replicated within its availability zone. And this is to prevent data loss due to failure of any single hardware component. So you can attach an EBS volume to an EC2 instance in the same availability zone. After you attach a volume, it appears as a native block device similar to a hard drive or other physical device. And at that point, the instance can interact with the volume just as it would with a local drive, and you'll have to mount it, and I'll show you how to do that as well. You need some Linux administration skills there, but nothing too difficult, and it's easy to look up on AWS as well. And then you can connect to the instance and format the EBS volume with a file system such as ext3, or in our case we're going to be using XFS, or we're going to be formatting it with the XFS file system. And again, I'm going to show you how to do that. And then you can install applications, you can save data, you can do whatever you want. And if you attach multiple volumes to a device that you have named, you can strip data across the volumes for increased input-output and throughput performance. So high availability is definitely a huge benefit of using EBS volumes, and something that is sure to come up on the exam. Another benefit would be data persistence. So an EBS volume is off instance storage that can persist independently from the life of an instance. You continue to pay for the volume usage as long as the data persists. So that's something to keep in mind, right? The data on an EBS volume will be stored in an S3 bucket. And so you're going to be paying for that, if you take snapshots, so on and so forth. So EBS volumes that are attached to a running instance can automatically detach from the instance with the data intact when the instance is terminated. But you have to obviously uncheck the delete on termination checkbox when you configure EBS volumes for your instance on the EC2 console. And I'll show you how to do that. The volume can then be reattached to a new instance, enabling quick recovery. And that's, very, very, very good to, that's a very good feature to have to ensure that your applications are always, serving your customers and your users without a problem. And, if you do have a use case in which you want your EBS volume to be terminated or deleted on termination of your instance, you can also specify that. So, if there's a use case specific to that, you need. If you're using an EBS backed instance, you can stop and restart that instance without affecting the data stored in the attached volume. So that's also a huge benefit because, you're paying for the EC2 instance as long as it's running. So if you basically, with an EBS volume, you can basically stop your instance when you're not using it, but still preserve your data and only pay for the storage instead of the actual server usage. So that you can stop and restart that instance without affecting the data stored in the attached volume. And potentially you can terminate that instance even and start up a new instance and attach that volume to that as well, as I'll show you how to do. The volume remains attached throughout the stop-start cycle, so it won't get unattached as soon as you stop the cycle. So this will enable you to process and store the data on your volume indefinitely, only using the processing and storage resources when required. The data persists on the volume until the volume is deleted explicitly. That's something to watch out for. If you're trusting that the data will just be deleted, if you have some security feature that relies on that, that's something to keep in mind. And the physical block storage used by deleted EBS volumes is overwritten with zeros after it is allocated to another account. That's also very good, in terms of security. But if you are dealing with sensitive data, you should definitely consider encrypting your data manually or storing the data on a volume protected by Amazon EBS Encryption. And we will be covering Amazon EBS Encryption. So by default, the root EBS volume that is attached to an instance at launch is deleted when the instance is terminated. You can modify this behavior by changing the value of the flag or the checkbox delete on termination to false. It is checked by default. And I'm going to be showing you where you can find that in the wizard, the EC2 wizard. And so if you uncheck that, this will basically cause the volume to persist even after the instance is terminated. And this enables you to attach the volume to another instance. So that's when you have an EBS root volume that's attached to an instance by default when you initiate the instance or launch the instance. But by default, additional EBS volumes that are created and attached to an instance at launch are not deleted when that instance is terminated. And you can also modify this behavior as well. So data persistence is another huge benefit to keep in mind. Then we have data encryption. So all EBS volume types support encryption. And this is a huge advantage. For simplified data encryption, you can create encrypted EBS volumes from the Amazon EBS encryption feature, which I'll be showing you. And all EBS volume types support encryption. So in the following slides, I'm going to be showing you like the 4 main types of EBS volumes. They all support encryption. You can use encrypted EBS volumes to meet a wide range of data at rest encryption requirements for regulated or audited data and applications. So this will be, crucial for you depending on your company. And Amazon, basically they, this is not a security course, but if you are involved in the security operations of your, backend architecture at your company, Amazon basically abides by everything, all these standards and stuff out there. So you can definitely go and search for details on that if you're interested. Another benefit of using EBS volumes are snapshots. So Amazon EBS provides the ability to create snapshots, which are basically backups of any EBS volume, and write a copy of the data to in the volume to Amazon S3. And then this is stored redundantly in multiple availability zones. The volume does not need to be attached to running instance in order to take a snapshot. And as you continue to write data to a volume, you can periodically create a snapshot of the volume to use as a baseline for new volumes. And this is also a huge feature. When you create a new volume from a snapshot, it's an exact copy of the original volume at the time the snapshot was taken. We're going to be going over EBS snapshots on another video, so I'm not going to get into it too much in this video, but essentially think of it as the ability to create backups and just save the data that's on your volume redundantly. So it basically eliminates any chance of the data being lost, even in the case of your volume being deleted. And finally, flexibility. So live configuration changes in production are definitely doable. And this includes modifying volume type, volume size, IOPS capacity, and all of this without service interruptions, which is, amazing. Really, it's crazy. And, you can find out more information if you search for Amazon EBS Elastic Volumes, which we will not be covering. But yeah, so essentially, this is basically everything there is to the benefits of EBS volumes. Now let's get into the Amazon volume types. The Amazon volume types can be broken down into basically three main, categories. So, and these will obviously differ in performance characteristics and price. So you can tailor your storage performance and cost to the needs of your applications. The first main category is called the solid state drives, or SSD category. And this category is optimized for transactional workloads involving frequent read-write operations with small input-output size, where the dominant performance attribute is IOPS. Okay, this definitely deserves to be memorized, especially for the exam if you're focused on studying for the exam. Again, this course is supposed to be more of a practical hands-on course, but there will be a lot of you studying for the exam. So definitely worth memorizing. So there are basically two types, or two, SSD-backed volumes provided by Amazon EBS that fall into this category. And I'll be going over those in the following slides. The next category is known as HDD, and it stands for hard disk drives. And this is optimized for large streaming workloads where the dominant performance attribute is throughput. Okay. So again, this definitely deserves to be memorized. And then we have, the previous generation hard disk drives that can be used for workloads with small data sets where data is accessed infrequently and performance is not of primary importance. Obviously, AWS recommend that you consider current generation volume type instead. So we won't be going over previous generation volume types at all. The hard disk drives also have two types that fall into this category, which we'll also be covering. But again, the main differences are these two. So one is optimized for transactional workloads that involve frequent read-write operations with small input-output size. And the dominant performance attribute for solid-state drives is IOPS, whereas the dominant performance attribute for hard disks is throughput. So these are basically the two main attributes to consider when considering, storage, IOPS or throughput. And so your use case will have to depend on that. So you'll have to, based on your case, you're going to have to really think about what would be more important for you. Is it a database? Is it, live streaming? Is it data processing, etc.? And based on that, you'll pick between these two categories. Now, within these categories, essentially, we have, so within solid state drives or SSD, we said that there are two main types, and these are general purpose SSD, which are also abbreviated as GP2 and GP3. And then we have provisioned IOPS SSD, which are abbreviated as IO1 and IO2. So the general purpose SSD provides a balance of price and performance. Generally, it's going to be what's recommended for most workloads. And in most cases, you won't need to look elsewhere. But if you do want high throughput workloads, or low latency or mission critical, high performance type of storage devices, then you can definitely look at the provisioned IOPS SSD. And here we can compare basically the different types within SSD. So we have GP3, GP2, which are general purpose SSD, and then we have IO2 and IO1, which are provisioned IOPS SSD. And this table is from the Amazon documentation. So definitely, if you are interested in more details, such as burst capabilities and calculating throughput and that kind of stuff, go into the Amazon docs. I don't want to make this video too long. There's a lot of information to cover. But if you are focused more on the exam, I do advise you to go and review the burst credits and the input-output credits and, calculating throughput and that kind of stuff in the documentation. But basically what you need to know is that, general purpose SSD can be used for, or is used for, low latency interactive apps or for development and test environments. Whereas provisioned IOPS SSD is more for workloads that require sub-millisecond latency and sustained IOPS performance, or more than 64,000 IOPS or 1,000 MIB per second of throughput. Okay, and that's IO2 block express, which we won't be covering, but then we have IO2 and IO1 for workloads that require sustained IOPS performance or more than 16,000 IOPS input-output intensive database workloads. So you're going to need to decide. You're going to need to compare using this table. There are also the range of volume size for each, the max IOPS per volume for each, and these do come with some caveats, which I'll be showing you in the hands-on section. And these do not support Amazon AWS multi-attach, and the maximum throughput per volume, as you can see, so on and so forth. Again, no need to spend too much time on the actual numbers, because this is, you can look this stuff up when you need to, and if you are studying for the exam, you probably have your book or your resources or whatever, which you can use to memorize anyway. So this is supposed to just give you exposure to the different concepts, and so this should be enough for you. And then when it comes to hard disk drives or HDD, we again have two main types. We have throughput optimized HDD, which is ST1 for short, and these are a low-cost HDD designed for frequently accessed throughput intensive workloads. And then we have cold HDD, or SC1 for short, and these are low-cost HDD designs for less frequently accessed workloads. And again, from the Amazon documentation, you can have a quick comparison of the different volume types. They're both very durable, throughput optimized HDD is used more for big data, data warehouses, log processing, etc. Whereas the cold HDD is used for throughput oriented storage for data that is infrequently accessed or scenarios where the lowest storage cost is important. Okay. And they do have different IOPS and different max throughputs, and they also do not support multi-attach. Now, when you're actually calculating it, right, if you have a very critical application or use case and you really need to determine which of these 4 types to use, you're going to have to, again, first and foremost, consider your IOPS versus throughput requirements. And then based on that, you can select the cheapest one. So that's going to differ based on your requirements, but definitely you're going to just refer to, there's like a one page on Amazon Docs. If you just type in EBS volume types AWS Docs into Google, you'll find this one page that very succinctly summarizes for you all the different ways to calculate the different prices and different burst credits and that kind of stuff for each volume. And based on that, you'll be able to determine which one you need for your application.